Is that 5 years?
Yeah, yeah, yeah. This be in the center.
Yeah, like
I'll just see. Yeah, he's done.
the thing at the Zoom. It's there.
That sidebar can they change? Like it's not showing.
It's not happening, right? Like, minimize.
Yeah, it's minimized.
I think वहाँ से देखें.
हाँ एक बार उधर से check.
This is not connected to a projector.
ओ हाँ तो वो प्रोजेक्टर वाले को बोलो.
यहाँ HDMI. So now this will be connected to that.
तो मैं पॉइंट करूँ तो वो इसकी तरफ से करना फिर यहाँ पे.
कोई भी करे. Yes.
बदलो आगे पीछे. ओके वो वाला लैपटॉप में लगा दे.
So good morning, everyone. This is our project's name, Lumino Bats. I am Kalpana. This is our teammate, Vishesh, and she's Anju, and he's Pranav. So today, I want to ask you all a question. So how many of you are the fans of cricket here? Cricket fans, raise your hands. The slides are not changing. Google Slide. Google Slide. Okay. Like, but how do you know? Like, I want to.
You can just say next.
Yeah, just.
Yeah.
Okay, just. Okay. So for the inconvenience, so can you raise your hands again, the cricket fans? So I want to say sorry to you all, because today we are not going to talk about this bat, but we are going to talk about these bats. So our whole project is about that how light pollution affects the bats. So what is the connection between the light pollution and the bats? So firstly, we should all know the meaning of the light pollution, like what the light pollution meant. Light pollution is nothing but the inappropriate or the unwanted or the excessive light, artificial light present in an area. So firstly, the question, how does light affect animals? So I have written here only the 3 points, but there are many ways that light pollution affects animals. From the first point only, migratory patterns, this is self-explanatory point that it's related to the aerial animals and the birds, those who migrate. So firstly, the birds use the celestial cues to navigate themselves in their pathways, but because of the interference of the artificial light, they are disoriented from the pathways, or in other cases also, they are collide from the buildings also, and they also get some injured. So the second point is predator-prey interactions. So in somewhat way, the natural light disturbs the natural balance between the predator and prey interactions. So roosting is very important, as roosting is the place where the animals live, the habitat of the animal. So if the roost of the organism, the animal is near around the artificial light present at their area, so it can disturb the sleeping cycle of that organism, and also may cause the disoriented hatching of the young ones or the eggs that they are laying. So this is the major highlight of our presentation, our project, that how light pollution affects the bats. So I've written here the 3 points, changing of feeding habit. So the first point and the last point are somewhat interrelated to each other, changing of feeding habit and predator-prey interactions. So what happens when some of the insects are attracted towards the light? So it somewhat makes it easy for the bats to catch them, to feed on the insects. So the the second point is roost disturbance. So when the bats, so we all know that the bats usually make their roost in the dark places, like in the caves or in the buildings or the abandoned buildings or any dark spot near any house or the buildings. So if the artificial light is present near the roost of the bats, so as I've discussed earlier, so this can cause disturbance in their sleeping cycle, and in the future it can cause the changes in the behavior of the bats also.
It's not working though.
So I would like to call Pranav. He's going to tell you that what all kinds of methods did we use in our study, in our project to make it more successful.
All right. So now that we know our main question, how does light pollution affect bats? Now we have to make hypotheses so that, without making hypotheses, you can't just go on the field. You want to know what to actually study. So we have come up with 3 hypotheses. Uh, the first one being that it may positively affect bats because insects linger around light areas. So bats may feed more in light polluted areas. The second, it may negatively affect bats because, it makes them prone to predators like owls and stuff. So it's very negative for them. And the last one is kind of a neutral point. Few bat species are tolerant to light, while the others, like most of them, are not tolerant. So it still affects a large amount of the bat population. So now, before we actually start a study, we have to know what bat species we are working with. And we are, yeah. And we are working with these 4 species. The first one is the, uh, before one, yeah. Okay, so the first species we are working with is the Indian pygmy pipistrelle. Now, as it says by its name, it's smaller than the other bat species. Now, the second species we are working with is the greater yellow house bat, and it has yellow fur on its body. The third species we are working with is the naked drum tomb bat, and the last one is the mousetail bat, which its tail resembles to that of a mouse. So we are working with these 4 bat species. And now one more step before we go ahead with our study. Okay. Yeah. So one more thing before we proceed with our study is to actually plan out what sites we want to sample. So based on this study of how light pollution affects bats, we have taken 5 sites of different light intensities. The first site, which we have picked a high light intensity site. Then we have picked 2 more medium light intensities and 2 low light. And we'll be sampling data in these sites. Now, now we come to the actual bit where we learn how we recorded the bat calls. Now for this, we need a specific device called the bat detector. Now it's a little bit bigger than your average smartphone, and without it, bat ecologists won't even exist right now. So before we start recording, we few important points. We spent per site we have sampled 7 minutes, and a few important things to note. bat activity is actually the number of minutes in which a bat was recorded. It's very different from the other species because you really can't keep a count and you really don't know if it's the same bat that has been displayed on the bat detector or if it's a different one. And another important thing to note about is the feeding bus. It's a very fascinating thing about bats that whenever it detects a prey and it wants to eat it, it produces a very fast series of high frequency sounds. And it does that so that it can pinpoint the location of the prey and it does not lose track of it. And therefore, it feeds on it and it's happy. It has dinner. And as you can see in the chart over there, that chart is from a software called Audacity, which we have used to analyze the data. So the first echolocation, that's the normal echolocation of a bat. And as you can see, after the echolocation, okay, after the echolocation, you can see there's a feeding bus where it's very fast and it produces a high frequency very fast. And it keeps track of the insect and finally eats it. Now, after we have analyzed the data, we have made graphs, and now I'll call my friend Anju to explain the graphs.
Yeah. Now I am talking about our result. This pie chart. In this pie chart, we can see pygmy pister is more active in other species and mouse-tailed bat is least active. Now we talk activity index. In this graph, low and medium light intensity, all species were active comparison to high light intensity. Now we talk pygmy pister. Pygmy pister is more active in low light intensity comparison to other light intensity. Now we talk other species, greater yellow house bat and tomb bat. These species were active in medium light intensity comparison to other light intensity. Now we talk mouse-tailed bat. Mouse-tailed bat is not active in high light intensity. Now we talk in this graph feeding activity. Pygmy pister is more active in pygmy pister, more feeding activity in low light intensity comparison to medium light intensity. Now we talk tomb bat. Tomb bat is more active in medium light intensity. Now I invite Vises for result conclusion.
So here is the conclusion of our study. So our first conclusion is that there are some species that can be actually benefit from the light pollution. Like we can take examples of tomb bat and greater yellow house bat. As the light intensity is increasing, their feeding activity is also increasing. So, but there is a limitation that they can be actually benefited till the medium intensity of light. So here comes our second conclusion that bats can tolerate light intensity at some extent, but after that their activity deteriorates drastically. This graph is representing my second conclusion, and that is the picture of a bat that is feeding on an insect. So next is our future directions. Future direction it's all about that what we would have done if we would we have had more time money, and access to some more sampling sites. So first future direction is that data collection across seasons. If we had more time, we would have collected more data across the seasons to verify our results that is it true for all the seasons or is it true for different for different seasons. Second is more sites available for light intensity. In our campus, we had only one high light intensity site, so we would have gone to we could have gone outside and collected some more high light intensity samples. And third future direction is that there are many other ways to carry out the study except recording. Like biological method, we would have studied that how light pollution affects bats' sleeping cycle, and monitoring roosting sites. We would have monitored their roosting sites at how is it true that light pollution affects the abandoning of roosting sites of bats. So thank you all for listening us. Now I hope that today when you head towards your mess and for having your delicious dinner, you all will take a glimpse of this beautiful species, this beautiful creature over your street lamps. Thank you.
Thank you so much, Luminobats. And can we have a huge round of applause for our first presentation? And do we have any questions for them? We can be very, we have 1 minute for that because we are already behind schedule. Any questions? Yeah. Okay, I think we don't have any questions. Thank you so much. All right. Now I want to call upon stage our next group, which is called, very interesting name, BLM, Bat Lives Matter, where we have Meenal, Namrata, Nancy, Samit, Sonakshi, and Sneha. Can we have you here? And the title of their presentation is, How Do People on Campus Perceive Bats?
चालू है बंद कर दो मैं बैठूंगी
तो बंद देखो ये इससे
2 सेकंड होगा
Good morning, one and all. We are members of the group BLM, that is Bat Lives Matter, and we are glad to be here in front of you today. So, before we start the presentation, let's play a small game. So what we're going to do is, we're going to present a few pictures in front of you, and you all have to guess which one is a bat, which one is not a bat, or which one is just a Photoshop picture and is not even a real animal. Now, I'd request the ecology students to not prompt the answers. You can answer, but just don't prompt them, okay? And also, here's the deal. We have a time constraint, so I'd request all of you to raise your hands to answer. So if you think it's a bat, when I ask you, just raise your hand, okay? Let's get started with the game now. Okay, so do you think, who all thinks this is a bat? Raise your hand. Okay. Who all thinks this is not a bat? Okay, and who all thinks this is just a photoshopped image? Okay, great. Now, move on. Yeah. Who all thinks this is a bat? Okay, now who all thinks this is not a bat? Okay, and who all thinks this is just a Photoshop? Okay. Now, what about this? Do you think it's a bat? Raise your hand. Who all think it's not a bat? Okay, is there anyone who thinks it's a Photoshop picture? Okay, great, next. Now, who all thinks this is a bat? Who all thinks it's not a bat? Who all thinks it's just a Photoshopped image? Okay, next. Now, is this a bat? Okay, who all thinks this is not a bat? Okay, who all thinks this is just a Photoshopped image? Okay, great. Next. Now the last one. Who all thinks this is a bat? Okay, who all thinks it's not? Okay, and who all think it's just a Photoshopped image? Okay, great. So now to the answers. So you were right and wrong. So the first one is a bat. Most of you were right about that. And it's the fruit bat, and it's the most widespread bat, even on campus. The second one there is a hammerhead bat, and it's most widespread in West Africa. The third one, most of you were correct, is not a bat, it's a kangaroo. The fourth one is a bat, and it's known as the horseshoe bat, and it's widespread in Europe, Asia, Japan, and Africa. The fifth one is not a bat, and it's a colugo, which is a gliding animal that you see in the forest of Southeast Asia. And the sixth one is a bat. It's known as the wrinkle-face bat, as you can see, and it's found in and around Central America. So I hope you got your answers. Okay, so that was a fun game. I hope you all had fun. But now, on the serious note, one thing that we must observe after this game is the extreme lack of knowledge that we all have about bats. If the same quiz was about dogs, we'd all probably know the different breeds of dogs. But as it's about bats, we're all mostly clueless. What we don't realize is that our lack of knowledge about bats affects their conservation. And so, it's very, very important to understand how these species are perceived by humans. And that is the very core of our project. Today, me, Sneha, along with my teammates Samit, Nancy, Namrata, Sonakshi, and Meenal, present to you our study on human perception of bats. So now, how did we study the human perception of bats from various people? It's simple. We just interviewed them. We interviewed over 50 diverse people all across campus. We also carefully curated a questionnaire, keeping in mind the exact type of questions that would be needed to understand and study the knowledge of the respondents regarding familiarity, conditioning, and conservation knowledge. So with a good set of questions, 18 in total, and after 50 interviews, the obvious tasks of compiling, sorting, and analyzing the data took place. Now, we can't present all the questions that we asked our respondents, but we have handpicked a few important ones and will be presenting them in front of you. Now, I would like my BAT friends to take over. Thank you.
Hello. So this is a bar graph that we have made, and so this question helps in understanding the level of familiarity that people have about bats. So we can also also record the amount of knowledge they have about them. So most of you know that these are so most of you think that these are mammals. So there are many people who think that they are birds. Yes, they do. So yes, they do look like birds, but they are so yes, they do look like birds, but but they are mammals. So I mean that we should know some information about them. And now I would like to call my another bat friend.
Hello everyone. From this data, we can conclude that there are more people who doesn't believe about family believe about me, and there are more people more. Hello everyone. From this data, we can conclude that there are more people who doesn't believe about me, and there are more people who have negative belief about me, and less people who have positive belief about me. But why am I so bad that there are more negative belief and less positive belief? So. Yeah. Now I would like to call my another.
Okay, so this graph shows your perception for me and my group members. Some of you think of me as, harmful creatures, and some of you think of me as useful one. And some think of me as a specious fellow too. So, by the way, hello, I forgot to say that. So let's come back to the topic and know how and on which basis you people have categorized me between harmful and useful creatures. The blue part is showing why I'm considered to be harmful, and it's just because sometimes I go for hunting, and because of my weaker eyesight, I hit someone like this, and after that people say that I'm bad. It's not like that. I'm a bad, I know that, but it doesn't mean I'm bad. And while there are some people who think I'm useful, they don't know the reason why I'm useful. We play important role in pest controlling, pollinating plants, and dispersing seeds. Still, we face threats from you, and all of you. And to carry on this topic forward, I would like to call one of my other friend, bad friend.
Thank you. So just now you met my friend Namrita, who is a bat, and learned why are we useful and harmful. So let's have a journey with me. You can see that graph which shows, okay, tell me one question. Though you know that we face a lot of prejudice, hunting and habitat loss, then why don't you put any effort to protect us? Now, because of these issues, we face a lot of problem. Look at the pollution graph, that one. I know these humans should be appreciated for increasing the pollution and population both. Leave it. So, for increasing pollution, we are only affected by. It does not, you think that by creating pollution, we doesn't affect, it hampers every activity that we do. Why don't you ever consider our situation, poor us? And this is not finished yet. Look at, there is a graph for none also. Means some of you even think that we don't face any threats from human. Wow, great. And you should be saluted by us. And this is so wrong.
Okay, time for some myth busting. So, most common myth about bats, they drink blood. That's false. I mean, it is true, but only 2 species of bats drink blood, and it's blood of cattle. So we don't really have to worry. Second myth is that they're rodents. Bats are just mice that fly. That's wrong. They're actually more closer to hoofed animals. So you could say a bat is a cow that flies. That would be more closer than saying a bat is a mouse that flies. Okay, next. Bats are not blind. That the saying as blind as a bat, that's false. They can see, they have small eyes. They're sometimes poorly developed, but they can see. Next, finally, bats are not scary. This is more of an opinion, but bats, they're like harmless creatures. They're just doing their own thing, they're living their life. We just have to leave them alone. Okay, now the biggest problem. Humans in general have a bad perception of bats, right? Their appearance, scary appearance, their fangs, whatnot. We just overlook this, you shouldn't judge them based on just their appearance. Overlook this and, just leave them alone. Let them be. The myths that are passed down, like I said, the myth busting, most of them are not true. You can just read them and just see that they're not true. They're obviously not true. Lack of knowledge regarding bats. Yeah, we need to be more educated about bats. We can't just, see them as something that is scary and, not study them. They need to be studied, we need to know more about them, and we need to learn about them. And media portrayal, recent times, COVID has portrayed bats as the bad guys. That's not true. It could have been a lab-created experiment or something, but leave bats out of it. Okay, so a change in this perception is necessary. We need to change our perception fast. Okay, so the conclusion. Bats, first of all, help in the ecosystem, right? They disperse seeds, they help in pest control. Overall nutrition cycle, they're helpful. Second, bats are not harmful. When bats come in sweeping, they might hit you, but that's not their aim. Their aim is not to come, they come sweeping like this, they don't hit you, they don't want to hit you. They are basically finding insects, and sometimes they might rarely hit you. Bats should be understood, yeah. Bats should be learnt, studied, and understood. We shouldn't judge them by their appearance. They should be learned, studied about as any other animal. Like Sneha said, dogs, we know more about dogs than bats. That shouldn't be the case. Bats are just as, harmless. They don't do anything. They're just looked upon as a scary animal. Okay, now I just have a few suggestions for Ashoka. Ashoka should, host workshops to spread awareness about bats, so that not only to students, to faculty, staff as well. So everyone knows more about bats, nobody's scared, everyone feels safe around campus. And also more learning and research to be done on bats by students, so that, their overall general knowledge is, built. So that's it for today, but I would like to conclude with 2 words, that is, bats rock. Mic drop. Okay, I can't actually drop the mic, but pretend I did. I was gonna. Okay, thank you. Any questions? So any questions at all? Bat wings hitting your face. Stick to your face. No. That they have like that hook at the end of the wing, right? That might kind of hurt you, but see, when they fly to you, they're usually trying to avoid you because they know you're there. Like, they send signals, right? So they know you're there. You're also giving away a signal because you are a big object compared comparatively to that insect. So they know you're there, they're trying to avoid you, but sometimes they might hit you, and I mean, it's not going to hurt that bad. Any other questions? Yeah. Oh, the camera's here. Yeah, any questions? Where's the camera? Oh, this one. Oh, that one. Yeah, you're not in the frame. Okay. Sorry, any more questions? Okay, I think we're done.
Next we have, which is again, the topic is, which is Gen A by Gen Z, and they're gonna do a presentation title on resting and sleep behavior and rehearsals MACU. Please. Okay, so I would request the team, which is Abhinay, Adesh, Sriram, Ryan. Oh, sorry. Inakshi, Vidya, Navneet, Alyana, Krishti, and Rishabh.
You have to get it.
2 bananas in my bag.
You have to get it.
Arey, I'm speaking introduction. Wait. Where is Rishabh? Maybe grill bag में देखो.
Pointer. ठीक है?
You need pointer? No. My bag is green. 5 है ना? 5 है ना?
Slides में आगे.
Someone sit and do this.
They can control it from the
In a small town of Haryana, seemingly in the middle of nowhere. The rhesus macaque, the only other primate species here, apart from human beings, lives around Ashoka University. A dedicated group of budding primatologists embark on some monkey behavior exploration in the sweltering heat of North India. Whatever did they do, and whatever did they find? How are these intelligent, curious, and creative monkeys adapting to life in a city? Coming soon as a presentation near you.
A very good morning to all of you present here. My name is Navneet Kaur, and these are my team members, Alayna, Rishabh, Kristi, Vidya, and Inakshi. And together we are Gen A by Gen Z. So in the ecology class, we studied the behaviors of rhesus macaque monkeys over the past month. We collected data, went off campus to make certain observations of monkeys, like their movements or their feeding details, etc., and then did a data analysis. We have integrated the entire information in the form of a small presentation, which we are going to showcase in front of you today. So without any further ado, let's begin.
So what we just saw is the rhesus macaque. It's the most common species found in India. It is mainly found in northern part and the central part of India. It is an orange-brown primate that interacts with people very easily. So it is of two types. First is old world monkeys and the second is new world monkeys. So we were talking about rhesus macaque and it's an old world monkey. So let's start. So old world monkeys and the new world monkeys have some common differences. They differ from different places. Old world monkeys are from Asia, Africa and Europe, whereas new world monkeys are from South Africa and South America. They are from and the places like Madagascar. They are also new world monkeys have prehensile tails which help them to hold and grab things, whereas old world monkeys do have tails but they can't hold and grab things from that.
Now, these monkeys are also found just outside the campus, so we wanted to study them and their behaviors. After spending some time making observations, we primarily wanted to study their rest patterns. So we wanted to know that how much of their time do they spend resting, differences in rest patterns at different ages and sex, how do factors such as human disturbance shade and time of the day matter to them. So these were the hypotheses which we created. So for the first question, where do they rest during the day? So the hypothesis which we created was that they rest during the daytime where the place is cooler, the place which has shade, and the place where are more hiding spots, and the human disturbance level is low, and they are safe from the threats. And the other question was that how much time do different age or sex categories of macaques spend in resting. So according to our hypothesis, the pregnant female, the infants and the injured and the injured macaques rest the most, whereas female individuals rest more than the male individuals and juveniles rest the least.
So now let's talk about data collection. So, can I continue? So now let's talk about data collection. So we used 3 methods of data collection for a project: group scans, focal samples, and social surveys. So group scans are basically when you make observations of an entire troop across several 10 to 15 minutes intervals and jot down necessary information required for work, like their age, behavioral state, and their sex. Behavioral states are the events that a monkey undergoes or undertakes for a longer period of time. Then focal samples are when we observe one individual at a time for a specified period, be it 5 minutes, 10 minutes. Since we were observing them only between 3:30 to 6:30, so due to the time constraint, we were unable to fetch the information that what do they do in the morning or at night. The people of Sonipat village, they live with the monkeys. And so we thought that they would have more information about what happens at night. So we interviewed them to know about their sleeping habits and the other activities they do at night time. So these three methods helped us in completing our project and also proving our hypothesis. Over to Rishabh.
So this is an ethogram. It is a table of code and descriptions for various behavioral states. Now, we can see some of the behavioral states here. You can keep different codes for different states as per the need of your project. For example, we have RST for resting, PLY for playing, GRM for grooming, and so on. Now, we have some monkeys around us. Let's try and observe what they are doing. Now, the individual does not seem to be involved in any activity that requires energy and does not seem to be moving at all. We can say that it is in a clear state of rest. Right now, the monkeys are taking care of the body and skin. Some of them are doing it for each other and some of them are doing it for themselves. This can be considered as grooming. I have to switch, goddamn. Now, sorry, 1 minute. It's not, okay. And now we have the process of feeding. So, now that we understand how behavioral states works, let's try and analyze a group scan. In this, we can see that the first scan we conducted was at 5:30, in which we recorded a total of 4 individuals. We can see that the first individual was a female adult. It was moving. Thus, it had no feeding details. The human disturbance it was experiencing was low, and the substrate, that is where it was found, was grass. The distance to road was 5 to 10 meters. This way, we analyze several group scans and we draw conclusions.
Now comes the results. So first we have this time activity budget. Here, you can see different age and sex category, means you can see many of the macaques when they were in which behavioral state. So as it was the afternoon, we can see that many of the macaques were resting. So this is the time activity budget again, but now we have different age and sex category. So as per our hypothesis, we saw that juveniles and the female adults rest the most, followed by the male adults and the juveniles. So can I get the next slide? Because of our limited data collection, we were not able to analyze so much, but we saw that the macaques spent a peak in resting behavior during 5:30 in the evening. So now over to you, Vidya.
Okay, so since they were urban macaques, we wanted to know how shade played a role in their resting behavior. Here we can see that most of the macaques rested in natural shade. For 95% of the macaques rested in the natural shade, while 3% in the anthropogenic shade like sheds, roofs, anything man-made, and 2% which rested in direct sunlight. And so here we can see that most of the macaques rested when it was very sunny. The reason being, when it's really sunny, the macaques can't do any physical activity in the blistering heat, so they just have to remain idle. And what do you do when you're idle? You rest. And social surveys, okay. We weren't able to observe the macaques at night, so we resorted to doing social surveys or interviewing the people in and around the village of Sonipat. Since they would have lived with the macaques, they would have known more about them. So the things we learned during the social surveys were the macaques usually rested in a shed near the highway. As you can see here, there's a macaque over there resting in the shed. And at times, they also slept on treetops and on people's rooftops. And we also got to know when they slept and when they woke up. And most of the people reported that they slept at between 7 to 8 p.m. and woke up at 5 a.m. And we also got to know that the first thing they do after waking up is forage for food. And some people also told that they snore at night. So we can't really prove this as we are short on time and we need to do more research. So yeah, and thank you very much. I think that's the end. I would like to express my heartfelt gratitude and appreciation to my colleagues, TA and Ishika ma'am, for her guidance, expertise. This would not have been possible without them. And we really enjoyed this module. Thank you so much.
Yeah, because you can't be seen right now. Hi, do we have any questions for them? Any questions? On Zoom, do we have questions? Okay, no. Okay, thank you guys. Can we have a huge round of applause? Okay, next up, we have a group called Bandar Bate, where we have Abhinay, Adesh, Shriram, Ryan, Bhumi, and Asfia, who will be presenting. The title of the presentation is How Rhesus Macaque Behaviors Influence People's Perception of Macaque. Can we please, yeah.
Hi everyone. Before I tell you more about our presentation, I would like to start with a fun fact about monkeys. They have opposable thumbs, which means they can probably beat you in video games. Moving on, this is the introduction. Our research covers the interactions between humans and the rhesus macaques, and it also talks about what behaviors of monkeys lead to people's perceptions of monkeys. Okay, so after researching and understanding about monkeys, we had two ideas for our final presentation. We could do a behavioral study like the last group did, where we understand how monkeys react to certain situations, or we can do a perceptional study where we understand how people feel about monkeys. We went with the perceptional study. So our project is very closely linked to social science. There are many aspects of social science in our project, like people's perceptions, people's past experiences with an animal, and myths, beliefs, and folklore about the animal. Let's do an activity. I'm going to show you a few slides, and you need to raise your hand if you feel that way about monkeys. It will be really quick. How many people don't like monkeys? Okay, next. How many people find monkeys to be funny? Okay. How many people go crazy when they see monkeys? Okay. And how many people don't care? Okay. I would like to invite Adesh to talk more.
Now I would like to tell you that how our research was going on the monkeys, on the rhesus macaques. This is our small mind map, you can see here, and how we did our research outside Sonipat and in our campus. Yeah, next slide. And we have some research questions and hypotheses for our research, that how we will do work on our research. So we have done, and there was our first objective was that the pupils' perception about the rhesus macaques, that how they think about the monkeys and rhesus macaques. So first hypothesis for that question was that those are living with the monkeys from larger time, they had negative perception. And those are living with the monkeys from greater than 1 year, they also have negative perception. But those are not living with the monkeys, they have positive perceptions. And our second objective was how have people adapted to living with the monkeys. And third objective was the people's perception about the monkeys' behavior, that destructive behaviors and aggressive behavior, feeding on human feed will lead to more. And for this second hypothesis was parental care, social dynamic within the troops will lead to more, means how they lead their groups. And last objective was the mitigation measures and what the people want in future. Yeah. So I would like to proceed to Sriram. Now he will tell us some interesting facts.
अभी मेरे दोस्त आदेश ने जो हाइपोथेसिस दी है उसके बारे में जानने के लिए हमने अशोका के अंदर एवं अशोका के बाहर गांव में जाकर कई इंटरव्यू किए। इन इंटरव्यू से हमने हमारे प्रोजेक्ट के लिए कई सारी सोशल साइंस की जानकारी इकट्ठी की। हमने टोटल 63 इंटरव्यू किए थे, जिसमें 40 इंटरव्यू अशोका के अंदर किए थे एंड 23 इंटरव्यू अशोका के बाहर गांव में जाकर किए थे। हमारे इंटरव्यू में मेन 4 कैटेगरी के क्वेश्चंस थे। हमारे इंटरव्यू में मेन 4 कैटेगरी के क्वेश्चंस थे, जिसमें पहला कि मकाक के साथ बातचीत एवं लोगों की धारणा, दूसरे में बंदरों के साथ रहना, एंड थर्ड वन इज बंदरों को दूर रखने के उपाय, मतलब, और फोर्थ वन इज मकाक के साथ व्यवहार, बंदरों के व्यवहार। इस तरह हमने हमारे प्रोजेक्ट के लिए इंटरव्यू के माध्यम से कई सारी जानकारी इकट्ठी की। अब मैं इंटरव्यू के डेमो के लिए भूमि, एसपिया एंड अबे को आमंत्रित करूंगा, वो आएंगे और हमने कैसे बाहर गांव में जाकर इंटरव्यू किए वो बताएंगे आपको।
थैंक यू श्रीराम। Hello, I am Asfiya and I am here for the LGP program at Ashoka University. For one of my science projects here, we are researching about the monkeys and would like to ask you some questions about them. This will take around 10 to 15 minutes. Would you have some time to chat with me?
राम राम अस्पिया जी, हजूर पूछिए जो पूछना हो।
Yes, sure. Thank you. So my first question is, how long have you been here?
जब से मैं पैदा हुआ हूँ तब से मैं यहीं पे हूँ। मुझे यहाँ पे रहते हुए लगभग 52-53 साल हो गए हैं।
I have been here for almost 2 years and I am doing my PhD now.
Okay. So what work do you do and what do your days look like?
जब से मैंने होश संभाला है तब से खेती और मजदूरी से ही जिंदगी कट रही है। रोज का वही काम है, सुबह उठना, खेत में जाना, काम करना और फिर शाम को आके खाना खा के सो जाना।
As a PhD student, my days are just normal as well. Like I go to my classes, then I study at the library. When I am free, I hang out with my friends. And after having my dinner, I just go to sleep. That's all what I do.
So I am seeing so many monkeys around. So do you know that how long have been the monkeys here and were they always here?
नो, बंदर यहाँ पे हमेशा से नहीं रहे। बंदरों को मैं पिछले 5 सालों से यहाँ पे देख रहा हूँ। पहली बार मैंने बंदर अपने पड़ोस के खेत में आम के पेड़ पे देखा था।
I don't know exactly from how many years monkeys have been seen here, but for the first time I saw them near the MPH inside the Ashoka. I was very scared. I just ran away from there.
Okay, so what do you think about the monkeys when you look at them?
इनके पास कोई काम धाम तो होता नहीं है, बस दूसरों को परेशान करना, दूसरे के फसलों को नुकसान करना, सामान तोड़ फोड़ करना। अगर कोई आदमी कोई लेके भी जा रहा होता है बगल से तो उसके पैकेट छीनना। ये बच्चों की तरह हरकत करते हैं, लेकिन ये भी क्या करें, इन्हें भी भूख लगती है। अच्छे ही हैं लेकिन परेशान करते हैं थोड़ा।
I think monkeys are left in their natural habitat because human contact changes their behavior. We should maintain distance from them, but at the same time, we should also respect them.
So, have you ever directly interacted with them?
एक बार जब मैं खेत में भुट्टा इकट्ठा कर रहा था, तब बंदरों के एक झुंड ने मुझ पे हमला कर दिया था। तभी मेरा बंदरों से आमना सामना हुआ था एक बार।
I have not interacted with them because I am very scared of monkeys. So whenever I saw them one time inside the campus and I just ran away from there.
So, what behaviors do you see the monkeys doing? Why do they do these things?
दूसरों के घरों से रोटी लेना और दूसरों के सामान को इधर उधर करना, ये आपस में झगड़ते रहते हैं। कभी कभी जब कोई इन्हें परेशान करता है या इन्हें किसी से डर लगता है तो अपने बचाव में दूसरे पे हमला भी कर सकते हैं ये।
I have seen monkeys snatching food and taking things from other people, and then also I have seen them taking care of their small babies.
So, which of these behaviors do you like and dislike?
बंदर भी हमारी तरह होते हैं, इन्हें भी ये भी हमारी तरह ही बर्ताव करते हैं। बंदरों का एक दूसरे के साथ प्रेम से रहना, इनमें आपस में बहुत प्यार होता है, जो कि अक्सर इंसानों के बीच भी बहुत कम देखने को मिलता है।
I like that whenever a monkey is giving a packet of chips, how carefully it will open and eat the chips.
Okay, thank you for the interview. आपसे बात करके बहुत अच्छा लगा. Now I would like to
So our basic summary inside the Ashoka was that we interviewed many people inside Ashoka and of different ages. So we found out that many of them had not interacted with the monkeys. And those who have seen the monkeys on the campus, they were scared to go and interact with them. Like me, I was playing the role of one of the interviewers we had. Like many of them were like that, they were scared with the monkeys, so they never interacted with them.
I was the playing role of one of the villagers, and we have hypothesis that the people who are living with monkeys have negative perception. But after the interviewing and some research, we got that this is not true. Some people whose main source of livelihood is agriculture, and sometimes monkeys interfere in their livelihood and destroy their crops, and they have only livelihood as the agriculture. So they feel some disappointed about the monkeys. Otherwise, people have either positive perception or the neutral perception about the monkeys. People have adopted living with monkeys in the village, and
was that there was a mixture of both negative and positive perceptions amongst the people inside and outside Ashoka. The people we interviewed outside Ashoka had more experience as compared to people inside Ashoka. People inside Ashoka has perceptions based on what they heard from people. But the interview we took out in the village, the people there has the experience more. So there was a balance between negative and positive perceptions, both about the monkeys. I would like to hand over to Ryan.
Let me explain what's happening here. On this side, we can see some behaviors of monkeys. These are the people inside Ashoka, and these are the people in Sonipat. We divided them into behaviors they like and dislike on both sides. So basically, these are the behaviors that people mostly liked, and these are the behaviors that people mostly disliked. So next slide. So the behaviors that people liked of monkeys is parental love and adorability and intelligence. Next slide. Next slide. And the negative behaviors are that they cause harm to people and they cause losses to people. Now we would like to present a video to you.
Until the video is playing, I would like to say thank you to all of the tutors of our ecology team. Thank you for making the ecology classes super fun. You are the coolest tutors. Thank you everyone for listening to us. I hope you find it interesting.
बंदर मामा पहन पैजामा दावत खाने आए बंदर मामा ढीला कुर्ता टोपी जूता पहन बहुत इतराए ढीला कुर्ता टोपी जूता पहन बहुत इतराए
Do you have any questions? Okay, seems like there is no question. Okay, ask.
Actually, I don't have a question on the content, but I have a question that when you were conducting this research and everything, were there any experiences that the monkeys harmed you or something like that?
In our batch, there was no such incident, but no, there was no such incident.
Okay. Yeah, Abhinay.
Some people shared their experience about the monkeys, and sometimes monkeys have harmed them. But they told that when you interfere monkeys, they will harm you.
Okay.
Otherwise, they doesn't interfere with us.
Okay, fine. Thank you.
Is your doubt clear?
Yeah.
So, yeah. So I would like the next team, which is emission investigator. I think so. They have a combined this thing project. So I request the team Aditya, Chand, Dinesh, Divya, Heenal, Sakshi, Shaurya, Soham, Tamanna, Vahri and Ved to be there. Yeah, it's a combined, so we have to calculate time. It's 20 minutes for them. Okay?
Hello, hello, hello.
तो different scenes होंगे.
We need the camera, this to be the background. It needs to be pointing that way. No, it's fine. It won't happen.
हाँ तो आप लोग थोड़ा आगे
Yeah, you do have the mic.
Do I have to say good? Do I have to say good?
Yeah, obviously.
Wait, so I'll say good morning everyone. We are team ambition. We are running up. Yeah, sure.
Start.
Good morning everyone. We are team emission investigators and today we are going to present our ecology presentation. As the global climate emergency unfolds and wildfires, cyclones and heat waves rage around the globe, our story begins. Ms. Prakriti, the chairperson of Climate Change and Sustainability at Anupam University of Liberal Arts, Faridabad, embarks on a bold initiative to find whether the university is carbon neutral or not. We just want to set an example, says Prakriti firmly. The university already has the carbon emission data. What they need is someone to find out how much carbon is stored in the trees. Do the residents know what they are doing to reduce their footprint? That's how detectives Khosla and Ghosla come into the picture. For Anupam University, the Eco Inquiry Agency is their only hope.
Video.
Joya, we cannot ignore our university carbon footprint. We need to take action.
Why should we be concerned about this? There are better people to handle this than us. Besides, we already have so many responsibilities on our head.
As professor, we have a special chance to make a difference. We have a moral duty to use our resources and opportunity for a positive change.
I feel like we're taking a burden that's too much for us. We have our roles as researchers and educators, but we should be only focusing on our own fields and excelling at them.
Have you thought about the reputation gains we could achieve? By addressing environmental issues, we become leaders in our field, attractive top talents, funding, and recognitions.
That's true. But you do realize we're alone, right? We cannot do this on our own.
We don't have to. I know someone who can help us with this. Professor Pragati. Good morning, Detective Ghosle. We have a job for you.
What do I have to do?
We're trying to make our university more sustainable and we need your expertise.
We are professor from the university nearby. We have all the data on our carbon ambition, but we need your help with something crucial.
We want to measure the carbon offset done by our trees, and we also need to find ways to reduce our food waste.
Can I have that? Carbon offsets, calculating footprint, and food waste also. That's quite tough.
Could you please show some interest?
Let's just ask the agency next door to do this instead.
I'd like to do that. I love challenges too.
Your book is upside down, by the way.
We're done.
Sit there on the Scene 3. Good morning.
Good morning.
I'm Detective Ghosle, and I'm trying to investigate a case related to food wastage. I have some questions for you.
Yeah, detective. I will my best to assist you. What would you like to know?
So, first, can you tell me your experience and your responsibilities in waste management?
I have been working in waste management for over 10 years, and currently my position is waste management supervisor, and my responsibilities include collect waste and
there's no need to be nervous. You aren't going to jail or something.
Yeah.
So, can you tell me how do you dispose the garbage and manage it?
After we collect the waste, we give it to the composters. And, yeah.
Oh, composters. Interesting. Do you have any more information about the people working in composters?
No, I am sorry. I have that's all information. Yeah.
Okay, thank you for your cooperation.
Thank you.
One done, 16 more to go. Now, where do we find this damn composter guy? There you are. You are as elusive as a leaf in the wind.
Do I know you guys?
You don't, but we do. We are eco sleuths from Eco Inquiry Agency, Detectives Khosla
and Detective Ghosla. Can you please spill some beans more like the compost? And what do you even do with the waste?
So I take the food waste, dance it with some leaves, and put it in my marvelous machine and make magical compost concoction.
quite interesting. And what do you do with the dry waste?
Dry waste, my friend. That's a mystery for some another detective.
That's the work for another day. For now, we should figure out how to measure the carbon content in the trees.
Yeah. After all, we'll get paid for that. Are you seriously trying to measure trees with that? It looks older than my grandmother. Don't you have anything professional?
Don't you worry, this may look like a jugaad, but we've been using these methods for years. I could have used a range finder to measure height, but that cost 1,000, and this is just a good.
Oh, I think we should hire people like her. We must save so much money.
Or maybe we can just fire people like you.
You think I'm useless?
I didn't mean to make you.
Shut up, I was just tying my shoelaces.
नींद में ही रहती है.
Here is the mechanism we use for measuring trees. This is a protractor with a string and a weight attached to it. We can measure the angle using this setup. A specific distance from the tree is taken and the angle is measured using the eye height of the user with the help of trigonometry.
Our team has analyzed the data you have uncovered. According to our calculations, there's a net carbon sequestration of 14 tons with an average of 32 kgs per tree. This leads to net carbon footprint of 5.27 million kgs. Despite the fact that 13% of the electricity comes from solar panels, electricity is still the main emitter of this. According to our findings, when planting trees, focus is not given to the carbon sequestration of the trees. Bohemia is the most commonly planted tree, yet it stores only 11% of the carbon. We propose that henceforth, rather than planting Bohemia, you focus on Ficus virens, more commonly known as the white fig tree. That stores 20%, that's 20% of the trees, yet it stores 28% of the carbon. By our calculations, replacing every Bohemia on campus with the Ficus virens would increase efficiency by 32%, an increase of 4 tons. Now my colleague Hinel will analyze the interview data.
So we interviewed total 18 people, and out of those only 3 were female and rest all were men. Basically their duties were included like being a buzzer, manager, chef, owner, waiter, employee, and a housekeeper. So all these people play a crucial role in managing the waste and transporting it on the campus. They've been here for around 3.5 years, and their daily hours of working are 9 to 10 hours. More than half of the interviews we did, people were not aware of the waste composting. We found only some people that told that the waste is composted. Some people also told that the leftover food is also sent to gaushalas. and some were literally unaware of that. Next, we also interviewed many people, and with that we got that they also suggested some suggestions. For example, we can have separate dustbins for wet waste and dry waste. We also got to know that if there are prepared meals, the employees consumes it, and the veggies are sliced appropriately as much are required according to the order, so that it does not goes waste. And mostly it was a qualitative data for us to analyze what people think about waste and what about their prior knowledge about waste management.
In the shadows of our everyday lives, a silent threat looms large, unaware to most, just like Khosla and Ghosla, casting a dark cloud over our planet, the rising carbon emissions. It's time we face the truth. Carbon emissions are suffocating our world, poisoning the very air we breathe, and altering the delicate balance of our ecosystem. This is not a distant nightmare, it is our reality, our present. And if we turn a blind eye, it will turn into our future, the legacy we leave behind for the generations to come. But there is hope, there is power within us. The power to change the course of this looming catastrophe. We cannot afford to stand idle to let inertia dictate our destiny. We must take responsibility, for our actions have consequences, and the consequences of unchecked carbon emissions are dire. We can champion renewable energy, harness the power of the wind and the sun, and unlock the potential of innovation to build a cleaner, brighter future. We must educate, inspire, and ignite change in the hearts and minds of those around us. Together, we can pressure our leaders to enact meaningful policies to hold polluters accountable. Together, we can pave the way for a carbon-neutral world. With this, we end our presentation. We would like to thank you all for listening to us, and of course, we could not have done this without our colleagues Priyanjana, Nageshwar, and Abhay. We also extend our gratitude towards this program for providing such an amazing opportunity. Thank you.
Oh, questions? You have a question. Okay. So could you talk about why you chose to focus on food waste? Yeah, please don't say that.
The project was to calculate the carbon footprint, and food wastage is one of the things which adds to the carbon footprint. And it was an important aspect of our project, so we decided to interview all of them who are related to this field.
More importantly, in the previous emissions that Ashoka University had publicized, it didn't rely on food waste. This is based on data provided by Ashoka University, naturally. So in the data publicized, it did not focus on carbon emissions caused by food waste. It instead focused on distance traveled and electricity. Hence, we chose to focus on the part that's not already been covered. Yes, Manu?
In the beginning, there was a device that you had to measure something of the tree. What is that used for, and what is the concept behind its working?
The concept is trigonometry, and the device is called inclinometer. We just use a protector to measure the angle that we make when we are observing the tip of the tree. Then we have the base, we have the angle, then we can easily calculate the height of the tree.
And so another question, segregating waste should come, is something that should come naturally to us and to the society. After research, what are some of the reasons you feel society today does not segregate waste, or they hesitate to segregate waste? Are there any reasons of odor, etc., or what?
So not exactly why, I mean, we don't know why exactly the society does not segregate waste, but one thing, one conclusion we have reached upon is that it's not only individuals, it's also the institutions. I think the waste that they generate is more than the waste that individuals generate, and maybe the individuals take it lightly because some of the institutions don't really follow their waste management policies, so maybe that can be a reason.
Also, this very prominent quote that waste is a resource if we segregate it at its source. So it's ideally segregating it at the source.
Yes, ideally we should be doing that. The main issue is people always prioritize convenience to themselves over others. So they are not many people are not willing to spend that extra minute of effort to segregate the waste. We need to first connect with them emotionally, get them to realize that they need to segregate the waste. Only then can we do it.
Got it. Thank you.
We had a newspaper which is related to our project, so if anyone wants a copy of it, please tell us, we'll give it to you.
Hi. Can we please settle? We are starting with microscopy now. Please settle down. Guys, please settle down. Okay, so next up we have microscopy modules coming in, presentations coming in. And the first group that is coming is called Lenses and Beyond, where we have Arya, Arth, Punya, Vedanshi, and Parimoksh. And the title of their presentation is New Design for a Microscope. Can we have you guys here? And also, can we have a round of applause for the microscopy presentations?
Rebel's team is third. So fourth is Shively.
Okay, I think we can maybe call the next group and then get. Okay, okay. Because we have. Okay. Start. Okay, start.
Imagine a whole new perspective where the smallest details Imagine a whole new perspective where the smallest details hold immense fascination. Good morning. Today, I, Punya Chaudhary,
I, Earth Single.
I, Arya Agarwal.
I, Vidanshu Agarwal,
invite you all to join us on an eye-opening voyage through our microscopy module. Microscopy is the study of the microorganism world through microscopes. Using these microscopes, we dive into the microscopic world that is right in front of us but is invisible to the naked eye. Microscopy has a variety of applications and benefits in diverse fields.
Now, talking about the benefits of microscope, the first benefit is visualization. It allows visualization and study of microscopic structures. It helps in forensic analysis. It helps in analyzing trace evidence and aiding in criminal investigations. It helps in nanotech advancements. It enables observations and manipulation of nanoscale structures, advancing nanotechnology research. It helps in understanding diseases. It aids in studying diseases mechanism, diagnosis, and developing effective treatments. It helps analyze materials, properties leading to the development of advanced materials. Environmental studies. It helps study environmental samples, assess pollution levels, and understand ecosystems' health. Now, talking about different types of microscopes, I've taken two major examples like of light microscope and electron microscope. In light microscope, we use the principle of visible light to illuminate, and in electron microscope, we use a beam of electrons to illuminate. Whereas, and in different types of microscope, it's bright field, dark field, phase contrast, and fluorescence.
Whereas different types of electron microscope are transmission electron microscope, also known as TEM, SEM, which is scanning electron microscope, STEM, which is scanning transmission electron microscope. The depth of field of light microscope is relatively larger, whereas of electron microscope, it's shallower. Limitations of electron microscope, its limited resolution and inability to observe ultrafine structures. Limitations of electron microscope is complex sample preparation and expensive equipment maintenance.
So these are the different type of contrast techniques which are used in light microscope. Bright field, most simple one, easiest to use. Light illuminates the background and contrasts with the sample. Dark field, which is slightly more complicated, and finally phase contrast. So now I'll be taking you through the light microscopes on how they work. So most of you have probably seen this diagram in your schools, but I'll be explaining it. So the magnification is produced by the eyepieces and the objective lens. The total magnification can be calculated by multiplying the power of the eyepieces with the power of the objective lens. Below that, we have the sample stage, is where your sample goes after you prepare it. Below that, you have the light bulb and the condenser. So the light bulb is basically the source of light which illuminates the sample, and the condenser is a special tool which gathers up all that light and focuses it on the sample stage, on the sample, so you get a brightly illuminated, well-contrasted image. Of course, then you have the fine focusing and coarse focusing knobs which help you see the image clearer. So our journey in the microscopy module was a fascinating one. We started with a very simple task in our first session, which is collimating a beam of light. Now, collimating a beam of light basically means making the light rays parallel to each other by removing any divergence, ensuring that they travel in a straight line. So how we did this was, by putting a source of light at the focal length of the lens, we can create a parallel beam of light and an image projected at infinity. Now the next step, the hardest step that we faced, was trying to achieve a specific magnification and learning how to focus. Right. So over in this setup, we actually had to use multiple lenses, fine-tune them to the exact millimeter, so that we could obtain a specific magnification of a scale in this case. So as you can see, we managed to obtain a 7 times magnified image of a scale, and it's a pretty sharp image. We also use a microscope tester to check how sharp our image was and how precise our tuning and adjustment was. This was probably the most stressful part of the program, but the experience was really rewarding as we felt like we could actually do something. And the final part was how we built the actual microscope. This is the final part of our project. So this is how the final microscope looks like. I did not expect it to look like this when I joined the program, but here it is. Now this was so much more complex than what I'd actually imagined. We used a combination of total of 5 lenses. Wait, 1 second, sorry. Oh, yeah. We used a combination of total of 5 lenses, a source of light, 2 pinhole apertures, and a camera as well as a sample. So the pinhole apertures were mainly there to decrease or increase the intensity of light as well as the field of illumination. Lenses were there to magnify and focus the image, and the source of light was to illuminate the sample. Instead of a screen, we used a camera which would capture the image and project it on the laptop. So instead of using a scale like we did for the magnification, we used actual samples obtained from Ashoka University. So these are some of the results that we found. The images may not look very good, but they were actually really fascinating to look at. We got a section of a bone cell. We also got a fern rhizome. Next in our remaining sessions, we learned about fluorescence microscopy. Now, in fluorescence microscopy, we got to look at some pretty amazing stuff. In like this, okay, both of these images are cells. Like I never expect cells to look like that, all bright colors and everything. Now,
yeah. So now I would like to take you through the most innovative part of our presentation, that is integrating VR, the virtual reality technology, in microscopy. VR is an immersive technology that simulates a realistic computer-generated environment, allowing users to interact and experience it as if they were physically present. I would now like to show you a short video on how VR works.
Hey! Aw, they're so cute! Oh. I will. Hey, I have a stick now. Come here. You have the stick? Yeah, go get it.
Imagine visualizing your microscopy samples under such an environment. Won't that be cool? All right, now let's talk about integration and potential working of VR microscopy. Through the integration of virtual reality visualization in microscopy, we aim to revolutionize the way we examine samples under a microscope by providing an interactive, personalized, and a user-friendly experience. By harnessing the power of virtual reality visualization, we can enhance the convenience and fascination of sample exploration. This innovative approach not only simplifies the process of sample visualization, but also captivates young learners, drawing them into the remarkable realm of life sciences and microscopy. Through this, we'll be able to interact and attract a lot of young learners to microscopy, which will eventually lead to development of biology and new developments and research in the same field. One of the world's most leading, can we move on the video? One of the world's most leading microscopy brands, Zeiss, we attended a lot of their GIS sessions. They are also coming up with the same kind of technology. We wish to collaborate with them in future. This is a part of the research that they have conducted recently. So this is basically the section of the rat's brain. And now we will see how can we visualize this under a VR setup. So you wear your VR headset, and then you start visualizing your sample. And this is how it looks like. The 3D view of your sample. Thanks. All right. Now, I would like to talk about why should we develop such a microscope? Are there some advantages or not? So the first advantage that potentially we think of having is an immersive experience in the microscopy world, which will enhance engagement and understanding of the field. The second advantage is remote capabilities, which will promote collaborations and experiencing remote collaboration and education. So basically, a person sitting here can collaborate with a person in the US and can visualize the same sample under the same circumstances. They can move the sample by using their hands, eyes, and a lot of features. The third feature is flexible exploration, which will enable users to navigate and observe various samples from various angles. So they can move the sample, the stage, and they can have different fields of views. The fourth feature and the main feature is making the microscope more controllable. So just by using your hands and moving them in air with a joystick, you'll be able to move the field of view, and you'll be able to change its resolution, its samples, and everything. You can even lock a sample at a position, and you can visualize 2 to 3 samples in the same time by just moving your face.
Wrapping up, we like to conclude that microscopy offers an exciting and innovative way to explore the microscopic world. We encourage you to continue exploring the fascinating realms of microscopy and virtual reality. By delving further into these fields, you can contribute to scientific advancements and gain valuable insights into the microscopic wonders. Remember, the microscopic world holds a wealth of knowledge waiting to be discovered. Let's embark on a journey of scientific discovery and creativity. Bon voyage.
Now I would like to deliver the vote of thanks. I would like to thank all the people who were directly or indirectly involved in our presentation, and due to whom we are standing here and presenting our idea. First of all, I would like to begin with our instructors, Dr. Saurav Pal and Mr. Manoj Matthew. I would also like to thank our TFs, Megha Rai and Mayank Saini, and also all the TAs, Promiti, Arush, Vaibhav, and Drishana. thanks a lot for your help throughout the microscopy module. We enjoyed it a lot. Thank you. Yeah, so a microscope is more preferred over a foldscope in terms of research and everything, because you can change the objectives and you can have different magnifications. You can you can never try to achieve 1000x magnification using a foldscope, right? So, but you can do that under a microscope. You can move the sample easily and you can get better images. You can track objects and everything. So a microscope is always better. Like a foldscope can never replace a microscope, but till some extent for research purposes, like for our level, like the children, the teenagers, they can explore the world using the foldscope.
I'd like to add something. So you see, in a foldscope, there's only one type. You can only use a natural source of light or maybe an artificial source of light. So you can only achieve like a bright field type of contrast. But if you're using an actual microscope, you have like different types of filters, like polarizing light, DIC, bright field, dark field, and what do you call it? Phase contrast. Yeah.
Also, it's easy to work, like if you're working on the sample and dissecting it or something, so it's easy to work under a microscope than a foldscope.
Any other question? Yeah.
So in the starting, you were showing the differences between a light microscope and an electron microscope. There was the mention of depth of field. What's depth of field?
All right. So depth of field is basically the depth of sample that you observe. So basically, if you have a sample, let's say 1 nanometer long or some like in height, so depth of field basically signifies like the length of the field that you will be able to visualize. The depth, so basically the different layers that you will be able to visualize.
Okay, thank you.
You're not audible.
After you got the parallel beams, why was focusing particularly difficult for the team or in general too?
All right, so basically to get a perfect sample, like to get a perfect image and like a desired magnification, we need to place the sample at the focal length of the magnifying lens after the collimination of light. So placing it exactly at the focal length is somewhat difficult because we talk about the measurements in millimeters. So we have to be like much more precise than we are in the usual world. So that's something that's difficult.
What's I'd like to add on? So when we place it at the focal length, when we calculate the focal length of a lens, it may not exactly be 30, right? It might move either or that. So even once you get the precise measurement, even once you like use the formula to find out exactly what distance you have to place it, you still have to do some fine tuning to get that perfectly clear image.
Also, that alignment of the lenses is a thing, and it's just very complicated stuff.
And at times we use the aperture, so the aperture.
Any other questions? Yeah, sure. Do you need a mic? Can we have a mic?
Hello. Yeah. So you gave an overview of some of the different kinds of microscopy. Could you run me through what I mean, if each of these kinds of microscopy are useful for some kind of samples or the other kind of samples? Can you investigate different kinds of questions using or analyze different kinds of samples using different kinds of microscopy?
All right, so basically in the dark field, we visualize the sample under a dark background, and the sample is visible as some shades of white color. In the bright field, we almost get the exact colors of the sample. In fluorescence, we use a beam of electrons, like not really electrons, but like light source to excite some of the particles, and like they radiate energy, and then we are able to get different colors using different sensors. We filter out different wavelengths of light, and we do all the complex stuff. And yeah, that's all.
No, but what is it useful for?
Yeah, so like in fluorescence microscopy, let's say you're trying to find you only want to see a certain part of the cell, right? So if you only want to, let's say, see the mitochondria, then you inject a special chemical in the cell, which will so that when light is passed through, it will only excite the chemicals present in the mitochondria. So you get like this in terms of fluorescence microscopy. Bright field microscopy is the most simple basic type. Dark field microscopy may be used for other samples and like so on.
Like the samples which are transparent or white are not like particularly studied in bright field because the light won't like pass through and we won't be able to get a perfect image. So they are studied under dark field and like.
Also, there's a phase contrast feature which helps us view unstained samples. Like all the areas where there is more concentration in the specimen, those will appear darker than the areas where there is less concentration. That is phase contrast.
Would you use it for the same kind of samples that that you mentioned, or some other kind of like? Would you use that to visualize some other kind of cells?
It actually depends on the why are we seeing that sample and what's our purpose of studying that sample. Like what do we exactly want to see in that? Closer. Yeah, that's it.
So please, can we have a round of applause?
So the next batch which we have is the micro magnifiers, and the present title is the Dig into Microscopy World and Its Importance. And in the team we have Mehak, Heenal, Meenal, Shravani, Antara and Alaina, all girls team. Huh? Amazing.
Hello.
Why are microscopes used अच्छे से बोलना है for research purposes? ये थोड़ा emphasis है for research purposes. ज़्यादा खींचना मत, but सिर्फ बोलना कि for research purposes it is used. मैं बोलूँ? तुझे बोलना है? नहीं वो पता नहीं क्या.
Hello, a very good morning to all of you. I am Alaina Maldar and I am along with my team. Today I am thrilled to stand beside you all and introduce my group and my presentation. So my group name is the Micro Magnifiers and our presentation's title is Dig into the Microscopic World. So these are my teammates, Meenal, Meg, Shravani, Heenal and Antara. So yeah.
Go up. Slide change करो. Wait.
Okay. So our project is on microscope. So I am going to start asking you that what is a microscope? So microscope is a self-explanatory word. Micro means small and scope is an instrument for viewing or inspecting. So a microscope is basically an instrument used for magnifying microscopic objects or any objects. We can magnify any objects and do research upon it. So why are microscopes used? So basically microscopes are used for research purposes and viewing tiny objects which are not visible from our naked eye. So I am going to hand over the mic to Heenal.
Okay, so
The other batch has already explained the simple microscope and its components. So I will just tell you that this is a simple microscope that we've usually seen in a lab or a school. But we were curious to know about the internal structure of the microscope. How we see the sample in the microscope, we were curious to know the inner structure, how it works inside. So for that, we made the inside part of the microscope in our class. Yes, so the process starts here. We started with the collimation of light. So collimation basically means when we make the beam of light parallel without any divergence with the distance, then we made a condenser to concentrate the light intensity. We also used a field diaphragm in order to have a field of view and an aperture to control the intensity. And then at last we obtained the magnified image and calculated its magnification, resolution, and numerical aperture. Yes. So this is the picture we making the microscope. So here is the breadboard, which is the stand for a microscope. Then we use different lenses. And then after calculation, we put it on a specific distance so that we get the best magnification and clear image. Here, this is the source of light. And we have a camera which is computing the image in the laptop. And this is how we made it. Yes, and this was the final product of our microscopy module. So we observed a beetle under a microscope. We also observed a grating. Also, this is basically a sample which is used for industrial purposes to check the resolution. And this is sorry. Yes. And this is the scale. This is the scale that we usually have, the normal scale. That also we observed it with our microscope, and these three were our results. Now I would like to hand over the mic to Shravani to explain different types of microscopes.
Yeah, so there are so many types of microscopes, but in this module we learned 4 types of microscope. First one is light microscope, stereoscope, fluorescent microscope, and confocal microscope. Yeah. Move on. Okay, so I'm going to talk about the light microscope. So light microscope uses light beam as a source of light to observe the samples. So like you can use natural lights also, or the LED lights that we get that are used for light microscope. Then we can observe live or dead samples, both samples in a light microscope. As compared to the electron microscope we can only observe the dead samples, but in a light microscope we can observe the live samples also. Then light microscopes are easy to install, and they are mostly in schools for students to use, and I think that most of you have used light microscopes in your schools or somewhere. So it's very easy to use, and it gives a pretty much good resolutions for us to observe. Yeah. Then, yeah, I'm done.
So this is the stereoscope. We took a sample of C. elegans and observed it under the stereoscope. So the good thing of the stereoscope is that we can have a 3D view of that. It has two objectives and 2 eyepieces, and we saw a fascinating image of the sample. Over to Mehak. Over to Antara.
Yes, so this is the fluorescence microscope. Fluorescence is basically the property of a molecule or a dye which when excited with a light source, with a light of one wavelength, it emits the light of a higher wavelength. and I would like to tell you about the sample of HeLa cells we observed under our fluorescence microscope. As you can see, there's 3 colors in the sample, and the blue colors is we have tagged the nucleus to be as the blue color, and the reddish pink colored things are called mitochondrions, and the green colored part is the cytoskeleton. And now I would like to hand the mic over to Mehak, who's going to explain us the confocal microscope.
This is confocal microscope. But I have a question. Why it is called confocal microscope, specifically confocal? So it is called confocal because it is called confocal because it captures the particular image that's given by conjugative focal plane. So it is called confocal microscope. The confocal microscope is different from the other microscopes because it's give a clear image, not any blur. This confocal microscope, we have a sample that's is this one. Let's play. Let's play. What happened? Okay, so we can see clear image by pinhole. Pinhole, now what is pinhole? Pinhole is a hole used in confocal microscope in the image size of the lenses to get cut off of the another lights. I mean, pinhole is like a wall. Pinhole is this one. This one is the pinhole by which this is our focal plane. Here some focus that is out of our focus, pinhole, this gone from there and pinhole obstruct it. Don't come to pinhole only come to allow only this focus that is on our focal plane. This is pinhole. So over to Meenal.
So we had a three-day workshop with Dr. Manu Prakash, and so on the first day we went to pond to collect samples, and then we made a foldscope and observed a worm which we took from the pond. So foldscope is a mini version of the microscope, and it is easy to carry. And it was very good to observe this sample under our own foldscope. Over to
What's going on? Okay. So it's been a great program for us, and the experience has been way more wonderful for us because the TAs have interacted so well. Actually, at this age, you only see under a microscope and observe and write observations, whereas when at this age, we all have got the chance to make our own microscope. Then it was hard to sit for 3 hours and just adjust the lenses to get a clear image. So we can understand the struggle of a scientist now. So this experience has been great, and at this age, getting the experience of making a microscope rather than just seeing under it, it just feels more, much lucky for us. Thank you.
So we were working with microscope since past 1 month. So we thought about writing something on microscope. So these are the few words which we wrote about it. So it is as follows. Some things in the nature are hidden from the naked eye. It's possible to see them under the microscope sky. Oh microscopes, your images are so clean. It unlocks the secrets of the world unseen. You make us visible the microorganism which are ruling their own kingdom. It's all possible because of a microscope's wisdom. Thank you.
Lastly, it was a great experience working with our instructor Manoj Matthews, Saurabh Datta, and our program instructor Megha Rai and Mayank Seni, and of course our TAs Arush, Pramuti, Vaibhav, and Rishana. Thank you for all the help that you've provided. We learned a lot from you, and we hope to take back from you. Thank you so much. And this is a team photo. Thank you. Any questions?
Yeah. Any questions? Oh.
What was your favorite sample under the microscope? Which one excited you the most?
So actually, we saw a sample under the confocal microscope. It was about C. elegans. We could see the eggs removing. Yeah, it was about C. elegans. We could just see all the eggs removing from the C. elegans, and it was dividing also. We wanted to place that slide, but it was not working.
So we took a worm from the C. elegans, and then we dissected it and put it on the made a slide of it, and then under a confocal microscope we saw it reproducing the eggs. So it was amazing to view those. So it was the correct time that we observed. So I think it was a lucky time that we observed that. So it was a great time observing that.
A microscopic version of watching Three Idiots ka final
Yes.
scene, huh?
Any more questions?
Can you move to the slide like where you were showing the foldscope thing, the sample that you observed? Yeah, the worm that you showed, like, can you please describe it? Which worm is it? And like, because I think it is a C. elegans.
No. So it was a worm found in the pond water. So we collected the pond water, and then from that pond water we found a worm. We don't know actually what worm it is, but we can describe. So we also made a video of it. If you want, I can share. But for the details, it was it had two heads, and it was a very thick worm. We could observe the thickness of it, and we could also observe the inner particles which were moving inside and making some processes and doing some processes. Any questions more?
Thank you. I don't think we have any questions.
Thank
Thank you, the
you.
micro magnifiers. Next up, we have Sukshma Darshak, and where we have Om Kumar, Mohammad Zuhaib, Shaurya, Vaibhav, Ansh Tiwatne, Ansh Jain, and Avi Jain. And the presentation of their title is A Dig into the Microscopy World and Its Importance. I'm so sorry. So sorry. It's interdisciplinary approach to understand microscopy. I'm so sorry.
So, hello everyone, good afternoon. This is Zohaib on behalf of Sukshma Darshaks, and our topic is interdisciplinary approach to understand microscopy. So, I hope you all know what does Sukshma Darshak means. It literally means microscopers, those who watch from microscope, and from this
So a microscope magnifies the image by placing the sample between the lens and the focus of the lens. This gives us diverging rays through the lens, and our brain thinks that the rays are uh, originating from a single point which is behind the actual object, which gives us a magnified image. Now I will pass the mic to Vaibhav to explain us the chemistry portion.
So, attention please. I am going to present how chemistry is involved in microscopy. So, I want to ask a question. What do you see here? Nothing? Basically, you can't see anything because I have kept the blank slide. And you can't see anything because there is no colors. I haven't used any colors to show anything. So, next slide. If we want to observe any sample under microscope, we need to make it very thin and transparent so that we observe the details. And we can't see any transparent things without adding colors to it. So for that we need stains to color it. These are some stains which are used in microscopy. Next. Ecosystem of living organisms under a microscope. Suppose we want to observe some micro creatures under the microscope. And we want to observe their feeding activities, their moving activities. We want to basically observe how they survive in their ecosystem. So for that we need to maintain ecosystem under the microscope. For that we have to maintain temperature and pressure, etc. So this is also a part of chemistry. Next slide. Material science. Material science is also a very important key of microscopy because since we are dealing with the micro creatures, we need to be very stable and very perfect to observe the details. So we need to use specific materials for building microscopes. So material science is also very important for microscopy. Now I want to hand over the mic to Ans.
Next slide. So what is biology? Well, biology is the study of living organisms and their vital organisms. So how do you observe something? How do you analyze something that is too small to see? Well, this is where microscopes come in clutch. Microscopes help us to study, analyze and visualize living organisms which are too small to seen by the naked eye. They can range from micro to macro level. We can see different levels of cells. There is a symbiotic relationship between biology and microscopy. Well, through microscopy we can see hidden details in a cell. And biology drives the need for further advancements in microscopes. So can someone tell me what this is? Well, this is penicillium. Do you know how it was discovered? Totally by chance. Like, there was a guy named Fleming. He went to a vacation leaving a plate behind in his room. When he came back, it was growing. Well, so discoveries of microorganisms in past was like so difficult, and it used to be so rare. But now in modern day, microscopes have revolutionized discoveries. You can just discover something by using a foldscope. You know, 99.999% of the microorganisms present on Earth haven't been discovered yet. So I hope you can find the cure of cancer. Or maybe not, I was just joking. And if you find something, which isn't been, which you think you haven't observed or seen before, be sure to record it, cause I'm sure it will lead to a new discovery.
These are C. elegans. Um, we used fluorescence technology to see them. It was seen in analog lab by the use of spinning disk microscope. So one more thing that in biology that microscope helps is studying the life cycles. Here we can study how cell division is occurring in a C. elegans. So microscopes also help us to study life processes and the morphology of a cell.
Now let us understand the significance of mathematics in the field of microscopy. So let's start with a quote by Alfred North Whitehead. All science as it grows towards perfection becomes mathematical in its ideas. So it is a testimony to the statement that mathematics is really important and plays a vital role in microscopy. So in mathematics, arithmetic, which is also known as the queen of mathematics, is very important in microscopy. Using arithmetic, we can do complex problems and we can also measure sizes and we can do many things using arithmetic and microscopy. So these are some formulas which we discovered during the entire course of journey of microscopy here. So it is a numerical aperture whose formula is n sine theta, and d represents the smallest distance between two objects. So it is basically used for the resolution, like how can we see two objects as two in microscopy. And these are some examples of resolution like 480p, 720 pixels, etc. Yeah. Now basic concepts in math. These are the concepts which we use in microscopy, and these are very basic. The list is so vast. Geometry, symmetry, trigonometry, etc. are used. Next. Yeah. So let's integrate mathematics and microscopy. Microscopy has many features like image analysis, image quantification and processing. So image analysis is basically there. Like microscopy is often extracting meaningful information out of an image. So the concepts such as pattern recognition, algorithms, statistical analysis are used. And calculus, linear algebra, and probability theory are also used in mathematics for these processes. Now other things we are going to understand are aberration correction, diffraction, and modeling biological processes. So what do you mean by aberration? Aberration is basically the imperfections in image and the degradation in its quality, like the image is not clear. And diffraction is basically when light waves encounter obstacles or pass through the small apertures. So calculus is primarily involved in these processes. Now let us see the diagram for understanding aberrations in a more detailed way. So in this diagram you can see that the light waves are scattered and they are not focused at one point. So for its correction, we use the mathematical models. Now, other domain of mathematics, which is trigonometry. We all know that it is basically for angle measurements, distance and sizes. So that plays a very important role in microscopy. Along with this, we use image rotation and alignment in microscopy for measuring the 3D angles. Now this is a formula, which I seriously don't know what it is. But this is just here to demonstrate the function of calculus, differentiation and integration in the field of microscopy. So this is known as Fresnel diffraction integral or the Rayleigh-Sommerfeld diffraction formula, which I hope to learn when I opt for microscopy in my future. So that is how mathematics plays a very important role in the field of microscopy. Now I would like to pass it to Ansh Devatne.
So I'll be talking about the use of computer science in microscopy. But before I proceed, I'd like to ask you, what do you think microscopy is all about? What do you spend the most time doing in microscopy? Anyone? Okay. So you look at some interesting samples through the lens, but also you spend most of your time analyzing the data you collect. Analyzing and documenting the data is like one of the more tedious parts of microscopy. And computers are all about crunching numbers and processing the data for you, right? So my computer science can really help microscopy over here. So data analysis, I'm sure a lot of you have heard of this. So in microscopy, there's, to name a few popular tools, Fiji and OpenCV. There are a few data analysis tools to essentially help you analyze your the images you take in microscopy. So maybe next slide, I'll show you an example. So this is a blood smear looked under a microscope. So does anyone know what this is for? Okay, this is to detect malaria. So imagine going through all of the red blood cells over here to find ones infected with malaria. That's going to be hard, right? So here, nowadays, what you can do, you can just get an anomaly detection model to just find the red blood cells infected with malaria for you. And this is to an impressive done to an impressive accuracy. Maybe next slide. Okay, well, this is slow. Yeah. So, okay. There's a few more applications of data analysis and programming in microscopy. So, researchers generally tracking cell movements, visualizing substance presence, measuring distances, speeds, and counting the number of cells. This is what researchers do on a daily basis when looking at images. So it's actually it's very helpful for scripts usually written in Python to do this for them. This expedites their workflows by a lot. I'm sure this wouldn't have been possible like 30 years ago. And okay, imaging. So this behind over here, this is a spinning disk confocal microscope that we have over here at Ashoka University. Essentially, what it does is a laser goes through the entirety of your sample in like a zigzag fashion and collects data from every single point in your sample. Now, all of this data needs to be stitched together to give you an image, right? This is where complex algorithms in computer science play a role to stitch together an image that will be helpful for you. And next slide, I'll show an example. So this is something called super resolution. Over here, what essentially happens, similar to the spinning disk microscope, over here your light source is actually rotating and your microscope is capturing multiple different images of your sample. And a complicated algorithm, which I'm not even sure how it works, puts together all of this data to give you an image more resolved than what your diffraction limit would have normally allowed you. And yeah.
यहाँ पे आपको एक बॉक्स दिख रहा है, इसको मैजिकल बॉक्स कहते हैं। आपको मालूम है इस मैजिकल बॉक्स में क्या है? चलो हम देखते हैं कि मैजिकल बॉक्स में क्या है। थोड़ा लेट बताया। अब मैं पूछना चाहता हूँ कि इसको मैजिकल क्यों कह रहे हैं? इसका जवाब किसी के पास? या इस एक तरीके से हम ये कह सकते हैं, सच बात है, फिर भी मैं थोड़ा एक्सप्लेन और करना चाहता हूँ। जैसे मान लो कि हम स्कूल में जाते हैं, स्कूल में हमें माइक्रोस्कोप मिलता है। मान लो किसी के पास बायोलॉजी नहीं है तो उसको मैक्सिमम 2 या 3 घंटे मिलते होंगे साल में माइक्रोस्कोप के पास, या अब उसको भी थोड़ा सा देखने की माइक्रोस्कोपिक वर्ल्ड कैसा है तो इसका यूज़ कर सकता है ना। और मान लो एक और कंडीशन देखते हैं कि हमारे पास पैसे माइक्रोस्कोप खरीदने के घर पे, ठीक है, तो आप माइक्रोस्कोप खरीदोगे, फ़ोन खरीदोगे, लैपटॉप खरीदोगे, क्या खरीदोगे? मालूम ना कोई माइक्रोस्कोप नहीं खरीदेगा। ठीक है, तो मेरा ये क्वेश्चन था कि हमें जो फोल्डस्कोप दिया गया है, हाँ सर ने दिया था, वो हमें क्यों दिया गया, किस मोटिव से दिया था सर ने हमें फोल्डस्कोप? हाँ नहीं मालूम। तो मतलब कि आप फोल्ड्स को बस घर पे ले जाके ये दिखाना चाहते हो कि हाँ इस फोल्ड्स को भी सर के सिग्नेचर हैं और वो उनके साथ फोटो खींच ली, ये दिखाने के लिए लेके जा रहे हो ना? हाँ चल नेक्स्ट। अब हम दिखाते हैं फोल्ड्स को में कैसी कैसी फोटोज दिखती है। अब मतलब कि आपने भी देख रखा होगा इमेजेस, कुछ ऐसी इमेजेस होती होगी। या नेक्स्ट इमेज, या अब मैं आपको एक वीडियो दिखाना चाहता हूँ जो मैंने पहली बार लाइव सैंपल देखा था फोल्डस्कोप से, तो कैसा था?
एल्गी जो उसमें वाटर के साथ उसमें कवर डाल दिया, वाटर को रिमूव कर वाटर भी डाल दिया। Can I see your thing? Can I see your thing? Find it, that doesn't mean you have discovered something new. But I searched everywhere I could. I also noticed that it's antennas. Yeah, what was that? Yeah. So search it online is cool. Ooh, that is something new too. Yeah, we have it. एल्गी जो उसमें वाटर के साथ उसमें।
या आपने भी देखा कि सर ने कुछ दिखाया कि यहाँ पे हमने कुछ नई चीज़ें देखी हैं। या जो लास्ट फोटो थी उनमें से किसी को मतलब वो किस चीज़ क्या थी? एनी ऑफ यू कोई माइक्रोस्कोपी का कुछ नहीं मालूम? क्योंकि सर ने कहा कि ना ये उन्होंने पहली बार देखा, तो अगर हम थोड़ा टाइम और लगा के देखें तो हमें भी कुछ नई चीज़ें मिल सकती है और बाई चांस वो हमारे फ्यूचर को बदल के रख सकती है। मैं सर को थैंक यू कहना चाहता हूँ कि उन्होंने हमें पढ़ाने के लिए, और मैं सर से आपसे एक और बात कहना चाहता हूँ सर कि मैं आपका विश्वास नहीं तोड़ूंगा, लेकिन मुझे नहीं लगता कि आपका विश्वास रखेंगे। और मैं अब आपसे और बात नहीं करना चाहता, इसलिए मैं अब जैन को बुला रहा हूँ आगे.
Now, first of all, I would like to thank our teachers, Manoj Matthew sir from Zeiss and Saurav Datta sir from Olympus for teaching us during the entire course of journey in microscopy. And I would like to thank my teaching faculties, Megha Rai ma'am and Mayank Saini sir. I would also like to thank my TAs, Promiti, Arush, Drishana and Vaibhav for helping us and teaching us something new. Like we got a very good experience through this module and got to know how scientists perform the experiments and make microscopes. Thank you. Now we would like to take the questions from you all. Any questions? Yeah. Yes, please.
I have a question about the computer vision aspect of it and integrating it with microscopy. So
Sure.
are there any open source data sets for microscopy image analysis that could be used for validation and training, and where could those be found?
Sorry, what for did you say?
Open source data sets for
Yeah.
microscopy image analysis for testing and validation mainly.
So actually, I myself was also looking for these. You can find a bunch of these on, if you've heard of Kaggle, you can find a bunch of open source microscopy data sets for, mitochondria images or, malaria, infected RBCs and anything pretty much. And I'm sure there's a bunch of other websites. If you just search, you'll find a lot of them online.
So I have a slightly philosophical question for you guys. So interdisciplinarity, of course, is very evident in the use of, of everything that you've done. But I was just curious, do you think that it is interdisciplinary because the other fields are contributing to microscopy, or do you think that actually microscopy is just a really versatile tool that has application in many fields? So is microscopy really a field of study, or is it more of something that can be applied to any field?
Maybe I'll let.
एक बार क्वेश्चन रिटर्न कर, दोबारा कुछ बोलोगे? समझे नहीं?
हाँ नहीं, सॉरी, मैं बस पूछ रही थी कि क्या माइक्रोस्कोपी एक्चुअली एक फील्ड ऑफ स्टडी है, या क्या माइक्रोस्कोपी एक टूल है, एक इम्प्लीमेंट है जिसके यूज़ से बाकी फील्ड्स को काफ़ी यूज़ होती है?
मैं कहना चाहता हूँ कि जैसे हमें बहुत सारी कॉन्सेप्ट्स है वो माइक्रोस्कोप बनाने में यूज़ आते हैं ना, तो उनकी सारे जो सब्जेक्ट्स है हमारे वो माइक्रोस्कोप बनाने में काम आते हैं, और माइक्रोस्कोप भी बहुत सारी चीज़ों में काम आता है. तो हमें लगता है कि वो सब सारी चीज़ को, बल्कि वो एक हर चीज़ में यूज़ भी होता है, हर चीज़ यूज़ होकर वो बनता भी है. या और कोई?
So we are with the last presentation from the microscopy batch, which is the smaller picture. And their presentation title is Major Concepts in Microscopy and our Journey Around Them. So in team we have Sia, Shresht, Arnav, Divya, Tamanna, Suhili, Krishya and Chand. So please, all of you, please be here now. This is next.
Wait.
Yeah.
A very good afternoon to one and all present here. We are very excited to be here. Today, I, Krishya Khajanji, along with my teammates, Shuli, Sia, Arnav, Shresht, Chand, and Tamanna, along with Dia. Tamanna's not here because she had to go to the infirmary. She's feeling sick. And today we'll be talking about major concepts in microscopy and our journey around them.
A microscope is a laboratory instrument used to examine objects that are too small to be seen by the naked eye. And the science of, I don't need it. The science of investigating small objects and structures using a microscope is called microscopy. Microscopes are mainly used in the field of biology to magnify small objects and specimens.
Okay, fine. It's there. Yeah, it's there. Yeah, go.
So, hi everyone, I'm Sia, and I'll be giving you an overview of what's like to study in microscopy. So, microscopy is a course that's usually taught to PhD scholars, so we are immensely grateful for this opportunity. We expected this course to mainly revolve around physics, but so we were surprised to see incorporation of topics like C elegance, coding, and even nail polish. We spend the first 30 minutes of class every day to understand the various concepts and formulas we will be using in the day. After that, we have to perform two crucial steps, that is the collimation of light and aligning the rails on the breadboard. No experiment of ours is possible without these two. We often have to recalculate and adjust a lot of the components used accordingly, but that's the beauty of this course. It's based solely on practical knowledge, and thus we get to learn things that we cannot learn from our textbooks. We often after this, the ending part is where we have to see if our observations match the given hypothesis. And I feel the great thing about this course is that our teachers do not expect us to provide observations that directly match the given hypothesis, and they encourage us to trust our gut and explore things ourselves. So I think one major takeaway that we took from this course was that we do not necessarily need to stick to the rules when we are exploring whatever lies in this vast world or under our vast microscope.
Okay, so how many of us over here like theory? Rote learning from textbooks. Can I have a raise of hands? Do we like theory? You like theory? Okay. How many of us like hands-on learning, experiments, practicals, conducting your own research? I mean, that's the exciting part of science, isn't it? So what we did for majority of our class is that we worked on smaller capstone projects that had increasing difficulty levels. This is called the microscope on rails. So basically in the setup, we had something known as a breadboard, which you can see over here. And we had something like a railway sort of a track. I hope everyone has seen railways, and the mechanism is the same. So we had 30 mm and 50 mm radius lenses mounted on top of these stands, as you can see. And we were able to slide them onto this track, which it functioned like a railway track. So what we did over here is that we used LEDs, lenses, camera, and along with aperture, field aperture and a diaphragm aperture, to sort of work on smaller capstone projects. And so we started off with something so easy, such as collimating light and figuring out the focal length of each lens. And then we moved on to more difficult projects, such as dark field imaging, and we learned about colors and illumination. So over here, this is something called sort of a grid, and it's basically what you do to sort of calibrate your microscope and check how good it is. And then over here, this is the sort of images we were able to create. And this is the first aberration you can see, these. So that's red, yellow, and then blue. So.
Which is the laser?
This is, yeah.
Wait, what?
Just the green.
Yeah. Okay. Now we're going on to a few various concepts in microscopy. Yeah. Yeah.
Okay, first of all, we have Kohler illumination. Kohler illumination is a method of illumination that generates an even illumination of the sample. It ensures that the image of the light source is not visible in the final image. Basically, most light sources consist of these filaments. We don't want this sort of image to finally be generated on the sample that we have. Therefore, we place a collector lens, a field lens, and a condenser lens, which create parallel beams of light, which finally intersect on the sample plane with beam pencils. This ensures an even illumination. Yeah. On the next slide. Yeah. Next slide. Okay, fine. Yeah. Numerical aperture, this is more of a mathematical concept, but the numerical aperture is a measure for the angular light gathering ability of an objective or a condenser. It is mathematically defined as numerical aperture is equal to n times sine theta, where n is the refractive index of the medium we're passing through and theta is the half angle. For example, if a light ray was coming from that direction and this is the condenser lens, then we calculate this half angle, and let's say the medium was oil, because that's usually used. And a greater numerical aperture is usually better for microscopy. Yeah, on to the next slide. Finally, we have resolution. This resolution is different from digital resolution. We're talking about optical resolution. It's used to describe the ability of a microscope to distinguish between details of a sample. Mathematically, it's defined as delta D is equal to 0.61 lambda divided by NA, where lambda is the wavelength of light used. For example, let's see here. This is a fully resolved image where two points are absolutely visible. This is just resolved, while this is unresolved, where both the points look to be the same thing. In general, unlike like digital resolution, we want a lesser change in delta D, as therefore it would mean that even smaller two objects separated from a smaller distance will also be visible as distinct objects. Yeah.
A stereo microscope. A stereo microscope is a type of microscope, optical microscope, that allows the user to see three-dimensional view of a specimen, otherwise known as dissecting microscope or stereo zoom microscope. The stereo microscope differs from the compound light microscope by having separate objective lenses and eyepieces. I was explaining it. A stereo or a dissecting microscope uses reflecting light from the object. It magnifies at a low power, hence ideal for amplifying opaque objects. The compound light microscope is a tool containing two lenses which magnify and a variety of knobs used to move and focus the specimen. Since it uses more than one lens, it is sometimes called the compound microscope, in the addition to being referred to as being a light microscope.
So now we are going to talk about a confocal microscope. So can I have the... Yeah. Thanks. So it's just like this, yeah. So we'll just talk about like the ray diagram on this, like how it works. So at the start we have this light source, which is the laser. It's like a very like coherent light source and like highly focused. So that passes through a pinhole here, which like removes any scattered light out. That is then like passed through the objective lens, which focuses it on the sample. Objective lens also collects any reflected or emitted light from the sample back, sending it through a scanning mechanism, which is not really shown here, but that scanning mechanism then like scans all the points on this to form a final image, sending that light through this final pinhole onto the detector where we can see it. That's like the general overall like explanation of this. A confocal microscope, like it can be used, it's a very specialized optical system. It can be used to generate very high resolution and three-dimensional images of specimens. Compared to like the stereo and compound microscopes, it is quite high in resolution. Yeah. Now about inverted and upright microscopes. So microscopes can roughly be ordered into two types based on the placement of the objective and the stage. Inverted with the objective is below and upright with the objective is above the stage. So inverted microscopes give an inverted view of the sample. They are easier to use. They have no limit on the height and weight of the sample. They have no risk of potential collisions of the sample with the lens. While upright microscopes give a straight view of the sample, they are more complex to use, but they have finite limit on sample height and weight, and are prone to collisions between the sample and lens. So here are inverted and upright microscopes images. Yep.
So I'll just discuss some techniques used in microscope. So there's bright field and there's dark field. Those are like just basically the opposites. In bright field, what happens is there's a specimen or a sample, and like light is passed through it, and it appears dark against a bright background because it's in a bright field microscope. And the opposite happens in dark field. What happens is there is a dark background, and when we put a sample on it, and when we put the scattered light on it, it appears bright on a dark background. For the fluorescence microscope, what happens is there is a property of fluorescent in a particular molecule. So basically, when we emit some kind of light on it, what happens is it emits back light, but like with a higher energy. So yeah, and it's used to see and observe specific like parts of samples. So if we have a wavelength of a green color, and we'll be able to see a yellow in this microscope.
So I wasn't originally supposed to do this slide, but Tamanna left, so I have to. So if I make a mistake, forgive me. A phase contrast microscope is a microscope is an optical instrument used for visualizing transparent or semi-transparent samples, such as living cells that do not absorb or scatter light strongly enough to be seen clearly with a conventional bright field microscope. So in a phase contrast microscope, there's of course a light source, and we have a condenser lens that the light emitted from the light source is focused on the condenser lens, and then we have the stage where we have a specimen, and on the objective lens we have the objective lens collects all the light that is passed through the specimen, both the deviated light and the undeviated light. And on the phase plate, all the deviated and undeviated light is focused for the eyepiece to receive the image correctly.
Yeah. I wasn't supposed to do this slide either because Tamanna isn't there again, but I'll do my best for this one as well. So I'll explain the ray diagram for this and then like explain why DIC is useful. So it's not very clear, but at the start we have like a light source. Obviously, it's supposed to be an unpolarized light source, which then goes through a polarizing filter, which polarizes it. It then goes through these prisms. I won't pronounce that name because I will butcher it, which basically separates the beam of light into two separate beams, which then goes into the converging lens, which focuses it onto the sample. That light is then collected by the objective lens, sent through another of those prisms, and then back through a polarizing filter and in our light detector to get the final image. So this can give us like contrast to images of specimens which have like little or no contrast when viewed using bright field microscopy. Yeah. Yeah. Thanks. That's all from us.
Next slide. A special thanks to our teachers and our TAs, Professor Manoj, Matthew, Ashish Pandey, Saurav Datta, and our TAs Megha, Mayank, Peacock, Promiti, Arosh Bucket Hat Guy, Trishana, and Vaibhav Jimbro Guy for their help and guidance. Bye.
Yeah, okay. Yeah, any questions?
Okay, do we have any questions?
Yes, so you spoke about DIC. So can you please elaborate, like, for what DIC is used specifically?
I'm actually not completely sure myself. This wasn't originally my slide to do. I researched on how it works, basically. Like, I gave like an example of it. It's giving contrast to like some specimens. I'm not sure exactly which specimens. I haven't researched on that. But it's able to do things that bright field can't do. I'm again not sure on which ones exactly, but yeah, yeah.
Okay, thank you.
Yeah, any other questions? Yeah.
Yeah, I was just waiting for the group picture. So thanks, guys. So based on what you said about upright and inverted microscopes, it looked like inverted microscopes had a clear edge over upright in every way almost, right? So would you agree with that? Or is there one way or another in which maybe upright microscopes are more useful?
Yes, so actually about that, upright microscopes can be used for like very specialized uses, and basically they can be used when there's like slide-based applications, which is like used in many, I think, forensic and historical, like when you're taking specimens like that. And it's also easier to like access the specimen that you're using and like manipulate that. So those are like two of kind of the advantages you can get with upright. There's more like other like specialized techniques that you can use with upright that can give you edges in special cases with upright microscopes.
Any other questions? Yeah.
Yeah, so there's a very big problem associated to fluorescence microscopy, that is photo bleaching. So how do you think we can like prevent it from happening, or how can we increase the time of photo bleaching of samples so that we can observe them for a greater time period and observe more things? Like any possible solution that you have in your mind?
Okay, so this is a very minor help, but Mayank, he's a TF. So for his PhD, what he does is he has to observe live samples, like they're usually wet samples. So what he does is he takes a slide, he puts a cover slip on top of it, and then he coats it with clear nail polish so that no air can enter inside it. So it makes it harder for that to happen, like to dry out. Oh, you mean bleaching? Oh shit.
Yeah. So basically, one of the things that you can do, of course, is to try to ensure that to take the picture itself of whatever we're observing, that time frame is very low, so that like we immediately get a picture and it doesn't get bleached. And in fact, you're talking, besides that, sometimes we require bleaching in our samples. So therefore we do it. There's separate techniques as well. I'm not entirely sure about them, but like, yeah. As in, it's not always a problem either. That's the thing. Sometimes you require bleaching in specific cases. Yeah. So, but we have certain solutions against them.
What about light samples? Yeah. Okay, yeah. So like bleaching is like kind of the biggest problem for confocal and fluorescence microscopy. So for live samples, observe it, and like usually in that the lasers are used at a very low intensity, and you don't have to spend all the time looking at each one, spending that time which can risk the bleaching, right? So with that helps with live imagery. But bleaching, yeah, it can't be completely avoided in fluorescence and confocal. It is a major problem in that, yeah.
Thank you.
Thank you so much. Now, yeah, we'll break for lunch. Okay, a group photograph. Yeah, yeah. Can we have a group photograph for the microscopy group? Yeah. So now we'll also be breaking for lunch and we'll resume at 1:45 p.m. sharp. So all the astronomy students, please send your upload your PPTs if you haven't still, and also request you to please come at around 1:30 or 1:40 at least, so that we can start on time. Thank you.
Okay.
Okay, we'll restart, not restart, resume our presentations with the astronomy module. And first up, we have the group Astala Vesta with Arnav, Shiuli, Vedant, Aditya, and Alithya. And the presentation of the title of their presentation is Marooned of Vesta. Over to you. Which one is yours?
Hello.
Did I pronounce it right? So why do you need?
I don't remember.
You can start. Take charge of this change.
Hello. So hello, I'm Shuli. Oh, okay. I'm Shuli.
I'm Alatya.
I'm Vedant.
And I'm Arnav.
And we're Team Hastala Vesta, and we're doing a presentation on the story Marooned of Vesta today. So to start with, we have the introduction. Next slide. Okay, so Marooned of Vesta is a short story written by Isaac Asimov in 1939. It's about three men stranded on what is left of the spaceship Silver Queen in the in Vesta's orbit with a year's supply of water and and a week's supply of food, but only 3 days of oxygen. The next slide. A captain's decision to save time by plunging through a field of asteroids rather than to skirt around the belt is to blame for the situation that left three men stranded in the orbit of Vesta. Vesta is a massive asteroid in the asteroid belt between Mars and Jupiter, with only 3 days left to live. Post the initial responses about their impending suffocation, the men come up with an idea to melt a hole in the water tank to use the pressure to propel themselves towards Vesta, where a small community of humans live. Though Marooned of Vesta is an amazing story, we have to see whether or not it is truly possible. The story was written in 1939 when the reach of technology wasn't very far and many assumptions.
It is being shared right now.
So the people online have commented that they're not able to see your presentation. They're asking, right?
It's not a party.
Okay. What's the laser pointer? No, the camera is only directed at the people. Yeah. Also the laser pointer is.
Let's just start.
Oh.
Let's just stick to this.
Next.
Just click if it's not working, the arrow.
Starting, sir.
Okay, we're starting again.
Okay, so hi, I'm Shuli.
I'm Alatya.
I'm Vedant.
I'm Arnav.
And I'm Aditya.
We're team Hastala Vesta, and today we're showing you a presentation on Marunda Vesta by Isaac Asimov. So, next slide. Okay, so Marunda Vesta is a short story written by Isaac Asimov in 1939. It's about 3 men stranded on what is left of the spaceship Silver Queen, trapped in an orbit of Vesta, with a year's supply of water and a week's supply of food, but only 3 days of oxygen. Next slide. So a captain's decision to save time by plunging through a field of asteroids rather than to skirt around the belt is to blame for the situation that left 3 men standing in the orbit of Vesta with only 3 days to live. Vesta is a massive asteroid in the asteroid belt between Mars and Jupiter. And post the initial response about their impending suffocation, the men come up with the idea to melt a hole in the water tank to use the pressure to propel themselves towards Vesta, where a small community of humans live. Though Marunda Vesta is an amazing story, we have to see whether or not it is truly possible. The story was written in 1939 when the reach of technology wasn't very far, and many assumptions made in the time have been proven wrong.
So our first question is, in the story it is mentioned that Vesta as seen from the porthole is about 300 miles away from the ship. What would be the size of the porthole considering the parameters mentioned in the story? How does it change if we consider the current data? Index for the questions are diagrammatic representations, given values from the story and assumptions, radius of porthole according to the current data, and appendix.
So to begin with in this question, a porthole basically is a window from a submarine to view stuff. And to begin with, we need to calculate the parallax angle for this question. A parallax angle is basically a semi-angle of inclination from the 2 lines of sight. So to do that, we use Pythagoras theorem, and since it's a right angle, we use the formula tan theta is equal to opposite upon adjacent. And since we have the radius of Vesta, that is the asteroid we're looking at, and the distance between the porthole and Vesta, we can calculate the angle formed, which is the parallax angle.
Next slide.
You're doing this.
You are doing this.
Yes,
you are doing this.
Okay, so for this question, the given values in the story is the average radius of Vesta, which is 100 meters, and the average distance between Vesta and the spaceship, that is 563.27 kilometers. The assumptions we're taking here to solve this question is that we have assumed the distance of Vesta from the porthole to be 1 kilometer or 1 meter or 0.5 meters.
So yeah, according to the story, and after all the calculations, the radius of porthole is 0.29 meters to 1.4 meters, and parallax angle is 31.88 degrees. And but according to the current data, the radius of porthole is 0.47 meters to 2.3 meters, and parallax angle is 49.98 meters. But the diameter of porthole is 4.6 meters, which is not possible to fit in a regular size room. So the given data might be incorrect in the story.
Okay. Yeah. On to the next question. Question 2. At what points in time will the position of Vesta, Jupiter, and the Sun be the same as mentioned in the story, Marunda Vesta, and at what intervals will such a situation occur? Just to give you a brief overview, could you shift to the next slide? Next slide. Yeah. We're just taking this data. The average distance between the Sun and Vesta is approximately 262.7 million kilometers. The time period of Vesta is 3.63 years. Average distance of Jupiter from the Sun is 778 million kilometers, and the time period of Jupiter is 11.86 years. Certain assumptions we're making: all astronomical entities in our calculations lie on the same plane. Since in the story it's mentioned that when the astronaut went out into space, he was able to observe Jupiter on the left, Based on this, we're saying that it's exactly 90 degrees to the left. We have a diagram in the next slide. Wait, just go back to the previous slide. Yeah. Also, we're assuming that the spacecraft is facing the sun, as it's mentioned in the story. All orbits are circular, not elliptical, and everything is upright with reference to Earth's north pole. Yes, on to the next slide. So basically, what we're saying is that the astronaut who went out of the spaceship, Silver Queen, and he saw to the left, he saw Jupiter. This is the radius of Jupiter's average orbit, and therefore we get a right angle. By calculating tan inverse, sine inverse, we get 63 degrees as our angle. Next slide. Now on to the method of how we're going to calculate this. First, let's take a look, we will take a look at the positions of Jupiter and Vesta at a specific point of time and judge the angle between them. This will be our initial case, and we have to get all the astronomical bodies into the particular configuration that we want, that we displayed in the previous slide. Then we will find out the change in angle between them per year. For that, we need to calculate the angular displacement of both bodies per year and take the difference. We have the time periods, therefore 360 degrees by time period. To illustrate this in more simple terms, I'm taking the example of linear velocity. Let's take there are two cars with velocity A and velocity B, where the first car is much faster than the other, where VA is greater than VB. Now, if we want to find the point of time in which the first car would come across and cross the second car, one thing we could do, could you go to the next slide? Yeah, is think of this slower car as having 0 velocity and take the first car as having a relative velocity of VA minus VB. Similarly, what we have done is by calculating the distance, the difference in the angular displacement between Vesta and Jupiter, as Vesta is much faster, we get that by dividing the total angle of difference in theta per year, we shall get the smallest time interval after this situation occurs compared to the first time. And finally, we will find the time taken between consecutive positions using the formula of synodic period, which is 1 by T1 minus 1 by T2 is equal to 1 by S. This will be further explained by, Adit.
The synodic period is the time required for the body within the solar system to return to the same or approximately same position relative to the sun as seen by this observer on Earth. So like as in the diagram, both the bodies start in in a straight line with reference to the sun and in the similar position but on the different side. So the synodic period is defined as the difference between the time period of the body closer to the sun and the body further from the sun. So 1 by T1 minus 1 by T2 is equals to 1 by S, which is synodic period.
So you understood the way we are going to calculate exactly at what time this position had occurred when the story was written. So starting with a random date, 24th September 2022, we got the positions of Sun, Vesta, and Jupiter on this date, and using GeoGebra, we got the angle between asteroid Sun and Jupiter as 23.7 degrees. Now we want, next slide. Now as Arnav explained, we found the relative velocity of Vesta with reference to Jupiter. That means Jupiter is gonna be static and Vesta is moving. So we want Vesta to be to complete the whole revolution minus that 63 degrees because we want this angle to be 90. Next slide. We did the calculation and we found that this 90 degrees can be achieved after 5 years and 85 days from 22nd September 2022. And the date we got was 24th May 2027, and the angle was quite close to 90. It was 78.9 degrees. Since the orbits are not circular, and they are not in the same plane. We were assuming that they are in the same plane and they are in the circular orbit. That's why we got 78 degrees. That's quite fine. Next slide. Then as, so we can say that, wait. Okay. Can you just go to the next slide? Okay. So as Shioli explained, we can obtain the same positions by getting the synodic period. So I calculated the synodic period, which came out to be 5 years, 85 days. That means this position can be achieved every 5 years and 85 days back. So we went back in time, we subtracted 5 years and 85 days again and again till we reached the closest time when the story was written, and we got June 1938. That was so close, it was 85.9 degrees. That's it. Thing.
So, thanks to our professors Sushant Konar and Professor Saurav Mitra, and our TFs Anantharan and among NRTs Aditya, Abir, Ayush and Tejas, and so hasta la vista.
Yeah, if anyone wants to see the exact method of calculations, we've mentioned it in the appendix. This is for the question 1, parallax. And these are the exact calculations of question 2, with the first one being that of calculating the first rate and the second being the synodic calculation. Yeah. Does anyone have any questions? Yes. Yeah. The next slide.
The radius slide. Yeah, so you have taken the radius of Vesta to be 100 meters, but it is actually 100 miles.
Yeah, that's I guess just written wrong, that it's supposed to be miles.
All right, so would the answer change or in the calculations?
We've made everything in kilometers out here. I think we just wrote the value wrong. We've made the appropriate conversions.
All right.
Yeah.
Any more questions?
Yeah. Any more questions? Yeah. Yeah. Okay. Thank you.
Okay, can we have a round of applause for Hasta la Vista? Yeah. Next up, we have Anjaneya, Reyansh, Om, and Gajendra.
Hello.
This is the one, right? This is the one. So what is this? This one? Yeah, that's the one.
Yeah, this one.
Okay, you can go this side. Wait, I'll just share it on Zoom, and then you can take over. Yeah.
पीछे जाओ हाँ wait shall we start
Do we have the pointer? No, we don't. चलो. अच्छा. Okay. ठीक है. See start.
Good afternoon, everyone. We are Daedalus De Patte, and today we're going to present an analytical study on the dangers of taking inspiration from the original Patta, Icarus. I'm Anjaneya Dani, and I'll introduce you to my fellow Pattas. This is Reyansh, this is Om, and that is Gajendra.
Next slide.
So today, we're going to be answering a few questions that struck our minds from the story Summertime on Icarus, which we were assigned for our final group project. The story was written by Arthur C. Clarke in 1960. Now, this is a story about an astronaut called Colin Sherrod, who was on a mission to explore the asteroid Icarus, one that orbits perilously close to the Sun, its surface a blistering inferno of burning rock. Now, in Greek mythology, Icarus was the son of Daedalus, or as you would say in Punjabi, he was Daedalus the Pattha. Now, Daedalus made wings of feather and wax to help him and Icarus escape from the maze they were trapped in. But he warned Icarus not to fly too close to the sun, or else the wings would melt and he would come crashing down. But Icarus ignored him and did exactly that, leading to his death. Now, Anjane will give you a short summary of the story.
So, Colin Sherrod was on a mission to explore Icarus. He and his crewmates traveled in a ship called Prometheus and used small space pods to explore the surface during the cold night. One day, Sherrod was repairing an instrument on Icarus and disaster struck. His space pod malfunctioned and crashed, damaging his radio. Sherrod was trapped and unable to call his ship as the dawn sun crept over the horizon. Sherrod knew the sun's punishing heat would soon kill him. In a desperate bid of survival, he dragged himself over the treacherous rocks, seeking any shelter he could find. The best he could hope for was the partial shade of a large boulder. As the sun rose higher, the temperature soared. Sherrod steeled himself till the end, but high above, a flash of light caught his eye. It was a large reflective sheet, and beneath it were his crewmates, searching for him. By some miracle, they had traced his fading radio signal. They snatched him from the jaws of death just seconds before the heat would have claimed him.
Now, the first question that came to our minds after reading this story was, what would be the temperature on the surface of Icarus during the day, given its composition of nickel and iron and its distance of 17 million miles from the sun? Now, to calculate this, we first made a couple of assumptions. We approximated Icarus to be a perfect sphere, and we also approximated it to be a perfect black body. So for any body that is in a thermal equilibrium, the heat energy that it receives is equal to the heat energy that it emits. So the first step was finding the heat energy that it receives due to the luminance of the sun. So let the energy emitted by the sun be Q, and the distance between the sun and Icarus be D. The radius of Icarus is R. So the formula for heat received is we multiply the total energy emitted by the sun with the ratio of the cross-section area of Icarus and the spherical surface area of Icarus. So doing that, we get our answer. We get the value of 3.37 into 10 raised to the power 11 joules per second.
Now, we need to find the average
Just read from here. Mass update हो जाएगा.
Now, we need to find the heat energy absorbed by the surface of Icarus, provided that its surface is made up of a nickel alloy. The albedo of an object is the fraction of light its surface reflects. Averaging various sources, we get 0.1 as the albedo for nickel iron alloy. The heat energy absorbed by the surface of Icarus would be 1 minus the albedo into the heat energy received, which gives us a value of 3 into 10 raised to power 11 joules per second. Now, using the Stefan-Boltzmann's law, which states that the light energy emitted from the surface of an object is proportional to the fourth power of the absolute temperature, we try to find the heat emitted and the temperature on the surface of Icarus. Sigma is the Stefan-Boltzmann's constant. So the heat emitted would be equal to the Stefan-Boltzmann's constant into the area into the fourth power of temperature, which gives us a value of 775 Kelvin, or approximately 501.85 degrees Celsius.
Okay. So our second question is, what is the acceleration due to gravity on the surface of Icarus? So verifying that it is 10 times less than 10,000 times less than that on surface of Earth. What is the speed with which Colin Sherrod crashed on the surface of Icarus? Considering the gravity of Icarus and his initial altitude of 90 feet. So here are the assumptions that we made. We assume that the entire asteroid is made out of iron and nickel alloy and has a density of 9,000 kilogram per meter cube. And second assumption is Icarus is a perfect sphere, as we took it in first question also. So, and the third assumption that we made was Colin Sherrod crashed to the surface of Icarus only because of the gravitational acceleration. So first of all, first step for it is we find out the acceleration a body would experience on the surface of Icarus due to gravitational force. So we let the density be p. So the mass of Icarus will be equal to volume into p, which gave us the equation 4 pi r cube into density by 3. For acceleration due to gravity, we got the equation as g into mass of Icarus by square, where g is the gravitational constant. So we got the equation as g into 4 pi r cube into density by 3 into r square. So which gave us the approximate acceleration as 0.004 meter per second square. The acceleration due to gravity on the surface of Earth is 9.8 meter per second square, which is 2,500 times more than that of Icarus. So second step was we calculated the speed with which Colin Sherrod crashed on the surface of Icarus. So we used the law of conservation of energy, which states that the total energy in the system can remains constant, which means it can neither be destroyed nor be created. So therefore we get that kinetic energy is equal to potential energy. With that we get the velocity as 0.85 meter per second square.
So now to conclude, on performing the actual calculations for the concepts in the story, we found that most of them were accurate. The author has done a great job to ensure the scientific accuracy in the story, especially considering that it was written 60 years ago. The story mentions that the temperature on the surface of Icarus at noon is 1000 degrees Fahrenheit, which is 550 degrees Celsius, and that matches with our calculations of 500 degrees Celsius. It also says that the gravity on Icarus was 10,000 times weaker than that on Earth. According to our calculations, it was around 2,500 times weaker, which is pretty close. It's only half an order of magnitude, and in astronomy, that's really not a lot. So, thank you. Thank you for listening. And we're open to any questions if you have them.
Okay, thank you guys. Can we have a round of applause for them? Next up, we have Shresht, Nimay, Rishabh, Agastya, and Rohan.
It's called, we have put it's in astronomy.
Okay. Yeah. So we worked on this story, Neutron Star by Larry Niven. Our group name is Parmanu Ki Vidut Rahit Kan Ka Tara, which is basically Neutron Star in Hindi. Our members are Agastya, Nimay, Rishabh, Ruhan, and myself, Shresht. So I'll give it over to Ruhan to start.
Our story was Neutron Star by Larry Niven, written in 1966. I'll explain the summary of the story. In this complex and intriguing story, we follow the narrator's journey as they encounter a series of mysterious events and characters. The narrator, along with the skydiver, a ship they are plotting, finds themselves millions of miles above a neutron star. They discover a distortion mentioned by Sonia Laskin before her death. The narrative also introduces the concept of general products hulls, mass product ships with transparent hulls, no reaction drive and retractable altitude jets. I'll explain something about neutron stars to you as well. Neutron stars got their name because their cores have such a powerful gravity. They are composed of only neutrons and protons, which make up most of the mass. They're a compact form of a star. In the story, BVS-1, the first neutron star is mentioned. In the end, the narrator's plan involves smashing General Products hulls into the neutron star at half a light speed. They reprogram the autopilot to facilitate the plan, but they face intense gravity and struggle to execute the plan. The summary only scratches the intricate narrative and its interconnected events. It is a tale of high stakes, scientific discoveries, mysterious forces, and interesting characters. I'll give the mic to Agastya for the questions.
So the first question that we wanted to ask are, what are gravitational effects of a neutron star at different distances? So this question has two parts. First, the explanation of the principles that we use for the calculation, and second, the real answer to how close can a spaceship or a human really get to the neutron star. So, in the story, the spaceship gets as close as 7 miles to the neutron star, which is very weird. We wanted to find out if that is even possible. Now, for a point object, the acceleration due to gravity can be written as capital G m upon r square. So, where G is the universal gravitational constant, m is the mass of the neutron star, and r is the distance between the neutron star and the body. So if we consider the point of the spaceship closest to the neutron star and the point of the spaceship farthest from it, then there's a difference in r, or the distance. Thus, the acceleration for the closer point will be more. It will feel as if the spaceship is slowly being pulled apart. So at what point does this pull become too much to handle if we assume that a human can take a maximum of around 10 g-forces, and assuming that the maximum pull a spaceship can take is around 100 g-forces. Note that 1 g-force is the acceleration due to gravity experienced on Earth. Thus, when we say 10 g-forces, we mean 10 times the acceleration due to gravity experienced on Earth.
Yeah. So now moving on to the second part of the question, which is the gravitational effect on the spaceship and how close it can get. So basically, we took the gravitational effect on the spaceship due to the neutron star at 1 million miles, since that's the original distance that the spaceship was away from the neutron star. So for the closer point that we showed in the diagram, we found that the effect was this much, the acceleration was that much, and the farther point, which is 91.44 meters away, the acceleration is this much. So it's like very close. We had to go in many decimals, and we found the difference was around 8 times 10 to the power minus 6 meter per second square, or in g-forces it's 8.16 times 10 to the power minus 7 g-forces, which is that's the gravitation on Earth. So this would not be even close to breaking the ship apart, so this is fine. For how close the ship can get, we just use this equation gm over r square minus gm over r plus 91.44 meters squared, because 91.44, as said before, is the length of the ship. And equated that to 100 g-forces. As stated before, we assume this is the force that will be required to rip apart the ship. And we found that the distance, the closest distance the ship could go to the neutron star was 3,200 kilometers or so. So it was impossible that the ship could have reached 7 miles, like within 7 miles of the neutron star. It would have broken apart much before that.
Okay, we also wanted to see how close a human can get. So here we assumed the distance as the distance between the head and the feet of a human. Took that as 1.83 meters or 6 feet. Equated that to 10 g-forces as we said before. And we got the distance was actually closer because of how small a human is in comparison to a spaceship. We got the distance as 1,910 kilometers. Okay, now on to Agastya for the next question.
So the second question we came up with was, if we are traveling at around half the speed of light, then will the colors of stars behind us, and how will they be perceived by us? And will the color change from blue to red if we increase our speed? So you can move ahead. So to first understand the question, we need to understand what's Doppler effect. So Doppler shift is a phenomenon that is observed whenever the source of waves is moving with respect to the observer. So first we need to understand what's the wavelength. So what a wavelength of a wave is. So it is the distance between the two peaks of a wave. And the frequency is the number of times a wave passes through a point. So basically, Doppler shift states that when the source is moving away from the observer, then the waves become more stretched. And because of this, the wavelength increases. And since the wavelength increases, it shifts to red. And the observer perceives this light as red. So we can move ahead. Yeah, so this is an equation we used to find out how the color shifts. So basically, the lambda observed is the observable wavelength of the color, while the lambda s is the original, while v is the speed of light, and c is v is the speed of the observer, and c is the speed of light. Yeah. So we can move ahead. So over here we have taken the observed wavelength as the wavelength of red, so 700 nanometers, and then we have taken half the speed of light, since the narrator in the story was moving at around half the speed of light, and our calculation gives that the original light was around 400 nanometers and the wavelength. So this tells us that it was originally blue. So we can move ahead. Yeah, so as I had stated, the narrator is moving towards the neutron star, and behind him are the other stars. Thus, those appear red to him. And the narrator was correct in his hypothesis.
All right, so now we shall be moving towards the conclusion of this presentation. So this story, we used mathematical and physical methods to understand how likely the physical scenarios presented in the story were. So before we go on, I'm going to tell something interesting about the story. So when the story was written in 1966, it was actually quite notable for mentioning a neutron star, which was just a hypothetical concept at that time. It was only a year later, in 1967, that we first got evidence for neutron stars through the detection of pulsars, which are a special kind of neutron star. And today, we know over 3,200 stars in the Milky Way itself. And then other hundreds of millions of undiscovered neutron stars. The reason that we have so many undiscovered neutron stars is that older neutron stars are really hard to detect because they become colder, because of which they don't have as much electromagnetic radiation. So for that reason, we can't really, we only know 3,200, but there are many, many more neutron stars that are predicted to exist based on estimation of supernova explosions. So moving on to the factual correctness of the story, as we had already figured out, the narrator gets to a closest difference of 7 miles to the neutron star. And as according to our calculations, at 1150 miles or less, the narrator should essentially have been ripped apart because of the differential acceleration between his heads and toes. Plus many factors that could have affected the distance, such as electromagnetic radiation, electromagnetic forces, etc., have not really been considered when calculating the closest possible distance, which is probably greater than what we have come by just using gravity. That's one. So thank you, everyone. That was our presentation. We hope you enjoyed it and got like something to know about neutron stars in general. And do we have any questions?
Hello.
Great presentation, guys.
Thank you.
Just one small question. So, if I understand correctly, the stretching that happens near a neutron star is because you have one end of an object at a different r and at a different
yeah.
r distance, and the
Yeah.
other end is at a different r distance, right?
Yeah.
And you say that in the story, he mentions that the human went to at a distance of 7 miles, which is not physically possible.
Yeah.
Now, taking this into account that you need a different r distance for the stretching to occur, can you think of any physically possible way that he still could have gone 7 miles near to the neutron star without being killed?
Yeah, well, I guess you could, to minimize the r distance, like he could stand straight, in which like the r distance would be much lesser. We considered like head to toes. Instead, it would be like the width of the body. So he
Right.
could become much closer in that. It just depends on how small you can get that r distance to be. The smaller you get it, like you can go like much closer to the neutron star. Yeah.
Right. Makes sense. Thank you.
Okay. Any other questions? Okay.
Thank you, guys. Thank you so much.
Yeah.
Next up, we have Galactic Hikers, where we have Tanmay, Vari, Vidushi, Ram Pranav, and Sriram.
Yes, look here. Wait, one more. Okay.
Keep the mic.
Hi everyone, we're the Galactic Hikers, and today we'll be taking you through the barren world of A Walk in the Sun by Jeffrey A. Landis, and our mathematical analyses of certain claims in the stories and whether or not they would actually work. My name is Vidushi.
I'm Vari.
I'm Ram Pranav.
I'm Sriram. I'm Tanmay.
And we hope you enjoy our journey onto the moon. Now on to Vari with the summary.
I'll be telling you all the summary of our story. In this science fiction story, the protagonist Trish is the sole survivor of the crash landing on Moon in her ship Moon Shadow. She faces the challenges of surviving in a harsh lunar environment with limited resources. Trish mourns the loss of her crewmates and contemplates her own fate. Determined to survive, she takes stock of her assets, including her intact spacesuit and remaining supplies. She starts depending on a wing-like solar panel to provide power to her suit's recycling facilities, for which she needs to remain on the bright side of the moon. Trish realizes that she must call for help, but then discovers that the nearest assistance is on Earth, which is 250,000 miles away. To stay alive, Trish has to keep walking continually to stay in the sunlight. Whilst on her journey, she passes wonders of the moon unseen to any other before her. While she walks, she has to maintain her suit, sleep rations, and ensure that she is moving at a fast pace. Due to exhaustion and loneliness, she starts hallucinating that her elder sister Karen is there with her, who died a few years earlier. Once she cannot cope anymore, she goes up a mountain and signals for radio help. After a strenuous climb, she successfully contacts Geneva Control and learns that a rescue mission cannot be sent until 30 days later due to the lunar night approaching. Despite the challenges and uncertainty, Trish resolves to wait for the rescue mission, displaying her determination to survive. Now on to Ram Pranav.
Okay, next question. Okay, so wait. All right, so question one is a very simple question. So basically, Trish, or the main character, she kind of holds out her hand like this, and when she holds out her hand like this, the earth is covering, uh, the earth is being covered from her perspective, and it's being, her hand is covering the earth. And from the story, we know that the hand span measures 20 centimeters, which is just the distance from the bottom of your hand to the top of your hand. And the arm span, which is 60 centimeters, and the moon distance from the Earth is approximately 384,400 kilometers. And based on this information, what is the angular distance of the Earth as seen from the moon? Okay, so based on the information given in the story, we're able to draw this diagram where this is her arm and this is her hand, and using that information, and we know that the earth is being covered from her perspective, so using that information, we're able to draw a 90-degree triangle and use tan inverse, like shown over here, to calculate the angular diameter of the Earth from the Moon, which is 18.4 degrees. Just for comparison, the angular size of the Moon from the Earth is approximately 5 degrees. Same thing with the Sun. The Earth, however, from the Moon is 18.4, which shows you how big the Earth is from the Moon.
So the next question is, so if Trish takes 6 days to travel quarter across the moon, so we have to calculate her average speed and how fast she would need to move to achieve a distance which is equal to the circumference of the moon in 24 more days. And we have to compare how fast she has to move to the required speed. And so also we need to calculate at what is the distance if she moves at the speed she is going right now, and with the circumference given in the story as 11,000 kilometers.
Next slide. Next slide.
So with our given circumference, 11,000 kilometers, we compute the quarter circumference, that is 2,750 kilometers. And we can find Trish's average speed in 6 days. That is 5.31 meter per second. So after that, we have to compute the required speed of Trish. So we get 3.98 meter per second. So now we can say that Trish's average speed is greater than the required speed. So now we have to calculate the difference, that is 1.33 meter per second, and we have to find the exceeded distance. So 1.33 meter per second times 30 days, she travels 344.736 kilometers if she walks at the same speed, and that means she will exceed the circumference. So I would like to also add that at the speed she is moving, that is 5.31 meters per second. This is almost equal to a marathon runner's speed on Earth's gravity. Now I would like to hand over to Tanmay.
So as we know, the spacecraft, from the summary, this spacecraft crashed. So how much thrust is required for soft landing of the rocket? So these are the parameters given below. The height of the rocket is around 110 meters. The moon's gravity acceleration is 1.667. The mass of the rocket is 28 tons, which is around 25,400 kgs. The initial velocity is 20 meter per second. The final velocity is 0.2 meter per second. And the distance from the moon when thrusters were activated are 500 meters. Yeah, so uh, yeah, from the diagram we can see that this is the rocket, this is the height, the final velocity, and so to calculate the acceleration, the net acceleration, we are going to use Newton's law of motion. From that we get acceleration as 0.996 meters per second square. So by using acceleration, we can calculate the thrust, the upward thrust, which is around 32,250 newtons. So for comparison, 32,250 newtons is aroundly required by this cables to lift off a whole crane.
Now, in conclusion, we believe that the author did a relatively good job in maintaining accuracy, even when adding new technologies to the story. The scientific base, along with the fiction of the story, truly did lead to it being an enthralling and entertaining science fiction read. Now, lastly, we'd like to thank our professors, TAs, and TFs for guiding us and letting us venture into another world. We'd also like to thank the audience for listening to our presentation and following us on our journey into debunking and proving elements of the story. Now, we open the floor to any questions.
Any questions? Okay, if we don't have any questions, we can move to our next group, which is called NASA, where we have Ninad, Ansh Tevatne, Ansh Jain, and Sukriti. Yeah.
Good afternoon, we're Team NASA, and today our presentation is on the sci-fi story Cool Neighbor, written by Jack McDevitt and Michael Shara, and we are
Ninad, Ansh,
Sukriti.
And Ansh.
Our team name is NASA, and Cool Neighbor is basically a story about a scientist called Greg who makes a shocking discovery, along with his colleagues Anna and Christy, that there exists a brown dwarf just 18 light years away from our solar system. And this story was first published in 2009 in The Cryptic.
Now let us talk about the summary of the story, Cool Neighbor. So here we are talking about a brown dwarf. So most solar systems in our galaxy are binary, meaning that there are two stars orbiting around each other. So a brown dwarf is a gas giant that might have not been large enough to start the fusion. The story Cool Neighbor is about a dying astronomer Greg's findings that later leads to his colleagues to discover a brown dwarf 18 light days away from us. That is a binary companion to our sun alone. So let us look at the series of events which happens in the story, The Cool Neighbor. So first of all, the Greg Cooper discovers a massive radiation surge and it could be caused by either a supernova or a Wolf-Rayet star, specifically mentioning Gamma Velorum as the source. They filtered down these stars that were a part of the Sagittarius constellation, and this led to a shocking discovery. There existed a binary companion to our sun, a brown dwarf, and its two orbiting planets, one of which shows signs of life. And the story also mentions a cool fact, that Jupiter, if Jupiter would have been more massive, then it would have turned into a binary star. Now let us look at some questions which we found from the story. Over to Ansh.
So in the first question, there's a Wolf-Rayet star that's the binary companion to our sun. One of the stars about 810 light years away from us and 29 times the mass of our sun. So if this star goes supernova, will it appear brighter than the full moon in the sky? So we'll see how we calculated this. Okay, so we know the mass of the star, which is about 28.5 solar masses. We know the distance to the star is 810 light years. So first thing we do is calculate the amount of energy released by the supernova that was visible light. So we know the formula that relates energy to mass. So that's equals mc square. So here we used an approximation. So in a supernova, generally what happens, about 1% of the mass of the original star is converted to energy. And further, 1% of that energy is visible light. Like the rest of the energy is kinetic energy and other electromagnetic radiation that's not visible. So over here, I simply plug in the numbers and get the visible light energy as about 5.1 into 10 raised to 44 joules. Now, luminosity is basically energy over time. I think, in 1054, Chinese astronomers observed the supernova that caused the Crab Nebula to last for about 2 years. We can use this approximation in our calculation because the masses of the stars are pretty similar. So we know that 2 years is about some 6.3 into 10 raised to 7 seconds. So we simply divide the numbers and get 8.09 into 10 raised to 36 watts as our luminosity. Now, another thing, luminosity decreases over the distance squared. So using that, we can calculate the power per meter square. So for the supernova, it turns out to be 0.1377 watts per meter square. And for the moon, it's 0.0034 watts per meter square. So this is obviously much more brighter, and the story was indeed right about that. Now, back to how we calculated the luminosity based on the distance. So, picture this diagram. Here's a light source, and this is the light from the light source spreading ahead. So at a distance of 1, the light will cover an area of 1 square. At a distance of 2 units, it'll be 2 squares. So that's 4, and then 3, it's 3 square, that's 9. So as you get further away from the light source, the area your light is covering increases proportional to the distance squared. Now, as this area is increasing, you can see each one of these squares is actually getting dimmer. So it's getting dimmer by 1 over the distance square. It's proportional to that. So that's how we calculated that over, I think it was 810 light years, how much the luminosity will decrease and how bright we will see that supernova in the sky. So, yeah. Over to Ninal.
Hello. Yeah. So here is the second question. The story claims that Sagittarius constellation occupies just over 2% of the sky. Is this true, as seen as from Earth? Here's the diagram. So the Earth to the Sagittarius constellation distance is 98 light years. As per the story, we took the diameter of the Sagittarius constellation from eta Sagittarius to mu Sagittarius, that's approximately 82 light years. Now we have divided as a isosceles triangle. Now we have divided into a right angle triangle, and now we have to find the angle x. As the angle, we have take 2 into tan inverse into 82.43 upon 2 upon 980. So we can get the degree 4.81. Now we'll convert that degree into the percentage, and we get the 2.67. So it's just over the 2%. So we can conclude that the story was approximately right, and it was just over the 2%. I will conclude that just so criticums. I fucked up.
So for the third and the last question, the story mentions that only objects in the solar system move enough in a few nights to be relative to their background to be detectable, and the closest brown dwarf, that is 12 light years away, would not be detectable. Is this true? So we know that the farther away an object is from us, the smaller its angular displacement will be. So we use this diagram. So the brown dwarf is a binary companion to the sun. So it can be assumed that it has a circular orbit around the Earth. And the distance between Earth and the brown dwarf is 12 light years. So to calculate the circumference of revolution, it's approximately 75.39 light years. So using that, we can assume the few nights to be a week, which is approximately, which is 604,800 seconds. And we know that currently the best of our telescopes can detect 0.1 degrees of movement in the sky. Therefore, the object must move about 1.7 into 10 to the power minus 7 degrees per second over a week for it to be detectable. So the distance from Earth to the object is 12 light years. Speed is what we found, 1.7 into 10 to the power minus 7, and circumference is 75 light years. So we know that 1 degree is 0.2094 light years. So using that, we found 1.7 into 10 to the power minus 7 degrees is equal to 3.56 into 10 to the power minus 8 light years per second. Converting this to meters per second, we get 3.36 into 10 to the power 8 meters per second. And that is absurdly fast because light itself travels only 3 into 10 to the power 8 meters per second. So for it to detect in a week, it would have to travel faster than light, which is not possible for the brown dwarf. Therefore, the story was right. It cannot be detectable.
So here's the conclusion that the story is scientifically accurate. After performing calculation and by confirming the story, we learned how to answer astronomical issues.
Now I would like to thank our teachers, Professor Saurav Mitra and Professor Sushan. And we would also like to thank our TFs, Umang sir and Anantaram sir, along with our TAs, Abir, Ayush, Aditya, and Tejas Seva. So thank you all for giving us such a good experience in astronomy and teaching us many good things. Thank you all for paying the attention. Now we'd like to take the questions if you have any. Any questions? Okay, thank you everyone.
Thank you for the presentation, guys. Next up, we have To Vesta and Back by Arth, Ananya, Manya, Ryan, and Vedanshi. Can we have an applause for them?
Our story, Marooned of Vesta, is a science fiction short story written by the American author Isaac Asimov.
Good afternoon, everyone. I'm from the group To Vesta and Back. Today we are presenting the story Marooned of Vesta. While reading the story, we had few questions that that we were curious about. We found the answer to it, and with me I have my group members Arth, Single, Ananya, and Manya and Ryan. So the characters of the story are Warren Moore, Mark Brandon, Michael Shee. Warren Moore was more on the positive side that they'll survive, and Mark Brandon was more on the negative side. He had negative thoughts about survival, and Michael Shee was kind of neutral. Now we have the summary of the story.
Our story, Marooned of Vesta, is a science fiction short story written by the American author Isaac Asimov. Marooned of Vesta tells the story of three men who survive the wreck of the spaceship Silver Queen in the asteroid belt and find themselves trapped in orbit around the asteroid of Vesta. To save themselves, their captain, Warren Moore, decides to plunge through the asteroid belt rather than circumnavigate across the belt. However, the problem was that they have only 3 days of air supply left, week's food supply, a regional gravitator that would keep them at an average weight, and a year's worth supply of water, about 750,000 cubic feet. In the middle of their conversation, Warren was struck with a brilliant idea. He immediately got to work. Carefully, Shay and Warren make their way through the airtight door, making sure that no air is leaking, taking the only suit available. Warren starts executing his idea with a metallic grapple and a heat ray. He steps into a space where the water tank is kept. With great determination, he starts heating it with the ray gun. Even though the space suit begins to grow very hot, he manages to warm the beryl steel alloy, the material of the tank, to its melting point. Through the small opening made, steam starts filling the room, and in a few minutes, Warren feels a gentle pressure push him out. Excited, he realizes that his plan has worked and the water is substituting for the rocket blast. This rocket blast was supposed to help them push towards Vesta and reach the asteroid in 5 to 6 hours. He returns to the room in a ruffled state and tells them about the happy news. Our story, Marooned of Vesta, is a science fiction short story.
Alright, so now we move to questions. The first question we are going to answer is, what would be the approximate angular size of the Silver Queen spaceship from Vesta? So an observer standing on Vesta, would they be able to see the spaceship or not? Alright, so first let's recap the given information. The spaceship Silver Queen consists of a major part that is a water tank with a volume of 10 lakh cubic feet, that is 28,000 cubic meters, and a small room with a volume of 1456.3 cubic feet, which is nearly the size of 5 cockpits of an aircraft. To determine whether an observer standing on Vesta would be able to see the spaceship, we need to calculate the angle theta formed by the spaceship as seen from the Vesta. So the point here on Vesta, we assume that an observer standing here would observe the spaceship at an angle theta. To find the radius of the spaceship, we equated the total volume of spaceship, that was the volume of the water tank plus the volume of the cockpit, to the volume of sphere, which is 4 by 3 pi r cube. Solving for the radius, we got a value of 62.065 feet, which is approximately 19.22 meters or 0.0119 miles. Next, we use the formula S is equal to r theta to calculate the angle theta, which is the angular diameter in radians, r being the radius and s being the diameter of the ship. Therefore, the angle theta can be calculated as follows. Theta is equal to r by s, which gives us theta is equal to 0.0045 degrees.
We conclude that the angle theta is very small, and upon calculation, we found it to be equal to 0.0045 degrees. Comparing the estimated value of theta of the angular resolution of the human eye, which is 0.02 degrees, we can conclude that an observer standing on Vesta would not be able to see the spaceship Silver Queen. So, in total, the assumption made in the story or the fact written in story is justified by the physical calculations too. Just for the fact, the sun that we see from Earth is at an angular diameter of 0.5 degrees. So this would be much smaller than the sun, like 10 raised to the power minus 2 times smaller than the sun. So that would be too small. The next question, the second question that we thought of was when the Silver Queen would hit Vesta, will the astronauts be able to survive or not? And if not, then what could they do to survive? Or like, could they change their strategy or something to do it? In the second question, we started off by assuming a scenario of a coconut falling on a car standing on Earth's surface. And it was pretty obvious that the surface of the car would be deformed. If we take the potential energy, mgh, of the coconut and equate it to the final energy that is all kinetic, we get that the velocity of impact will be 14.142 meters per second. And if the velocity of the spaceship falling on Vesta is greater than or equal to this, then we assume that it would be probably deformed and the astronauts won't be able to survive. So taking the spaceship scenario, we considered it to be similar to the coconut and assumed that it is falling towards Vesta. We equated its initial energy, that was all gravitational potential energy, to the final energy, that was the sum of the kinetic energy and the potential energy, according to the law of conservation of energy. And then we got an equation minus capital G m by R1, R initial, is equal to 1 half mv square minus gm by R2, which is the final radius, or the radius of Vesta. Rearranging the velocity equation, we got the velocity and like plugging the values, we got the velocity to be 412 meters per second, which is much more greater than 14 meters per second. So the spaceship would be probably broken into very small pieces, and it is really hard for the astronauts to survive. To prevent this circumstance, they could have used some sort of water thrusters and thrown the water and disposed of the water in the direction of their motion so as to decrease their initial energy, and which would eventually lead to a decrease in the final energy, thus reducing the velocity of impact, which would save them from dying.
So our third question is it possible for water to freeze and boil at the same time with a low pressure? That is, achieve the triple point of water. So the triple point of water is basically the temperature and pressure at which all the three states of water exist simultaneously. It was mentioned in the story that the water was constantly freezing and boiling at the same point. This shows that the triple point of water had been achieved. However, it should not be possible to achieve such a condition in space due to the following reasons. At a temperature of 0.01 degrees Celsius and absolute pressure of 4.58 mmHg, the triple point of water is achieved. In space, such conditions cannot happen simply because of no presence of air. At pressures below the triple point, such as those that occur in space, where the pressure is near zero, liquid water cannot exist, and therefore the triple point of water cannot be achieved.
In our presentation, we have proved whether certain facts in the story are true or false. For example, in our first question, we tried to find if the spaceship, the Silver Queen, would be visible from Vesta or not. Using various scientific and mathematical concepts, such as the eye resolution and the distance between two objects, we were able to prove that the spaceship would indeed be visible from Vesta. We were also able to find out that a safe landing on Vesta is not possible, using concepts like velocity, as mentioned in the second answer. Finally, in our third answer, we were able to show that the triple point of water cannot be achieved in space due to reasons mentioned earlier. The story was quite interesting, but clearly it was not entirely scientifically correct. If we could change anything that we wanted to in the story, we would definitely add a scene that describes the control of the water blast, as to make it more realistic. I guess it's safe to say As a team, we were able to learn a lot, such as accuracy and analytical skills. Moving on, we have the credits slide where you can see how everyone has contributed to the presentation. I would like to especially thank our TAs, our TFs, and our professors for being a guiding light throughout the way. We really enjoyed astronomy. Thank you so much, and we hope you enjoyed our presentation. Any questions?
We are open to questions now. Any question?
Yeah. It's not exactly much of a question, more like a sort of a question about the question. In question 2, like, you've only considered the potential energy of gravity, but like in this story, they're releasing water. Shouldn't that also increase the velocity and make it much harder for them to finally stop?
No.
And also, if it were just taking gravitational potential energy, the final velocity would have been something like a spiraling path inwards. Therefore, the velocity would have in fact been quite lesser towards the surface, and they could have like secured a landing that way. So, like, how
So
do you answer
the
that?
water thing, it would not impact the energy because energy is conserved in an isolated system and the system is isolated. The water force is an internal force. It would not even change the momentum, the total momentum and the energy. Coming to the second part of your question, the spiral part, we assumed the angular velocity of the spaceship to be 0 because there were like the syndonic period and the time period of the rotation and the revolution were not given in the story. So we assumed that it was stationary at a point and it was just falling directly in a linear motion sort of thing. But if we even consider the spiral paths, then the impact velocity would even increase further, and like the spaceship would like be more greatly impacted. So,
yeah, thanks.
Yeah, please. There's a question.
Even if it's a closed system, the rocket or whatever this is losing water, right? So it's losing mass. So you know that kinetic energy is half mv square, and the momentum is mv. So if m is reducing, shouldn't the v go up? 'Cause you're telling that it's a closed system, so it has to be constant, right?
First of all, the half mv square thing, when you put it into the equation, the mass of the rocket cancels out everywhere. So the mass of the velocity of impact is independent of its mass. Secondly, when you're talking about the momentum thing, so the water also has some mass, which you correctly told us about. So when the water is being released, it is also gaining some velocity. So the water has some velocity, so the rocket's velocity would not change because basically, like, it would not lead to a change in momentum, but somewhat change in velocity.
Yeah, but if there's a change in velocity, then of course the momentum will change, right?
No, the overall momentum of the system. When you talk about the momentum of system, it is always conserved because all these forces are internal forces. None of the forces are external forces, right? So the system that we have considered is the system of the spaceship, Vesta, and the whole solar system. Instead of, if you just consider the spaceship, then the momentum would change. But it's about the system that you consider. We are considering the whole thing to be one system.
Yeah, but this is last question. But that's just how the rockets work, right? They lose mass, and then since momentum is constant, because it's a system, that's why they propel forward. So you're just telling that the whole system of how rockets work is wrong?
No, I never said that. I'm even justifying the rocket system because I'm saying that the momentum in the whole system is conserved, which is why rockets propel. Because water gains a negative momentum if you would if you would give a direction to it, it will gain a negative momentum. So the rocket will have to gain a positive momentum to bring it to 0 or to conserve it. Thank you.
Can we take one more question?
Just a simple question. Did you consider if they would run out of water?
They wouldn't really probably run out of water because they have 7.5 lakh cubic feet of water, so that's too much. And the distance is not that much, like it's just 300 miles. So.
Thank you so much, guys. Next up, we have the group Lost in Void, where we have Aditya, Mannat, Sanjeet, and Gunita.
It's okay. This mic is also like.
Yeah, that's
Good afternoon, everyone. Today, our team, Lost in Void, will present you the story Summertime on Icarus. Our team is composed of Sanjit, Aditya, Mannat, and me, Gunita. In this presentation, we will cover a brief overview of the background, the setting, the plot, and the author of the story. Then we will go over the summary of the story. Lastly, we will answer some questions to check the factual accuracy of the story. This story was written by Sir Arthur Charles Clarke, who was an English science fiction writer, futurist, an inventor, and television series host. This story was also published under the name The Hottest Piece of Real Estate in the Solar System.
Hi, my name is Sanjay and I'll be talking about the asteroid right now. And as you can see, that's the asteroid. Its technical name is Icarus 1566, and it's a large near-Earth object of the Apollo group, and its diameter is approximately 1.4 kilometers. And its orbit is highly elliptical, and at one point it's closer to the Sun than Mercury, and on Earth it's farther than the orbit of Mars. And in the next slide. Yeah, you can see the orbit of Icarus right now. The dark blue ellipse is the orbit of Icarus, and as you can see, at one point it's closer to the Sun than Mercury, and at the other it's farther than Mars. So it has eccentricity of 0.83 and an inclination of 23 degrees, and its orbit ranges from 0.19 AU to 1.97 AU, and it completes its revolution at 409 days. Next slide. Now, now I'll be talking about the story. So our story is basically set on Icarus, where astronaut Colin Sherrard. Yeah, so where Colin Sherrod wakes up at a dangerous situation on a small asteroid. He can't remember what happened and stuff, and then he just remembers that they were doing experiments in Icarus as a part of International Astrophysics Decade. So asteroid is only 17. The asteroid is only 17,000 miles closer to the sun, as it's only 2 weeks from perihelion, the closest point to the sun. So its surface is scorched, and it's everything everywhere you see it's like charred and molten. So his goal was to he can't find his the mother spaceship, which is Prometheus. So he was just trying to search for it, and he was just repairing his equipment when he heard a bang, and his spaceship flew up, and it fell down again. So there was the spaceship just broke into half, like breaking its metallic arms. And at that point, he just noticed that the sun was rising. And when the sun rises, according to the story, it'll reach up to 1,000 degrees Fahrenheit, which is like 541 degrees Celsius. So that's like pretty hot. So his goal was to move further and further away from sunrise by moving in the opposite direction of the rotation. So that's what he tried to do when he just saw, but then he couldn't do it in time. So he just thought it was his final moment, and he's gonna die. So he just removes all his sunlight glaring visor to see Earth for the last time. And at that moment, he just notices a titanium or a aluminum foil floating up in the sky, and then he thinks he's hallucinating because at that point he has given up hope and he's just like dead. So, but then it's actually his crew members from Prometheus, and they save him at the last moment again. But as he has this experience, he'll never be able to enjoy summer again.
We have made some questions now to check the factual accuracy of the story. Our first question is to check the accuracy of temperature as measured in the story, which was 1,000 degrees Fahrenheit. We know that sun radiates light in every direction, and this forms an imaginary sphere. The energy radiated is equally distributed across this sphere. We know the surface area of a sphere is 4 pi r square. Through this, we can conclude that energy per unit area is inversely proportional to the distance from sun. We know that energy received by Earth per meter square is 1 kilowatt per meter square, which is enough to boil 1 liter of water in 5 minutes. If we know the distance between Icarus and the sun, then we can calculate the energy per unit area on Icarus. In stories, there are 2 instances when this is mentioned, so we will use both of them to check their factual accuracy. In one instance, it's said that the distance between Icarus and sun is 2.6 into 10 raised to power 7 kilometers. Using this, we have the square of this ratio, which is this. And through this, we can calculate the energy received by Icarus per meter square, which is 30 kilowatt per meter square. Now, firstly, we'll assume Icarus to be a perfect black body. A perfect black body is an object which perfectly absorbs all electromagnetic radiations and emits it at certain wavelengths. If we assume it to a black body, we can use Stefan-Boltzmann's law, which is this, to calculate the temperature. The temperature comes out to be 810 kelvins or 1050 Fahrenheit, which is very close to the original estimate. Now we'll use the second piece of information we had. In the story, it was mentioned that from Icarus, sun appeared to be 30 times the size of what it appeared to be on Earth. We know that the angle subtended by the diameter of sun is 0.5 degrees on Earth. From Icarus, it will be 30 times of that, which is 15 degrees. Converting it to radian, we can use it in this formula, which is S equals to A by R, where S is the diameter of the sun, A is the angle subtended, and R is the distance between Icarus and sun. From this, though, the distance from Icarus and sun comes out to be 5.3 into 10 raised to power 6 kilometers. Using the same steps as we did before, now the temperature comes out to be 2000 degrees Fahrenheit, which is completely inaccurate and it contradicts the story. Plugging the value of 1000 degrees Fahrenheit in Planck's radiation law, we can get a black body spectrum graph, which is this.
Okay, coming on to the second question. Screenshot. Okay, considering the gravitational field on Icarus is 10,000 times weaker than that on Earth, we're trying to check if Sherrod will attain escape velocity or not, given that he's been jumping on the surface too much. So escape velocity is essentially the velocity that a body must have such that it goes infinitely far from the gravitational force of a given planet. And it's the speed that's needed such that the potential energy as well as the kinetic energy, the final kinetic energy, is 0. We're given the values, the gravitational field is given, and we know the jumping velocity. And we're trying to calculate the escape velocity of Icarus as a ratio of the velocity on Icarus by the velocity on Earth, which is the square root of the mass of Icarus into the radius of Earth divided by the mass of Earth into the radius of Icarus. We calculated the escape velocity to be 1.2 meters per second, and the jumping velocity was given to be 1.7 meters per second, through which we can conclude that Sherrod will attain escape velocity and will go infinitely far from Icarus. Coming on to our third question, it's a two-part question. One, checking if the pod would break, and from what height the pod should have fallen from for it to break on crashing into the surface of Icarus. Just for some background, in the story it's mentioned that Sherrod pushed the throttle over to full, the pod crashed into the surface, and the metallic arms broke. There's no mention of whether the pod broke, it's just the metallic arms of the pod that were broken. Through this question, we're trying to check if the pod should have broken or not. Now I'd like to use this analogy first. Suppose we assume that there's a scenario where a ball is falling from a height of 10 meters on a moving car. By equating the energies, we calculated the velocity to be 14 meters per second. Applying the same principle, if a pod that's made of the same material as the car has a velocity greater than 14 meters per second, it will experience deformation upon impact. Now, let's assume that the pod is detaching or separating from Prometheus. At the point of drop, the pod possesses only gravitational potential energy and no kinetic energy. But according to the principle of conservation of energy, the pod will have some kinetic energy as it reaches the surface. From these calculations, we got that it is necessary for the pod to descend from an altitude more than 10 kilometers for it to break on crashing into the surface of Icarus. Based on this information, we can conclude that this story is accurate for this question, because we know it was given that the ship Prometheus is 3.2 kilometers above the surface, which means that for sure the pod is somewhere between 3.2 kilometers, which is less than 10 kilometers, and technically, with what we have shown, the pod should not have broken. I'll now give it back to Gunita.
To conclude, it is confirmed through Stephen-Boltzmann law that the temperature on Icarus is 1000 degrees Fahrenheit. In the story, it is stated that Sun appears to be 30 times larger, which contradicts the previously established findings. Since the jumping velocity of Sherrod is way more than the escape velocity, Sherrod would attain escape velocity. If a pod is made of the same material as a car and has a velocity greater than 14 meters per second, it will experience deformation upon impact. It is necessary for the pod to fall from an altitude more than 10 kilometers for it to be damaged. Thank you.
These were our credits, and we'd like to thank both the professors at TAs and TF for helping us get through this presentation. Thank you. We're open for any questions now.
So you mentioned about the black body, that it emits in certain wavelengths. So what wavelengths does the sun emit in, for example?
Well, the wavelength of the radiation emitted by the black body is proportional to its temperature. That's like the Planck's law. So for each and every different temperature, the wavelength emitted would be different. You can't.
So, but did you not mention that a black body absorbs and emits all light? So if it's emitting all light, then isn't it emitting all radiation in all wavelengths?
Yes. It emits all radiation and all wavelength.
Right.
Yeah.
But you just said it emits in certain wavelengths. So which
No.
of these is right?
It emits different types of different energies at different wavelengths. It alters, depends.
So at a given temperature, it can emit lots of wavelengths.
Yeah, at a certain energy.
Okay, thank you.
Alright. So while calculating the escape velocity, did you account for all the external forces, all the external gravitational forces and the magnetic field forces that were acting on the system? Like, and would it change your answer? What do you think?
For clarification, Icarus does not have a magnetic field. So we didn't account for.
I'm talking about all the external forces. I'm not talking about the forces by Icarus, by the other planets, Earth, Mars, and all the planets that are surrounding
Yeah.
Sun and everything.
So at this
so they
point,
have their magnetic fields, right?
So we calculated where the path, like where Icarus would be at its orbit, like 2 weeks before perihelion, and at that point, its farther almost negligible. So you don't have to account for that. Yeah, that was one of our other questions, but then we asked the professors, and they said you can, it's negligible, so you don't have to account.
Thank you so much, guys. Next up, we have neutronium seekers, and here we have Abhinay, Sriram, Shoibam, and Nishant. Can we have a round of applause for them?
form a white dwarf or a neutron star or a black hole. A neutron star is relatively small in size, like it's around just 10 to 20 kilometers in diameters, but its mass is extremely dense, the second densest just behind the black hole. Let me take over. Now over to Abhinay.
Newtonian star is a short summary by the Levin event that describes the effect of the gravitational pull of the neutron star. And the story begins with the protagonist, Beowulf Sapphire, who is tasked to investigate the mysterious deaths of the scientists who died while investigating a neutron star. He starts approaching from a million miles away. As he gets closer to the neutron star, he gets an strange thing about the neutron star. He gets that some unknown force is pulling him towards his side. And he could feel himself getting pulled towards in his feet. As he got closer, the force got stronger, and he realized that it was trying to pull the ship apart. Then he realized what the force was. The force was the tidal force. So now Nishan will explain what is the tidal force.
But what exactly is the tidal force? Well, when an object is under a gravitational influence, one end will be closer to the other. And the end that is closer, because of Newton's gravitational laws that states that the force of gravitation is inversely proportional to distance squared, the end that is closer to the body will have a greater influence. So what happens is, if the body is close enough, then the difference between the forces at the end is great enough to pull the body apart.
So we have two questions, and first question was, how would a body be affected by the gravity of a neutron star, and how close to the neutron star we can go? So for calculating this, we have used Newton's law. Force is equal to some g/mm upon r square, and due to the as for measures tidal force, when a body approaches to the neutron star try to pull it apart. Next slide. As the neutron star's gravitational force is much higher than the Earth, and so there will be a difference between the force at the foot and at the head. So first I am taking for the human, then for the human at the head force will be g/m head upon r square, and for the foot it will be g/m foot upon r plus h whole square. And when we take the difference for these two, we will get delta F. That is the difference between forces. And after, like, there is not much difference between m head and m tail. So I am taking it as a m. So when I calculated this, so I have taken delta F is equal to 10g into mass. So if we will take g/mm common, then small m will cancelled. So when I calculated value of r, we get for the human 2400 kilometer. And for the ship, I have taken delta F as 100g into mass. Then we got 3800 kilometer. If we get close to the neutron star, it will tear it apart. In the next, I am trying to show with the video.
The neutron star's gravity is 200 billion times stronger than on Earth. Around 150 miles above the surface, it starts to pull on Chuck's limbs in a distinctly unpleasant way.
As you get closer and closer to a neutron star, we were told to think that it would be this elegant spaghettification where you would get longer like a piece of spaghetti. But in reality, you're going to get ripped to shreds.
Think about what you're really going to experience. Think about, first, all your joints dislocated in your body. Your skin getting ripped off your body. Your bones being pulled apart. Your organs being pulled apart.
Within a blink of an eye, our dummy is just a thin stream of atoms hurtling towards the star.
So this was how the neutron star will tear apart a body which will close to the neutron star. Now, having listen for the next question.
The neutron star's
So our second question was to compare the apparent size of the neutron star given to the story, given in the story, and to cross-validate if it was right. Now, in the story, it's given that the apparent size of the neutron star from 1 million miles away is the same as the apparent size of the moon from the Earth. Now, what exactly is apparent size, you may ask? Well, apparent size is basically how big an object appears. So the closer an object is to the point of view, the bigger it will appear. That's why the sun and the moon appear the same size in the sky, although the sun is around, far more greater in size than the moon. So we can approximate the value of the apparent size through the formula S is equal to R theta, where S is the actual size of the object or the diameter, R is the distance between the point of view and the object, and theta is the apparent size. So taking into account that the neutron star is only 12 miles in diameter, we get the apparent size to be 0.006 degrees. Now, this is a far cry from 0.5 degrees, which is supposed to be the moon's apparent size. Now, if the author's statement was actually true, then the neutron star should have been perceived at approximately 1370 miles instead, rather than 1 million miles.
कंक्लूजन ऑफ स्टोरी, हम पृथ्वी से न्यूट्रॉन स्टार को नेक्ड आई से नहीं देख सकते. हम स्पेस में भी जाकर नेक्ड आई से इस न्यूट्रॉन स्टार को नहीं देख सकते. वी कैन सी इट बाय ओनली रेडियो टेलीस्कोप. अगर कोई बॉडी न्यूट्रॉन स्टार के थाउजेंड्स किलोमीटर की रेंज में आ जाती है तो न्यूट्रॉन स्टार इसे अलग कर देता है, क्योंकि उसका टाइडल फोर्स बहुत ज़्यादा होता है और हेड और फुट में टाइडल फोर्स अलग अलग रहता है. थैंक यू.
Do we have any questions? Okay. Thank you so much, guys. Can we have a round of applause? Next up, we have Apollo Night Riders, where we have Arnav, Pranav, Hitarth, and Ravish. Can we again have a round of applause for them? No, where did you upload it?
Apollo 9 should we get all that?
It's good. Can you email it to Urvashi? How is it possible? The presentation is missing from here. Can I call the next group till then? They said they had uploaded. It's not. Yeah, I can call the next group if they're there. Can you just... Can you send it to me? Do we have Anamika, Anshul, Angela, and Rowan here? You guys are here, right? All of you all? Can you call the rest of the people from your group? Okay.
Okay. Hello, everybody. We are the Apollo Night Riders, and here today we're going to present a scientific analysis of the story A Walk in the Sun. These are my teammates, Arnav, Pranav, Hitarth, and I'm Ravish, and we hope you enjoy the presentation.
Hello. Yeah. So this is the table of contents. We will be covering the summary of the story first. Then we will go to the questions, and we will show you the calculations and the results. And then we will be concluding the presentation. A little bit about the author, Geoff A. Landis. He was born on 28th of May, 1955, and he is a scientist and a sci-fi author. His famous books are Mars Crossing and Sultan of the Clouds, and he is an American aerospace engineer at NASA. The summary. So the story, A Walk in the Sun, was published in October 1991. It follows the intriguing journey of Patricia, or Trish Mulligan, who was an astronaut from the Moon Shadow satellite mission. The satellite was originally supposed to orbit the Moon, but due to an unfortunate malfunction, it crash landed on the surface. Trish was the only survivor, and after orienting herself, she realizes she was alone on the Moon. When she made contact with a team on Earth, the rescue team told her that it would take at least 30 days for a rescue team to come and take her. So for this, she would so basically her suit had solar arrays that used the sun's rays to convert it into fresh air. So for this, she would have to stay under the sun's light if she wanted to survive the 30 days. Overall, the story follows the perilous journey across the surface of the Moon, not only battling the sun, but also starvation, dehydration, and constant hallucination of her dead sister. The only things that got her through the entire period was her willpower and her mental strength, which allowed her to live and tell the tale.
So now we have the questions. First question is it necessary to travel at an average of 16 kilometers per hour to stay in the sunlight, considering the Moon's rotation and the revolution around the Earth? So in the story, it was mentioned that Trish was traveling at 10 miles per hour, which can also be said as 16 kilometers per hour to stay under the sunlight. The parameters provided to us by the story are approximate circumference of the Moon, which is 11,000 kilometers, the approximate speed at which Trish was traveling at, which is 10 miles per hour or also 16 kilometers per hour, and the orbital period of Moon around the Earth and the lunar day, which equals to 27.3 Earth days, or approximately a month. Our goal to achieve from this question is to check if 16 kilometers per hour is the adequate speed to travel at to stay under the area of the moon, which is covered by the sunlight. So while doing the calculation, we found out that it takes 27.3 days for the moon to rotate on its axis and revolve around the Earth. To stay in the sunlight for a whole lunar day, Trish needs to match the speed of the moon's rotation. This would ensure that she is always in the boundary between day and night and always under constant sunlight. To derive the average speed, we use the formula distance by time equals to average speed, which can also, in this case, be said as the circumference by the moon by the time period of the lunar day, which is 11,000 kilometers by 27.3 Earth days, which equals to 403 kilometers per day, and which is equal to 16.6 kilometers per hour. So the suitable speed to stay under the sunlight is 16.6 kilometers per hour, and Trish's approximate speed is 16 kilometers per hour. This gives us the conclusion that the difference between the values is, as it is not large enough, it is not large enough for Trish to not be able to cope up with. She would only need to increase the speed by approximately 4%, which isn't that high on the moon's surface. Therefore, the story is factually correct. Over to Ravish and Pranav for the second question.
Okay, so in our second question, we're going to answer another important thing about this story. Trish, the main character of the story, not only faces a time limit, but she also is exposed to the violent radiation on the moon. And since it has no atmosphere, she's vulnerable to the high temperatures on the moon. So in this question, our aim is to calculate the temperature of the moon at the equator to find out is it bearable given the current day's space technology, and using a graph, observe the minimum and maximum temperatures at the equator. So in the end of answering this question, we'll have a graph, which on the x-axis, we will have the day of the month in its rotation period, and on the y-axis, we'll have temperature given in degrees Celsius. Our given parameters are the moon and sun distance, the sun's temperature, and the sun's and moon's radius. The moon's radius is slightly hidden. And also, which we haven't added, is also the radius of the moon's orbit around the Earth, which is around 768,000 kilometers. But then after that, after using those parameters, in order to find the temperature on the moon, we're going to use the equation called the Stephen-Boltzmann law, and this will be explained by Ravish.
So, the Stephen-Boltzmann equation, it's used to calculate the power of any body, the amount of power it's radiating. So, the first component in this equation is the emissivity. So, the emissivity of any surface is the ratio of how much energy is radiated at that surface in comparison to a black body, the amount of radiation radiated by a black body. So, a black body is an idealized physical body which absorbs 100% of the electromagnetic radiation it faces and emits 100% of the energy that it receives, given that an object in thermal equilibrium must radiate all the energy that it absorbs. Then the second component is the Stephen-Boltzmann constant, which is just the constant of proportionality in the equation. Then we have the surface area of the body, which we can calculate using 4 pi r square for the surface area of a sphere. And finally, the fourth power of the temperature of the body. So the process we use to calculate the temperature on the moon starts with considering the fact that the sun constantly emits a certain amount of power in all directions. And considering a hypothetical sphere, so we can see that the distance between the sun and the moon is 1.5 times 10 to the power 8 kilometers. We can consider a sphere and calculate the surface area using our 4 pi r square formula. And we know that the power emitted by the sun is equal to the power of the entire surface area of the sphere. So using the Stephen-Boltzmann equation, we can take the power of the sun divided by the surface area of the sphere to calculate the intensity, which is known as the watts per square meter. And this gives us the intensity experienced on the moon, which we can use to calculate the temperature using the same equation. So using that, we know that the temperature of the moon at maximum is 397.867 Kelvin, which is equivalent to 124.727 Celsius. But here we run into a little bit of an issue. So what we know of a modern spacesuit is that the maximum acceptable temperature tops out at around 115 to 120 degrees Celsius. And the temperature we've calculated is a bit higher than that. So this leads to the conclusion that it seems to be that the story is factually inaccurate, since Trish would not be able to survive in that temperature. But one thing we must keep in mind is that this temperature is only for the equator of the moon, which is where the sunlight goes directly. In other locations, similar to Earth, when you get closer to the poles, the temperature experienced is less than at the equator. So depending on where Trish is walking, at which latitude she's walking on the moon, the story may or may not be plausible. So finally, we can see, as the graph we were talking about, where the x-axis has the number of days spanning from 0 days to 30 days along the month, and the y-axis gives the temperature in degrees, where the maximum is what we've just stated, and the minimum is about 118.8 Celsius.
So now we have the conclusion of our whole presentation. The story provided us with many approximate values which helped in our calculations. The story was factually correct about the speed Trish has to travel to stay under the sun's light. The story can be considered inaccurate about Trish surviving the moon's maximum temperature, but that is only and only if Trish was walking on the equator of the moon and nowhere else.
Okay. So we are really thankful for this project, as it taught us a lot of things. In going through the science fiction stories, we were exposed to a lot of fiction and science. And the duty and the thing of the project was to connect the fiction and the science. So in doing so, after reading the stories, we were allowed to brainstorm different types of questions we could pose against the statements made in these stories. And in order to answer those questions, we had to revise our previous knowledge in physics and learn new concepts like the Stephen-Boltzmann law and how to apply that law to calculate the intensity radiated by the sun. And on to Hitarth.
Yeah, so for the credits, this is the credits divided equally amongst the four of us. And we thank all the TAs and professors for guiding us along the way. Thank you. Do you have any questions? Yeah.
So in the first question, there was this thing that I forgot the name of the person. He has to move with some velocity to be in the sunlight for the entire duration, right? Did you account for the lunar eclipses? Because during lunar eclipse, there will be no position on the moon having sunlight. And lunar eclipses occur every 6 months. So did you account for it? I guess you guys...
We did not account for lunar eclipses as they weren't mentioned in the story. Only about her journey for 1 month. So in the Could you repeat the question? No, that's not the thing. So we don't know where actually she is.
Right.
It's mentioned in the story that on average, including her sleep time, she goes at an average of 10 miles per hour, which is approximately 16 kilometers per hour.
But if she were, for example, closer to a pole where there's daylight all the time, would her speed possibly be allowed to be lower?
Yeah, that would be happening if she was walking a different distance, but in the story specifically was mentioned that she covered 11,000 kilometers,
Okay.
which means that she was traveling across the circumference of the equator.
Okay, thank you.
The duration was 1 month, but you don't know if that 1 month lies in those 6 months. So you could have a lunar eclipse during that 1 month. So you should try and account for it.
Yeah, so we did not account for it because it wasn't mentioned in the story.
Theoretically, that could be true, but in the story, she was constantly mentioning about being in the sunlight. There is no mention of a lunar eclipse. Thank you.
Thank you so much, Apollo Night Riders. Next up, we have the final presentation for the astronomy module. Can I call upon Anamika, Anshul, Injila, and Reuven, and the group is called Light Years Ahead. Can we have an applause for them?
Hello. Hi everyone and welcome to our group which is Light Years Ahead. Today we're going to be presenting an analysis of how scientifically accurate our story Cool Neighbor is. I'm Anshul, this is Anamika, Reuven and Injila. So first I'm going to give a brief summary of what happens in the story. So the story begins with the protagonist. He is on a research facility on Earth when he is suddenly hit by a gravitational tsunami. He realizes he has only 1 minute left to live, and he realizes the inevitability of the situation. But he quickly sends the research he has to his colleague, Anna. After this, he is the only casualty. So Anna has been researching brown dwarfs, which are celestial objects between the size of a giant planet and a small star, with minimal luminosity. Basically, they are stars which have phases in the constellation Sagittarius, related to Clyde Tombaugh, the man who discovered Pluto. So after she filters through Greg's data, she realizes that there might be a brown dwarf very close to the solar system. So the story ends with another colleague of hers, Christy, presenting her discovery at Caltech. So she's discovered a brown dwarf, which is a binary companion of the sun, which means that they are gravitationally bound in orbit of each other. However, this brown dwarf had not been previously observed because it was much cooler, dimmer, and further away from Earth than the sun. So this discovery could help us understand why life established itself on Earth and not on other planets in the other solar system.
Now we'll be moving on to the questions. In our first question, we are going to question the veracity of the distance between Sun and brown dwarf using Kepler's law, and we'll learn how else Kepler's law can be applied. So Kepler's third law of planetary motion states that the square of the orbital periods of the planets are directly proportional to the semi-major axis of the orbits. What this means is that for a revolving body around a central mass, the time taken for it to complete one revolution squared is directly proportional to the mean distance between the orbiting planet and the central mass. The constant of proportionality is given as 4 pi square by gm. For time taken in Earth years, distance in astronomical units, and mass in solar masses, 4 pi square by gm can be equated to 1, and the equation can be simply written as t square equals to a cube. In our story, we are given time period as 150,000 Earth years and the distance between the Sun and the brown dwarf as 3,000 AU. We assume the time period to be true to check the veracity of the distance. Simply inputting the value of the time period into the equation, we get the distance to be equal to 2,823 AU, which is very close to the distance given in the story. Hence, we can say that it is verified. In our story, the closest brown dwarf is 3,000 AU away, but in reality, we notice that it is 4 lakh AU away. And since the difference between these two is so huge, we can say that the story diverges from reality at this point. This Kepler's law can also be used to find mass of supermassive black holes. As it has been used recently to find the mass of the supermassive black hole at the center of our galaxy, Milky Way, the Sagittarius A star black hole. So, there are stars have been discovered that revolve around the center of our galaxy, like S2 and S102. Using these stars and their period of rotation as well as their distance from the center of the galaxy and putting it into the formula, we can find the mass of the Sagittarius A star, which has been currently estimated to be about 4 million solar masses. Now moving on to the next question.
Right, so the next question in our story is, what is the temperature of the brown dwarf surface, given that the luminosity is 1/1,000,000th that of the sun, and how does it compare with the temperature indirectly given in the story, which is 8 times cooler than that of the sun? So the values given in our story for the brown dwarf are luminosity, distance, and temperature. What luminosity basically means is the light emitted by an object around its surroundings. For example, a big hot star would obviously have more luminosity than a small cool star, since it gives off more energy and has more light. The distance is 3,000 times farther than that of the sun, which is basically to say it is 3,000 AU, and the temperature is 8 times cooler. So for the first part of the question, where we're calculating the temperature, where we're verifying the temperature, we're using the Stefan-Boltzmann constant. What the Stefan-Boltzmann constant is the amount of, it basically helps us understand the amount of heat or energy radiated by an object. It also gives us a relationship between the temperature and the energy to say that they are both directly proportional, which means that if the energy increases, so will the temperature. This can also help us in calculations or figuring out more about stars and planets, so as to say that if we know about the energy radiated by a star, we can figure out its temperature, its size, and maybe even the lifespan of the star. So using this, we've calculated the amount of temperature for the brown dwarf, where P is the power, A is the surface area, sigma is the Stefan's constant, and 1/4 of the power, obviously, which gives us the answer to be 631.651 Kelvin. And according to our story, it should be 721.5 Kelvin, which is very close. So from this, we can infer that this fact holds true for our story. For the next part of the question, we'll be seeing how energy is dissipated from the brown dwarf and how it is dissipated from Sirius, which is the brightest star to Earth. This will help us understand if we can actually see the brown dwarf from our naked eye or not. For this question, we're using the inverse square law of light formula. What the inverse square law of light formula does is basically tell us how light spreads around its source and how we can see it when it moves away from its source. It also does this in a very specific equation, which is to say that the brightness is inversely proportional to the distance squared. S over here stands for the source strength of the light. 4 pi r square is the distance from the source to us, and pi r e square is basically the cross-sectional area of the Earth. From this calculation, can you go back to the last slide? Last slide. Yeah. No, before this. From this, we get that the energy or the energy dissipated by the brown dwarf is 1.9 into 10 raised to the power 4 watts. And for the next calculation, if we do the same thing for Sirius, we get that it is 1.4 into 10 raised to the power 7 watts. From this, we can infer that the energy we receive from Sirius is 1,000 times more than than that what we receive from the brown dwarf, which from this we can also say that we probably cannot see it by our naked eyes.
So for the conclusion of the story, we basically questioned the accuracy of the story. So these were our findings. Using Kepler's law, which we learned in our first astronomy session, the values given in the story were completely accurate. The nearest brown dwarf to the fictional Earth in the story was around 3,000 AU away. However, as Angela said, this is not accurate when we refer it to the real Earth, which if we take the distance between the nearest brown dwarf to the real Earth, is 4 lakh AU away. The temperature given in the story is also accurate. Based on the calculations related to luminosity, it probably cannot be seen from Earth with the naked eye, as it's 1,000 times less bright than Sirius. Thus, although the story holds true to information provided in the text, it's not an accurate representation of the actual circumstances of Earth in our universe.
Now we would like to thank our teachers and our TAs, Professor Soros sir and Professor Soshin Konar, who are not here right now, Umang sir, Anand sir, Abir is not here, Aditya and Tejas, and Ayush, whose name is not on the PPT for some reason. We could not have done this without you, genuinely. Thank you for teaching us. That's it. For questions, by the way? Yeah.
Someone is up. You
go
okay,
ahead.
so can you please go on the calculation slide?
Sure. Go back. Which calculation, by the way? The first
Um,
question or the second question?
First question. Yes, this.
Right.
Yes, this. So you also mentioned that by the Stephen Boltzmann law, you can also predict or determine the lifespan of a star. So how can you can you please explain how will you determine the lifespan?
What I said was that you know how energy and temperature are directly proportionate. So if we know the energy that is radiated by a star, scientists, people who've actually done this stuff before, can figure out the temperature of the star, and by that maybe the lifespan, eventually.
Okay.
Hello. Great presentation, guys. Anshul started the entire talk by saying there's a gravitational tsunami that hit something. What is a gravitational tsunami?
There was a supernova burst.
Right.
So,
What is the tsunami context here?
so the tsunami just causes the death of our main character. That's the only part it plays.
I think it's a gravitational wave burst, which also led to high levels of hard radiation, which is what caused the death of our protagonist.
Right. What is the wave in? What is the wave in?
It's not mentioned in the story, but we're guessing it's in gamma rays because it's a supernova burst.
Oh, okay. Well, okay.
It is mentioned in the story. It is a gamma ray burst and a supernova, constantly.
Okay, cool. Thank you.
More questions? Do you have any more questions? Okay. All right. Thank you, guys. So with this, we come to the last. This was the last presentation for the astronomy module. Before that, we disperse for a short break. We'll resume at sharp 5. But before that, can I request every one of you to come for a group photograph? Astronomy kids and the TAs and the TFs also. We meet at sharp 5 for QBio.
This is my evolutionary processes. Can you go to the next slide? Thank you. Wait, okay. So in 2019, the Aldabra rail bird was confirmed, a bird which was confirmed to be previously extinct, was brought back into existence due to speciation of a species under the same taxa. Following this discovery, scientists have been wondering, would it be possible for them to bring other animals as well as plants back into existence, especially the dodo bird, which has been believed to be extinct since the 16th century. This is also very beneficial because this would allow us to bring several important medicinal plants back into existence, along with improving our ecosystems. So our team Quant Squad, we are basically analyzing if such a thing is possible, what are the most important parameters for us to consider, as well as what is the typical amount of time something like a project or experiment like this would take. Can you go to the next slide? Okay. And this is our research question. That is it possible for one species to evolve entirely into another and go extinct itself? Thank you. I'll pass this on to Mannat.
I will now discuss our experimental design and the parameters we used to set up our experiment. The parameters we have taken into consideration are 1, stability of vegetation, which is essentially the chance of survival of either species when the vegetation is stable and when the species population is not stable. Secondly, we are looking into the energy provided by both plants. We're trying to see what would happen if one of the plants provides less energy than the other. When a newly speciated species eat each other's vegetation, they evolve back into that species again. So our experimental design is as follows. We start off with one species of fish, which is cyan colored for our case, and 2 types of plants, plant A and plant B. The 2 different plants are stationary and are on the opposite sides of the barrier. The fishes can swim in any direction and can only cross the barrier through the gap. Continuing with the previous slide, if a cyan fish eats a certain amount of plant B, it turns into a pink fish. If a pink fish crosses the barrier and eats a certain amount of plant A, it turns into a cyan fish. And finally, plant A and plant B die, essentially get eaten, if a certain number of fishes cross it. Reiterating on our hypothesis, we know that it is not possible for a species to entirely evolve into another and go extinct itself. I'll now hand it over to Arnav.
So now I'm going to talk about the results of our model. So we use the NetLogo software to create this model, and we have coded this model through by scratch. So here we start with 35 cyan fish, and there are two types of plants. This is plant A, and this is plant B. There's this barrier dividing these plants, and there's a small gap, so the fish can pass through it. So our model, what it does is that when the cyan fish pass through it, and when they eat approximately 3 plant B, they turn into pink color. And when the pink color fish cross back and eat plant A approximately 3 times, then they turn back to the color cyan. These are the buttons. This setups the model, and this enables the program to run. This tells us the current value of the cyan fish, and this is the graph. Could you skip? So these are the values that we are left in the end of 10,000 years. And now we'll have the graph. Next slide. So this is the graph of the data we got from the model. On the x-axis is the years, and we took 10,000 years to 10,000 years of data. And on the y-axis, we have the number of fish. The cyan-colored line represents the number of cyan-colored fish, and the pink-colored line represents the number of pink-colored fish. Could you go back? Yeah. So here we can see there are symmetrical oscillations in the graph, and this is due to we are using essential parameters and using a fixed number of fish, which gives us this pattern of symmetrical oscillations. Over to Ria for the conclusion.
So coming to the conclusion of our project, we're going to see what all results our graph implied. So we came to 3 major conclusions. The first one is that out of several runs that we took of the model that we made, the one displayed, there was no instance in which the cyan fish, which is the original population, it died out. There was always, cyan fish and pink fish were both alive all throughout. The second is that the mean of cyan fish to pink fish remained relatively stable throughout, as Arnav also spoke about this earlier, and they exhibited a near symmetrical distribution about the mean. Lastly, we can say that our hypothesis was correct and that one species did not go extinct as it evolved into another. Coming to the skills that we learned throughout this month-long project, the first one is obviously NetLogo coding. So this code that we had made for the model was built from scratch. Apart from that, we learned incorporation of computation into biological systems, learning how to be more attentive to other ideas, learning how to cooperate with others, being patient, not getting frustrated, and some of the most important 21st century skills, critical thinking and communication.
So I'd like to highlight that although our hypothesis worked out under the given parameters, I'd like to highlight something using this beautiful quote from Professor Vijay Raghavan. That is, there are several possibilities and opportunities in topics around evolution. And so, although things worked out for our hypothesis, there can be several arguments that prove that our hypothesis might or might not be wrong. And these are all the sources that we cited for our presentation. Can you move to the next slide? And these are the definitions of some important terms we used in our presentation. We'll go back to that during the question and answer session, but can you move to the next slide? And thank you so much for attending. And we'd like to thank Professor Sugat Dabholkar, Professor Sudeep Tang, our research scholar Chandrakant, and our senior learning partner Karan Kumar for all of their contributions and guidance. Thank you so much. Can you move back? So does anyone have any questions? Questions? Oh yeah, Ved. He has a question. Sorry.
Given the fact that in a normal ecosystem there are far more factors than in your model, isn't it unlikely that you can just get a species back from extinction by just evolution, since it'll probably diverge in a different way given how many factors there are?
Yeah, that's a very good question. Manath, can you move the bibliography slide? Right, so if you check I'll send you the link for the dodo bird article, but basically what they're trying to do is, they're trying to create the most ideal ecosystem to force extinction, and that's what evolution, I'm so sorry, and that's what you're focusing on.
Very interesting, thank you.
Thank you.
Any more questions?
I think Punya, oh no, okay, I'm scratching your neck, okay. Angela.
So the case that you took, the fishes evolved, like the cyan fishes evolved into the pink fishes and the pink fishes evolved back into the cyan fishes. But if the evolution is only one way, then possibly the pink fishes or the cyan fishes will go extinct. What do you think about that?
That's a very good question. Do you guys want to answer? Should I? Okay.
So the thing is, with the cyan fish, if you have an only one-way evolution, there's like a guaranteed chance that they will turn into pink fish, obviously, which sort of kind of guarantees that the cyan fish will go extinct. But since we're not sure, there are mutations. Firstly, there are not only mutations, but there are certain factors that don't get inherited, and evolution is never one way; it diverges a lot. So we try to keep that open by bilateral evolution.
Okay, thank you.
I just like to add on to your question. So we chose fish for our model because we were inspired by the key-killed fish and because they're very easy to speciate. So like in our model, we are assuming that these species have just recently speciated. So I feel it's very possible for them to like evolve back into the other using changes in their vegetation.
Okay, thank you.
Thank you.
Thank you, Quant Squad. And can we have a huge round of applause for them? And next up, we have Quant Bio Challenges with Pranav, Anshul, Angela, and Ananya.
Should I start? Should I start? Good evening, everyone. Today we will be talking about eutrophication. Our team, the Quant Bio Challenger, consists of Pranav, Ananya, Anshul, and myself, Angela. So in our presentation, we'll be presenting. Can you move on? We'll be presenting a small backstory, introducing our topic and the aim. Then we'll be going through some graphs and experimental setup to explain our experiment, and we'll be wrapping up with a conclusion. So now over to Pranav.
Okay, can everyone hear me? Yeah. So to begin this presentation, let's start with a small backstory to understand why this is important in the first place. So our story begins in a small settlement. And as this small society started to develop and improve, the population started booming like crazy. And what does this imply? That the food is turning short. So like there were food shortages and people were going hungry as well. And this started to worry people, and even the greatest thinkers started to predict that the famines they started to predict the end of humanity through famine. But then there's something that they did not predict, something they could not expect at all. The development of science and technology allowed the humanity to produce a magical ingredient that allowed them to improve their produce drastically. And this completely changed the tables. It went from shortages to a surplus of food. But then, what they did not expect for this magical ingredient was the dark side. In the dark side, they did not see that as the water from rain and the irrigation runoff, as this magical ingredient, so-called magical ingredient, washed into the rivers and lakes, it caused something absolutely terrible. It disrupted the entire ecological balance of the water ecosystem. And it turned the lakes murky, disgusting, and into an utter state of disaster. The fishes were choking. So what caused this? And I'll let Ananya explain this phenomenon. And this fate does not only apply to this hypothetical settlement. Rather, this is the situation for many of the water bodies that are surrounded by urban settlements. And this phenomenon is called eutrophication.
Right. Eutrophication is basically the increase in amount of algae and plants over the surface of lakes and coastal waters. And this is basically because when the environment becomes enriched with nutrients like phosphorus and nitrogen. And phosphorus and nitrogen are basically fertilizers. So get that picture. Right. So as you can see, the fertilizers runoff causes, okay, so because of the phosphorus and nitrogen, there's an overabundance of algae, and algae blocks the sunlight, which leads, which basically the aquatic life, plant life starts suffocating because they can't photosynthesize, and therefore they die and they decompose, and this leads to release of large amount of carbon dioxide, hence destroying the ecosystem. And also eutrophication lowers the pH of salt water, which is also a process known as ocean acidification. Aim. So right, so the aim of our project is basically investigating the impact of eutrophication on aquatic life and controlling the factors to study the growth of algae and its effects on a pond.
So there are certain parameters that we are varying to simulate this project. So the first parameter that we are simulating is pH, because different pH levels will lead to different rates of reaction in algae and in aquatic life. So that's our first factor. The second one is temperature, because increased temperatures lead to higher rates of photosynthesis and rates of reaction. So the rate of algae growth will be much higher. And the last two factors, which are the most important, are the phosphate and nitrate levels, because these are the compounds that are found in industrial fertilizers, which lead to the rapid eutrophication. Continue. Next. So the experimental setup we had for our NetLogo model was based on simulating the conditions of a normal pond. So most ponds have a pH within the range of 6 to 9. And a temperature between 10 and 30 degrees Celsius. The nitrate concentrations and phosphate concentrations can vary between 5 and 20 milligrams per liter and 0.005 and 0.05 milligrams per liter respectively. So to understand the effects of each of these factors on the rate of algae growth, we basically made graphs and we created functions to help model this growth. So firstly, for temperature, up till approximately 30 degrees Celsius, the rate of algae growth increases because photosynthesis rate increases. But after that, the enzymes in algae start to denature, and therefore the growth slows down. For pH, as pH increases and the lake conditions become more alkaline, the rate of algae growth increases up till a certain optimal point, after which it decreases again. Nitrate and phosphate, we discovered, have a majorly linear relation with the rate of algae growth, because as they increase, since they're essential nutrients, the more of them they are, the greater the rate of algae growth. So these were the parameters that we controlled during our experiment to understand how algae growth would change. But now, this graph basically models the result of the actual algae growth on the pond ecosystem. So as algae grows, it covers the surface of the lake, and as Pranav and Ananya explained, it causes aquatic plants to die and oxygen levels to fall. So this graph basically models the relation between algae growth and oxygen levels, because initially, because of higher levels of photosynthesis, it increases, but as the aquatic plants die, it decreases. So this is the video of our NetLogo model, which we made to simulate this process. You need to... show it on your laptop.
How do I show it on my laptop? I can't connect this shit.
Just show it on your laptop.
You have to share the access. It should be an open link. No? That's why it is happening.
But what did she just
Request access, and and whoever has the rights, just accept it. Or you can log in. Can we skip it? Just talk about it. Okay, then. Anyone else?
It's the actual model which is most of the work which is done. Yeah, so I'll quickly explain the model. So the sliders you have on the left side basically allow you to vary the pH, temperature, phosphate and nitrate levels, and this is the simulation of the pond. So based on these parameters, the algae grows at a different rate. And this graph, it's not working right now, but it simulates the oxygen levels as the algae grows. Yeah. Go to the next slide.
Okay. So I'll just explain a bit of the components of the code. So we had 4 global variables for our 4 parameters, which was for temperature, nitrates, phosphorus, and pH. So for each of these things, we corresponded another value for probability, which was between 0 to 1. So we had this conditional for temperature, that if it's more than 30 degrees, we'd have this, this expression find the probability. And if it's less than 30 and above 20, we would have the probability be equated using this one, which we showed before as well. And this is, the nitrate one is far more simpler because it's just a linear expression. And then phosphorus. And we rounded these values since these functions provide like huge decimals. So we rounded to like the precision of 2. And then we calculated the probability of spread by multiplying the probability of each of these parameters and to the multiplying it to 100 to provide a percentage. And then after that, we set the oxygen using the percentage covered, which was calculated using another line of code, which is not here. And that produced a graph like this, which is kind of similar to the one we expected.
So to conclude, rate of algae growth is directly proportional to temperature and pH till the optimal value is reached, but then the behavior of the graph starts to change. This change can be easily explained by environmental factors such as limited density and limited food resources and nutrients in the pond. So also we notice that the oxygen level first starts to increase when the algae starts to grow due to the excess oxygen produced by the algae, but then the algae starts to choke off other aquatic plants and die off and produce more carbon dioxide than it does oxygen, and then the rate of oxygen level starts to decrease. Next slide, please. Next slide. So in our model, there were some problems such as the equation of the parameters were based on hypothetical or ideal situations, which we don't know if they actually apply for real life values. So in our next step, we want to confirm these equations by validating them with real life data. We also want to, in the oxygen levels, we monitored it using an arbitrary unit. So we want to change that with actual units. And in the future, we also want to create an index that describes how favorable these conditions are for aquatic plant life and animal life. Next slide, please. So these are the resources that we used. Next. So thank you, everyone, and we would especially like to thank our teachers and TAs for guiding us through this process, helping us with the coding, and helping us come to a conclusion. Yeah, now we are open for questions.
Okay, thank you.
Thank you. Thank you, guys. Now, can we have the next group? We have creative thinkers, where we have Mahi, Anya, and Sheetal. Can we have a round of applause for them?
Good evening all. Me Sheetal along with my pod members Mahi and Anya going to present a presentation on topic maximizing the product formation of a chemical reaction.
So what we are modeling and why? Our group's initial aim was to model the contact process. The contact process is the process of producing sulfuric acid in the industry. So sulfuric acid basically used in the manufacture of paints, detergents, and most importantly fertilizers. The contact process has basically 3 stages. In the first stage, sulfur and oxygen react to form sulfur dioxide. In the second stage, sulfur dioxide and oxygen react to form sulfur trioxide. And in the third and last stage, sulfur trioxide and water reacts to form sulfuric acid.
However, due to the shortage of time, we decided to make a model on stage 1 of contact process. As a part of this, we will change variables like volume of changing the edge size and concentration of the both reactants by changing the number of sulfur atoms and the oxygen molecules. And through this model, we will able to see that how the pressure of the system and the number of reactants affect the rate of reaction that is taking place. So we have a future plan, like we will aim to make a model based on our second and third stage. And another future plan is to see how the changing temperature can affect the rate of reaction or the change of production each minute.
Now, the question arises, how is this model related to biology? So, sulfuric acid helps in the production of fertilizers, which help in the production of plants and crops. So by creating a model on the contact process, we would be able to understand the optimum environment for the maximum amount of sulfuric acid to be created. So we are able to create enough fertilizers to grow crop to feed the continuously growing population.
So I will tell you my research questions and the variables. Like my research question is like, how does changing the volume of system and the concentration of the reactants affect the rate of reaction? My independent variable is like the variable which I will change, the like volume of the system or the volume of reactants. And our dependent variable is the variable which are measuring, like the rate of reaction.
So our hypothesis was, at controlled values of the concentration of temperature and reactants, if we increase the pressure, the area will decrease and the rate of reaction will increase. As the particles have lesser area to move, so the frequency of successful collision will become high. Next slide. Now let's move on to the model. So through this model, we are going to see the process of maximizing the product of a chemical reaction. In this model, the blue ball represents sulfur atoms and red ball represents oxygen molecules. So as we all know that sulfur and oxygen react to form sulfuric acid. Now we are going to see different cases. So in the first case, basically we are increasing the volume of yellow edge. So when we're increasing the volume, the area is decreasing and the rate of reaction is increasing as the particles have lesser area. To move, so the frequency of successful collision become high. Now, when we are decreasing the volume, the area is increasing. So the rate of reaction is decreasing as the particles have large area to move. So the frequency of successful collision becomes low. Now, in the second case, when we're increasing the number of oxygen molecules and sulfur atoms, the rate of reaction is also increasing because as we all can see that there are more number of reactants to react. And in the it's not showing that. Now, in the fourth and last stage, we will see that when we are decreasing the number of oxygen molecules and sulfur atoms, the rate of reaction is also decreasing as we have less number of reactants to react now. So this was all about for this model.
So after seeing the model, like we did some experiment, like the changing the value of number of reactants and the volume. So we did 3 trials, and our hypothesis came true as we predicted. When volume of the yellow edge is increased, then the rate of reaction also increases. Like if the volume of yellow edge is increased, so the volume of black square decreases. This is evident when the volume increased from 3 to 20, then the rate of reaction also increased from 0.0395 to 0.9007. And the same we did with reactants also. We changed the number of sulfur atoms and the oxygen molecules. And our hypothesis came true here also. Like as we predicted, when the number of reactants increases, then the rate of reaction also increases. This is the evident when the reactants increase from 5.7 to 2020. The rate of reaction also increased from 0.0332 to 0.1486.
So thank you everyone for giving us your precious time.
Do we have any questions? Oh, yes.
Hi, thank you guys. So I don't know anything about what you did, but that was super interesting. I just wanted to know what platform did you code on, and could you talk a little bit about that?
So we use NetLogo. Yeah. So we use NetLogo to. Yeah.
Thank you, guys. Thank you so much. Can we have a round of applause for them? Okay, next up we have the pollinators, where we have Shraddha, Avi, and Ravish. Can we have an applause for them, please?
Hi, Mom. Hello.
Recording in progress.
Hello. Okay, good evening everyone. We are the pollinators, Shraddha, Avi, and I am Ravish. And today we are going to present pollination, an ecological model. So, we're going to start the presentation by saying, wait guys, do you hear that sound? Oh my god, a bee just took my pollen. Okay.
So, any clue as to what happened? Anyone? We'll give you a chocolate if you answer. She got points for being my friend. Okay. Next slide. So, what is pollination? Pollination is the transfer of pollen from the male from a flower to another flower, and it leads to formation of seeds, which in turn leads to survival of the plant race. And why is it important? Because without it, there wouldn't be, survival of the plant race. And there are different types of pollinators in nature. You have wind, you have water, and you have insects. And in insects, you have different types of insects. You have butterflies, you have honeybees. But why do we choose honeybees specifically? Why are they important?
So as she said that we chose bees because bees have tiny hairs on their body, which allows the pollen to easily stick on them and makes them a very good pollinator. And bees also require nectar from the flower in multiple ways. That is, they require it for their home, they require it for making offsprings, and they require it for food as well. So that's why bees are a very good pollinator. And why should we study pollination? So as she said, without pollination, the ecosystem would collapse and we would not be able to, the herbivore population would decline and we would not be, the ecosystem would entirely be destroyed. So our research question was that how will the bee population affect the rate of pollination? So we hypothesized that the bee population would affect the rate of pollination in a direct variation. That is that the graph will be linear, and as the bee population will increase, the flower population will also increase. So in our model, we chose to add 4 variables, that is the initial bee population, initial flower population, bee lifespan, and flower spawn probability. But we chose to vary the bee population since that is what we are studying. We will also measure the flower population, which is essentially the rate of pollination. What we did in the study was we ran the model multiple times and recorded the population of the flowers and as they were changing over time with the bee population. Over to Ravish.
Okay, so this is a video of our model. So we created this model using a platform known as Unity. So we can create a more realistic and lifelike simulation of the process of pollination. So as you can see in the video, there are multiple parameters, like Avi mentioned before, that we can vary, such as the bee lifespan, flower spawn probability, the initial flowers, and the initial bees. So how this model works is, there is a hive at the center of the screen. And the second we click the start button, there's going to be multiple bees flying to nearby flowers. So you can see, when we click the setup button, there's going to be a bunch of flowers that appear and a bunch of bees that appear. So the bees are going to be flying towards the flowers, and we're going to see that each bee has one role. This role is to gather nectar from any flower and bring it back to the hive. But a consequence of when a bee goes to a flower, as Avi also mentioned before, is that the pollen gets stuck to the hair on the bees, so that the next flower they go to, the pollen that's stuck on them might get released into it. So that's why we have a probability instead of giving it all the time, so that we can make it more realistic, since this process won't happen every time. And when the bee goes to a flower, we can see that sometimes there's a flower that's born in a new area, which is, like Shraddha showed in our earlier presentation, the flowers will come around and the seeds will germinate into new flowers. So in here, we can see that the flower population increases with pollination. The bee population increases since the nectar brought by the flowers into the hive is used to create new bees, because bees incubate inside honey. And then we can see that the bee population also reduces because of the bees. Each bee has a lifespan that we've set through the code. So in the next slide, we're going to show a snippet of the code that we used, which we wrote in the language of C#, which is used by Unity. So in this snippet of code, what we've done is, this is part of the bees movement script. So in the first half of the code, we use the math arc tan function so that we can calculate the angle theta so that the bee can move towards the target flower. And then in the and we also moved it by a rotation speed and movement speed towards the correct direction. And then secondly, in the second half of the code, we kept on measuring the distance between the bee and the target flower, so that when it's less than a certain threshold, we're going to do a few functions, which is pollinate the flower, we're going to set the target destination as the hive, and we're going to start drinking nectar, and we are going to equip the bee with pollen. So now we're going to show the graph that we've plotted, and Shraddha's going to speak about it.
So these are results. As we hypothesize, it is not entirely true that it is directly proportional to the bee population. However, it is an positive, whatever. It is an exponential curve, and just go on.
Yeah. So.
Okay. Further, I'd like to stress to whoever is going to take our model as a reference for future investigation that this is not entirely accurate, as it does not take into account a lot of parameters like flower lifespan and the influence of climate. Thus, whoever who is going to use this model as reference, we'd like them to add in more parameters to make it more accurate and more realistic. Thank you.
Okay. Now I would like to give a big thank you, all our gratitude towards these people who helped us along the way. We have Professor Sugat.
We have Professor Sudipto, and we have our TA Chandrakant here, who helped us a lot during this journey, and they taught us what a computation model is and everything that we know about quantitative biology right now.
We love you so much, Chandrakant sir. Thank you so much.
Thank you.
Do we have any questions for them?
Hi, great talk. I wanted to ask, what was the rationale behind behind hypothesizing that bee density and flower density would be directly proportional? Like, to my mind, it feels like it should increase and then saturate at one point.
Well, our intuition was that since there's going to be more bees, there's going to be more pollen in a direct variation. More bees, more pollen. So that'll give a direct proportion. But as you saw from the exponential graph, that's clearly not true. So even your intuition was a bit flawed, since it was not like that, it was like that. So I guess reality is not always what we expect.
Right. Okay.
Thank you, sir.
Sorry. No, this is less of a question and just interesting point. So you guys talked about bees versus butterflies as pollinators, but there's this very cool new research that came out, I think in March, that finds that moths are actually more efficient pollinators at night than bees are during the day. And yeah, that's just some reading if you're interested.
Okay, thank you so much for telling us that.
You can't hear. Yeah, next time we make a model, we'll use moths instead.
Thank you.
Thank you.
Thank you, Pauline. Thank you, pollinators. Can we have a huge round of applause for them? Next up, we have arsonists, where we have Nishant, Sonakshi, Anamika, and Masoom. I'll ask Anupama to do that.
Just check if the video is working first. Our video is not working. We're just checking model children.
Where is it?
Just can you just say this open it? Just yeah.
Okay.
I downloaded it before. Can you go to the minimize this. Minimize. So do you want me to sit here? So you all can do the shifting? Okay, ठीक है.
Everyone, I am Masum and these are my team. On coral reef. When you hear the word coral reef, what does it mean? Basically, coral reef means an underwater ecosystem characterized by reef building corals. Coral bleaching. Coral bleaching is a process when corals expels the algae and because corals expels the algae, it was present on them.
So I am going to show you the importance of corals and coral bleaching. So coral reef are important for marine lives as they provide habitat for a large variety of marine life. They reduce wave energy, protecting the shorelines and coastal infrastructure. Healthy reefs can reduce wave energy up to 97%. Coral reef play role in carbon storage and climate regulation. They are a highly efficient carbon sink. This was the importance of coral reef. Now let's move on to the importance of coral bleaching. Coral bleaching matters because once they die, they rarely come back. With few corals surviving, they struggle to reproduce and enter reef ecosystem becomes worse. So, hypothesis. Coral does not have any color. They look colorful because algae have symbiotic relationship with coral. But when the temperature changes, the coral expels the algae and they changes its color into white. And when coral bleaches, they do not die, they just changes their color. And with higher temperature in the sea water, the coral bleaches, the increase of coral bleaches happen. Hand over to Masum.
There are two parameters for our model. First one, rise in temperature. It is independent, and the second one is number of corals bleached. It is dependent. Basically, they are directly proportional.
Hi. So now I'll explain to you what our model actually looks like. This is the model that we've created in NetLogo, which is basically an agent-based system for modeling. It's very easy. Anybody can learn to code over there. So let me just get the pointer back. I love that pointer. Yeah. So from this snapshot of the model, firstly, we'll just look at it and then we'll go to the actual working of the model. We see in this square are the corals that we've represented. These are multicolored corals. We have two parameters. Number one is the density, and by density I mean to imply the density as in the population of corals existing, and change in temperature, which is basically the change in sea surface temperature. We've given the parameters for 5 changes in temperature from 1 degree, from an increase in 1 degree Fahrenheit to an increase in 5 degree Fahrenheit. And this is going to be the box for our result, which is the percentage of bleached corals. Now let's go and actually see how this plans out into the actual model. Right, so this is our model. Firstly, we'll test out the density parameter. When I decrease the density to, let's say, around 20%, and then set up, you'll see that the number of corals on the screen actually decrease. And we already saw it in the increased part. Now let's test out the temperature parameter. Right. So when I take the temperature back to 1 degree increase, a 1 degree Fahrenheit increase, set up and go, you'll see that over here, our result shows around 14% bleach in the corals. The white part of the corals over here, as you can see, represent the bleached corals. I'll show it to you in an increased temperature right now. When the temperature is approximately when there is an increase in 5 degree Fahrenheit and we set up and go, you'll see that there is an approximate 58.79% increase in temperature. Now let's see if the density parameter has a big role in our model or not. If I decrease the density to around 20%, remember that when we tried it with an 80% density, our percentage of bleached corals for 1 degree temperature, or let's say for 5 degree temperature only, was 58%. Now for 1 degree, for 5 degree temperature with a lesser density, if I set up and start again, it's still approximately the same, which is 61.96, I think. Yeah. So this is just to show that density in our model currently does not have a very significant effect. What I would like to emphasize on right now is the fact that in our model, the normal speed is around in 1 tick. So this entire process is happening in 1 tick. If I continue just clicking on go, you'll see that the entire thing gets bleached. What this means to imply is what my teammates have already said about the importance of corals and why we should care about them. If corals bleach, we have learned that we have learned that around 25% of entire marine life depends on corals. If they die, an entire ecosystem collapses. That is why we should care about them. From this data and from the other data that we've generated, we've made 5 graphs with varying density and at all 5 temperatures. So I'll just take you back to that and Nishant will explain that to you. Right.
So here we've plotted the percentage of coral bleached against the change in temperature at varying densities. So the percentage of corals bleached is on the y-axis and the change in temperatures and on the x-axis. So this is for 20% density of coral. And for 40%, notice that it's the exact same curve and the same for 60% too. And it's also the same for 80% and 100%. This confirms our original hypothesis that the density does not matter and the graph remains the same.
So the model tells us that if the temperature increases, the more coral get bleached, and if the temperature decreases, the less coral get bleached. So basically it says that they are directly proportional to each other. Density of coral has no significant effect on the number of coral bleached. For a given change in the temperature, the proportion of the coral getting bleached remains same. Coral bleaching matters because it is not an isolated phenomenon.
Lastly, we would like to thank our teachers, Sugat sir and Sudipto sir, and our TF, Shreya. We would also like to thank Chandrakant sir for helping us with the motivation along the process. We could not have done this without you. Thank you so much. Thank you. This is our project. Again, now open for questions.
Any questions?
So coral bleaching occurs due to algae dying out. So how do algae help the corals? So why do corals die out if the algae die out?
Corals and algae basically have a symbiotic relationship going on. I think corals help in, algae, zooxanthellae, the example that we've used, they help in algae like getting the nutrients in food, they prepare it. So that's the basic role. When they die out, so basically corals don't originally have color. It is the algae that's giving them color as well. It's their color. When they die out, the algae gets expelled, and that's why corals lose their color. What we mean to show by our project is with the an increased and a constant increase in temperature, if it persists, if it's prolonged, then it's actually going to affect the system. That's the basic purpose of our model.
So you're saying that algae provide the nutrients for the corals to survive?
Yeah.
Okay, thank you.
Thank you. Sorry. Thank you, the arsonists. Next up, we have Team Alpha with Nime and Agastya. Can we have a round of applause for them?
So we were examining the efficacy of biocontrols in mitigating invasive species and preserving keystone species, a ecological microcosm of crabs, ants, and microwasps in Christmas Island. And our team's name is Pod Alpha, and it consists of me, myself, Agastya, and Nimaya. So Nimaya, you could go ahead.
Greetings, everyone. So we will be starting by talking, by introducing the problem that we try to basically look into. So as we know, as humans explore the world, a lot of times we have, a lot of species that go along with them. And one of the interesting cases of that is, how sometimes we accidentally end up putting invasive species in different ecosystems to our own. So before we go any forward, I would like to talk about the term invasive species because it is something that we will talk about a lot. So invasive species is essentially any species that does not belong to an ecosystem, but once it goes there, it just takes over the ecosystem and just establishes superiority in a sense. So one case of this was Christmas Island. So we have the red crabs in Christmas Island, which work as a keystone species. Now that is another big word. Keystone species is basically any species that just maintains, the general based on which the entire ecosystem is built around. And so we had these red crabs in Christmas Island, and then humans accidentally ended up introducing these crazy yellow ants. And these crazy yellow ants are predators of the crabs. They spray formic acid in their eyes, blinding them, and into their joints, immobilizing them. And as you can tell, if any organism is blinded and immobilized, its chances of surviving will definitely lower by a big amount. So moving on, so to stop this issue, some methods have been used so far. So mainly the practice of poison baiting was used to try to curb the population of the yellow ants. However, the issue with the method was that it was very labor intensive due to the island's remote location. Besides, it is only a temporary solution because the ants move to remote and inaccessible areas, and after a while they move back, and this baiting process has to be done again. Next slide. So, so what is biocontrol? So basically, now as we see in the news, the next method that was proposed to deal with the situation was biocontrol. So biocontrol is defined as biocontrol or biological control is a method of controlling pests affecting animals or plants by using other organisms. So if you have an invasive species and you introduce an organism that basically kills or just negatively affects the population of the invasive species, you can essentially get away the invasive species. Next. So how can we use biocontrol to address this problem? So basically, biocontrol was proposed as a solution to this issue of yellow crazy ants on Christmas Island. The plan was to introduce a micro wasp. You can read the scientific name for yourself, which is a tiny yellow insect from Malaysia that is around 2 millimeters long. And this basically the wasp negatively affects the population of the yellow ants. So we thought that it was thought that this should be able to reduce the population of yellow ants. And this is basically what we're doing in our project. We are finding out how effective this biocontrol method is expected to be. So we shall now be moving on to talk about a research question. So our research question is, how does the introduction of a new biocontrol species into an ecosystem regulate the population of invasive species and consequently maintain the density of keystone species? So while doing our research, we had variables. So as you can see, there are two terms that have been used here. So control variables and changing variables. So control variables is anything that we keep fixed, right? So it's something that is just embedded in the code. We can't really change those while we were creating our model. So we kept the probability of wasp killing ant constant at 7%. The reproductive rates of crabs and micro wasps are 1%. And the reproductive rate of ants is 2%. So because they are the invasive species, they have a much higher reproductive rate, which is why they are the invasive species. And the changing variables. So see, the thing about these variables is that in our model, depending on what initial situation we want, we can actually change these. So Agastya will just be showing that to you in a moment. So the changing variables we had were the initial number of red crabs, crazy ants, and micro wasps, plus the probability of ant killing crab. So what method did we use to basically figure out the answer to a research question? So we used modeling, as we just told you. That is just basically simulating the ecosystem. For that, we used a software called NetLogo. And using NetLogo, we simulated the dynamics of the ecosystem on Christmas Island following the introductions of the micro wasps. And then we looked at different combinations of initial starting parameters to see what happens in different cases. Now, Agastya will take over and he will explain the model to you.
Currently. Yes. So this is NetLogo, and we have used this to model our ecosystem. And NetLogo is a platform and an interface where we can code and we can create simulations of natural ecosystems. And over here, we can change various parameters using sliders. So we can change the probability of kill, the initial number of ants, the initial number of crabs, the number of wasps, etc. And over here, there are monitors. So with the monitors, we can see in real time as the model is progressing. So the number of crabs, ants, wasps, etc. So yeah. So as I was saying, there are monitors over here, and as the model progresses, we can count the number of crabs, ants, and wasps. And this is also formatted into a graph. So the red line shows the crabs, while the yellow shows the ants. And as I was talking about, this is the NetLogo world, which is basically us modeling an ecosystem. And this is NetLogo world. And now we can press setup. So basically what setup does is it will release the number of ants, crabs and wasps into the ecosystem. And over here, Nime, I think, has already pressed setup. So then he has pressed go. So what go does is it will iterate the whole ecosystem for one tick. And like one tick is just a unit of time that like NetLogo has. However, one iteration or one tick does not tell us much about it. That's why we press go forever. And as we press go forever, we see how the model interacts itself. And I think I've forgotten to mention that the red turtles over here are crabs, while ants are yellow and wasps are brown. So I think Nima started the model. Yes. So as you can see, the number of crabs and ants have both gone down, which is actually very interesting. And eventually at some point, the number of crabs will overtake the number of ants. So I'll just let the model run. Yes. So this model will eventually run till like 400 ticks, and after that it will stop. And as you can see, the number of ants have almost died out, proving that our biocontrol works and it's an effective solution. Yeah. And one more thing I forgot to tell you was that you can increase the speed of the model. So we have placed it on slower so we can see what's happening, but we can increase the number of ticks and the speed of the model as well. Yeah. So as I was saying, the number of crabs have overtaken. Nimai, could you go to the graph? Yeah. So we used several simplifications and assumptions. For example, we didn't include the yellow scale insects and assumed the population of ants was affected negatively by the microwasps at a negative rate. And many other species in the ecosystem may have also had an impact, but in computational modeling, we aim to simplify the model. That's why we didn't consider them. And another thing, we didn't consider metapopulation and other colonies. So we didn't consider migration in this thing. And another thing that we have not written in the slide is that we have not considered energy. So basically, we have not added a death rate, we have added a kill rate instead. So that's something we aim to work on. So Nima, you can move forward. Yeah, so here are results and conclusions. So basically, we ran this for around 3 to 4 trials. And in all of the trials, the crabs eventually overtook the number of ants. And this again proved that the model works and biocontrol is effective. And another thing I wanted to mention is that we had made the model ourselves, and it took us several iterations to make it work. Yeah. So we basically found out that it's likely to work. And we also noticed there was a resurgence in the population of crabs, while the population of ants steeply dropped. So thank you for your time. And we'd like to thank our senior learning partners as well, especially Ms. Sriya and our TF Chandrakant, who gave us several ideas.
Also, the professor, Professor Sugaj and Professor Sudipta Rung, both of them were really helped us out, and all the different things that we were taught in the model were really, really interesting. And I think we would like to thank everyone who was a part of making this happen.
Isn't the risk of adding another organism to kill the invasive species, the organism that you add becomes a new invasive species?
Basically, the organism that we choose to add is chosen very carefully, right? So the reason that we specifically chose the microwasp was only because it does not impact any other species. It does not harm any other species. The only species it is harming is the yellow ant, which is exactly what we wanted. Which is why among like so many organisms possible, this is the one that was chosen. That will definitely have a very small. That will not become an invasive species itself.
Hi. Great talk. So now that you answered why you chose the micro wasp as an effective controller, what according to you would naturally control the micro wasps population on the island?
So so I see in general most organisms when they're in an ecosystem they have a set they have like a general rate, like so in our model like we had shown a 1% reproductive rate for micro wasps, for example. So you would say that why did we just add a reproductive rate and not a death rate? Because we expect that for any organism in general, they will have a slight reproductive rate at least for some time. So because like generally any species in an ecosystem is like kind of regulating, right? Like the numbers don't suddenly just go up or down unless like there's some factor that is affecting them. And as the micro wasp, like it isn't like significantly affected by any of the other species on the island, we didn't expect its population to like suffer any particular like upward or downward changes.
And you don't expect any other population control mechanisms? You only expect it to cycle naturally? Or do you expect something would also control the population?
So just to clarify, you want to ask whether we consider adding like something else to control the population of the micro wasp, right?
No. Is there something already on the island that would aid in the control of the micro wasp population, apart from its own natural cycling, of increasing population, decreasing population?
So I think what you're essentially talking about is a predator, right? So I don't think there are any significant predators to the micro wasp on the island. There might be. We aren't very sure about this answer, but I don't think so.
No, good job.
Thank you, Team Alpha. Next up, we have Pod 2.5, where we have Reyansh, Antra, Shriram, Anjanaya, and Lavanya. Can we have a round of applause for them? Guys.
Recording in progress.
Can you connect this? Oh. You want to start? Hello. May you start?
Hello, hello.
Good evening, everyone. Is this working? Yeah. Good evening, everyone. Our project today is transcontinental transmission, unraveling the impact of travel on viruses spread across continents. Our members. I'm Anjanaya. This is Reyansh, Shriram, Lavanya, and Antra. We have made this project possible only with the help of Professor Sugat, Sudipto, SLPs Ruchita, Karan, and Sedu. Introduction and background.
So our model is an attempt to simulate. Is it working? So our model is an attempt to simulate the case of a viral epidemic involving the concept of a metapopulation using the net logo model, and to potentially predict outcomes to help control such real-life cases. Now, this is a screenshot of our model. To make our model, we've used this programming language called NetLogo, and this is the NetLogo interface. So over here, we've got certain sliders. So these sliders can help us change the input variables of different parameters in order to change the starting conditions and in order to simulate different conditions. This is the graphical representation of our model, and what's happening here is that each individual dot represents a person. The white dot represents unaffected people, the blue dot represents vaccinated people, the green dots represent recovered people, and red dots, which you can't see any of over here, are the infected people. Apart from that, we've also got these 5 charts that show us the output, the result of our model. And we've also got a death counter that counts how many deaths, how many people died because of the infectious disease.
So there are 3 key concepts for this model. Communicable diseases. These are infections that spread from a sick person to a healthy one. Pathogens such as viruses, bacteria and fungi cause these diseases. Metapopulation. Metapopulation is a group of separate populations of the same species which interact to a certain level but not freely. R naught. R naught tells you the average number of people who will contract a contagious disease from one person with that disease. The model and the test cases. Next slide. Yeah. So we have fixed parameters. Yeah. We have fixed parameters which contain of initial people, which will be the people at the beginning of the model, which the initial amount would be 250. The infection chance is the probability of the people getting infected, which would be 40%, and the recovery chance is the probability of the people recovering in the given average recovery time, which would be 40%, and the average recovery time is 110 hours. The average isolation tendency, which means that a person isolates themselves and the infection does not spread. The average isolation tendency would be 5%. The average hospital going tendency to get recovered would be also 5%, and the initial infected people would be 15. And the intra-mobility, which is the communication of people amongst the continents inside the continent, would be 100%. And the variable parameters are the inoculation chance, which basically means that what is the chance of a person getting vaccinated and becoming immune to the virus, and the travel tendency is the ability to travel across the continents. We have 2 continents, and the ability to travel across the continents is adjustable. So those are the variable parameters and the fixed parameters of our model.
So this is a video of our model in action. And as you can see, all these people, they're moving around, they're contracting infections, and then they're recovering.
Yeah, so the hypothesis one is the number of death is inversely proportional to the fraction of population vaccinated in a linear manner. So our analysis, we have taken 3 test cases where the vaccination rate is from 0 to 100 with every 5 intervals. And we can see that it is inversely proportional as the death average reduces as the vaccination rate increases. So our result is, after running the model, we observed that the increasing number of people who are vaccinated, subsequently the death rate goes down. And there are some fluctuations which It's almost a linear relation between the two variables, and hence we can say that our hypothesis is correct. Over to Anjanaya.
Our second hypothesis was the extent of disease transmission is directly proportional to the amount of travel observed within a given time interval. This is our analysis. We took 3 test cases while increasing the travel tendency by 10%. We see that this chart it shows no clear trend, and it shows a lot of fluctuation. Our result, there's a lot of fluctuation in the values of death rate, even though we have taken the average of 3 runs. There's no particular direction in which the death rate trends. There seems to be no obvious relation between the tendency of movement of people and the death rate. Although this seems counterintuitive, one possibility is there is some inaccuracy in the model due to which we did not get the expected results.
Conclusion, making this model provided us with a lot of useful information. We found out the relationship between the vaccination rate, and this is not a perfect model, and we realized our mistakes. Many simplifications were made in this model, but it is still a useful model to study the spread of infectious diseases.
Any questions?
Yeah, hi. Hey, very nice talk. I was wondering if you, I was a bit confused about the geographical area that you were considering. You mentioned that there are 250 people, but are those 250 people spread 1 kilometer apart from each other? Are they as close to each other as they are in this room? I was a bit confused about that.
So when we press the setup button on a model, it just randomly distributes the people across the continent. So there's no particular pattern in it. So we have a different setup every time.
Across an entire continent, so like across a very large area.
So we had 2 continents there, right? I'll just show you.
So it's just 2 separate meta populations. So it can be for anything. It can be between 2 separate continents, between 2 separate countries, between 2 separate cities. So like we can't simulate all the people in the city. We just then scale up that number.
Okay. I mean, yeah, it would actually be nice to try and fix the number of individuals to, I mean, instead of having 250 individuals, if you had a population density, for example, 200 individuals spread in 1 square kilometer or something like that, then what do you reckon your model would look like? Or what your results would look like in terms of transmissibility?
So like then obviously that would depend on the density of people that we've taken. But over here we've assumed that the 2 areas are equal and the number of people in both the areas are equal. So we've taken the same population density for both the continents, for both the separate meta populations.
No, right. I didn't expect you to answer that. It was just, I was just testing how far you would think. But good job, yeah?
Thank you.
Do we have any more questions? Okay.
This is working. Hi. Thanks for that really, really interesting choice of topic and great work. So this is more of a philosophical question, but you said that you found that your hypothesis was correct, right? So would you say that, or would you maybe say that you were unable to prove your hypothesis wrong?
I think we can say that our hypothesis was correct because, like we said that the vaccination rate would be inversely proportional to the number of deaths. So if we increase the vaccination rate, then the number of deaths would go down, and that's what we saw in the model.
Thank you, Pod 2.5. Can we have a round of applause for them? Thank you, guys. The second last presentation for the evening, we have a group called Gamma, where we have Ninad, Satyam and Shreya. Can we have a round of applause for them?
Can I start? Start. Can I start?
Good evening, everyone. We are from Team Gamma, and we have chosen the topic growth of bacteria in presence of bacteria phase. Team members are Shreya.
Satyam, Ninad.
Change. This is the table of content, and we have model description, parameters, finding, and conclusion. Change. Model description. Bacteriophage can affect the growth of bacteria and invade bacteria cell by completely destroying them. As the result, the density of bacteria may decline. So to create this model, we have chosen the software called NetLogo. This model has 2 parameters as well as a graph and an animation. The animation shows the decline and or increase on the number of bacteria in the presence or absence of bacteriophage. So now I will hand it over the mic to Ninad.
Parameters of the model are death rate of bacteriophage, chance of bacteria to die when infected. So here is the base case scenario. In this, we have keep both the parameters in 0, and there would be no chance in the number of bacteria as they are not getting infected by the bacteriophage. So here are both the sliders, both the parameters. Death chance when infected is the death chance of bacteria when infected by bacteriophage. And the second parameter is bacteriophage death rate. The green slider is for bacteria, and the red is for bacteriophage. If you can see the animation in this, the green one is for bacteria and the red one is for bacteriophage. In this, we have kept both the parameters in 0. So there will be both are constant because there is no infection done by the bacteriophage. Test 2. In this, we have kept bacteriophage death rate in 0 and the death chance of bacteria into 50%. In this, you can see the bacteriophage has an increase and the bacteria has a decreased, and due to the loss of infection and no death rate of the bacteria, bacteriophage, so the bacteriophage won't die and they would infect, and they have a 50% chance of bacteria to die. Here's a test sheet. In this, we have kept the bacteriophage death rate into 50% and the death chance of bacteria in 0%. In this, the population of the bacteria is stable and the population of bacteriophage is gone decreased. And in the animation, you can see there are no bacteriophage because they have all died, because they couldn't infect the bacteria, because they were, when they get infected, they can't be died because of the 0%. Here's a test 4. We have kept both the parameters in 50%. In this, we have seen that the bacteria is in stable, and bacteriophage is decreasing, and we think is due to because the 50% death rate of the bacteriophage can kill the half of the bacteriophage, and due to the 50% of the chance of bacteria that only kills the half of the person, but due to the they only infect half of the, so they can't actually cause the infection. Yeah. Here's the extreme scenario. In this, we have kept both the parameters in 100%. And here's the video which would actually Satyam would explain.
We have used a software called as NetLogo to code this. The model is running on a code. This is the code that we are using to make the model functional. The base case, where the chance of bacteria to die when infected and death rate of bacteriophage both are at 0, you can notice that in the graph there is a change. Both the quantities are constant, as well as in the display both the quantities are constant when both the quantities are actually on 0%. Now the second case, when chance of bacteria to die when infected is at 100% and bacteriophage death rate is also at 100%. This is the extreme scenario. In this, it can be noted that bacteria is constant, although there is a decline in the density of bacteriophage. This is the third scenario, in which the chance of bacteria to die when infected is at 50% and bacteriophage death rate is at 0%. In this, it can be noted that there is a decline in the density of bacteria, whereas a huge incline in the density of bacteriophage. Now the fourth test, where chance of bacteria to die when infected is at 0% and bacteriophage death rate is at 50%. In that, we can note that still bacteria is constant, though there is a decline in the density of bacteriophage. And the last case, in which both the quantities are at 50%. We can note that still there's a constantness in the density of bacteria, whereas a decline in the quantity of bacteriophage. Conclusion. This model provides us insightful information about how bacteria and bacteriophage interact. Bacteriophage death rate and possibility of infection caused bacterial death. The model also states this. Our understanding and dynamics of possible application of bacteriophage and bacteria interactions can be improved by further investigation and combination of various other parameters. Thank you. Any questions?
Why did you only use unrealistic numbers in your data survey instead of something more realistic like 10% and 30%? It was always like 0, 100 or like 50-50. Why not something more realistic and closer to what actually happens?
We coded like that the percentage, like we could adjust into the percentage like of 50 or 100 extreme scenario. We could even number that into the like numbers like you said. Yeah, we haven't tested it yet, but we could try that in the model. Hope that answered your. Because it was more easy to explain in anyone, and the actual they are the numbers that have means we have in the percentage, so we can't go more than 100, and the 50% is like a mid margin that can explain what's the between of the both the numbers of the extreme and the lowest.
I'm not sure if you have already said what my answer, what the answer to my question is, but could you please explain what a bacteriophage is?
A bacteriophage is a virus. A bacteriophage is a virus where it kills the bacteria in the presence of where bacteria phages. Like it's simply the, we can say, antibiotic is used.
Okay, so it kills bacteria.
Yeah.
Yeah. Okay. Thank you.
Hi, I have one question. First of all, really great job. I think you did it so systematically with a bunch of different combinations. So that was really nice to see. You already kind of evaded my question by saying you can do more, add more parameters in your conclusion. But I was just curious about why for this project you chose these two parameters and not maybe some of the reproductive or death rates of the bacteria themselves?
In this parameter, we have coded the reproduction part, but we haven't controlled the percentage what's going to be. We have coded that a bacteriophage can, when it infects a bacteria, it reproduces 10. So here you go.
Thank you.
Thank you so much, Ninad, Satyam, and Shreya. Now we have our final group for the evening, which is Q Biochamps, where we have Parimoksha, Om, and Aditya. Can we have a round of applause for them? Just a sec.
Sir, special thanks to Professor Sugat, Professor Sudipto, and our senior learning partner, Santosh.
Well, hello, tired audience. Have you ever been out at night? Did you see a street lamp? Was it a working one? Well, if you have seen a working street lamp, then you must have noticed insects roaming, buzzing around, hypnotized by the light. Well, that's what phototaxis is, which also happens to be our topic. Coincidence? I think not.
So this is our team. This is Om. This is Parimoksha. I am Aditya Chaudhary and our senior learning partner Chandrakant.
Yeah, so basically phototactic behavior in insect is the attraction of insects towards light. So as you can see in the picture too, those bugs are getting attracted towards light. Yeah, so photodactic behavior has two types. One is positive and one is negative. So in positive phototaxis, insects get attracted towards the light, and in the negative phototaxis, insects like go away from the light as they can't like, that reduces the visibility for the predators, and they get saved from them.
Our main focus today will be about positive phototaxis behavior. So our research question says, or our hypothesis says, that more insects are attracted to a brighter light source as compared to a dimmer one. This says that if you have a brighter light source and there are insects in the environment, they'll always go for the brighter light source than going to the dimmer one.
So here's our methodology, which is basically our experimental design. We have kept two variables, number of insects and light sources and their intensities. In our experiment, we are basically focusing on the positive phototaxis, and we have kept the number of insects to 50, and these are the two light sources. This is light source 1 and light source 2. This one is brighter and this one the dimmer one. The setup procedure, this one makes the light intensities according to the sliders and initializes the number of insects. This is a screenshot, and here is a working video of our project. As we can see, more insects are attracted to the brighter light source, and very less insects can be seen around the dimmer one. This is the snippet of our code, which we wrote all by ourselves, and we may have used ChatGPT, we may have not, you'll never know.
Yeah, so we had several trials in that model. So like basically in our first trial, we can see that we have a steep slope starting from 60. Like as you can see over here, it's starting from 60 and goes on like till 60 it was constant, but as you can see on 60 it changes a bit, and the slope becomes much more steep than it was before.
In trial 2, you can see that after 40%, after when the light intensity is 40, the graph becomes steeper, and there are more bugs at 60% or 70 or 80. From 40 to 100, you have more bugs than from 0 to 40.
In trial 3, we can still see the graph rising from the 40, but there's a steep rise from 80 to 100. In all the cases, we can see the graph still rises up to the higher intensity ones.
So our conclusion says that insects may exhibit different phototactic responses based on the intensity of light. The more the intensity, the higher the number of bugs attracted towards it. And this is how we have proved our hypothesis.
So these are some benefits of phototaxis. So first of all, its first benefit of it is navigation. So some insects which use for positive or negative phototaxis, positive phototaxis, use celestial clues as stars, moons and all to look at their home and all. Then the second benefit is nutrition. So basically the insects which use positive phototaxis get the signal from the light that it's a plant or some other insect, so which serves them as their food. Then third is reproduction. So some insects use like light signals to attract their mates and to identify their potential partners. And fourth benefit for it is selecting habitat. So the ones who use positive phototaxis are likely to be in like well lit habitat, which is more helpful for them to get their food and all. And those who use negative phototaxis are likely to be in dark, dim light areas, which protect them from their predators.
So we learned a lot of things about phototaxis. We learned what is phototaxis, types of phototaxis, factors affecting phototaxis, and the effect of light intensity on the number of insects attracted. It was for like the positive phototaxis. Other than that, we also learned how to make a net logo model ourselves and how to conduct experiments.
Thank you so much, and a special thanks to all our learning partners, senior learning partners, to our teacher or professor Sudipta sir and Sugat sir. Yeah, thank you so much.
Any questions?
Hi. Hey, excellent topic. I mean, I'm very glad that you thought about such a topic, which which really interests me because I study bats. So now my question is, I had some questions about your conclusion slide, where you mentioned a lot of benefits of this attraction to light. Okay. So do you think with this increasing amount of lighting in cities, do you think insects would benefit from it? I mean, it's your conclusion seems to gives that idea.
So basically, these are benefits of phototaxis behavior, not the intensity of light.
So if there is, for example, nutrition, as far as I understand, the natural source of light that insects are moving towards is moonlight.
Yeah.
And so I'm a bit confused about how it helps them find food sources.
So basically, like plants, those who have nectars and all, so those are like.
Where benefits and conclusions, and our whole study basically is based on the positive phototaxis. So the negative effects like the predators around the light is also that effective one.
These like phototaxis behavior does not always have benefits. It also has some disadvantages, because like light can not only be their food. It can be any light, right? So it's not like ki. So yeah, but basically the idea is they use light to like locate their food.
So if I understand it correctly, what you're trying to tell me is that a flower attracting its colors is also phototaxis. Okay.
Any questions? Okay.
Thank you.
Thank you.
Thank you. So I have a message from Sugat for all of you guys. Shreya, listen. It's a message from Sugat, okay? So because he had to run off somewhere, so he just sent this. Starting to see biological systems as systems that can be studied quantitatively using computational tools requires a significant shift. This shift is in terms of how we see the biological systems and how we see biological research. I'm pleased that several students in the QBio research pods made this shift. I had wonderful experience learning with them. We learned about a computational modeling approach to study biological systems. In spite of some troubles with a hybrid setup and me not being able to be there in person, I'm really proud of what we have achieved during the summer. And thanks to all the senior learning partners, QBio TAs and the TFs who were in this journey with us. So, big clap. Okay, now a final picture, all the QBio team, TA, TF, instructor, faculty, whoever. Thank you, and we have dinner now at 7:30. This is a special dinner for you guys. And tomorrow we will be giving away all your certificates at 2:30. And we have the morning session at 9:30.